Hello there, and welcome everybody to CDK Day 2023. I will be emceeing track one for you. My name is Michael Liendo. It's going to be an amazing time. I'm super excited. We have a bunch of talented and just overall amazing folks that are going to be giving some great presentations throughout the day. I'm really looking forward to all of the things that you can take away. If you have your notebook, if you have your pen and paper, however you take your notes, go ahead and make sure that you have those on standby because you don't want to miss all the information that's going to be happening. I'm a senior developer advocate over at AWS. You can check me out on my Spanish talk later on track 3. But without further ado, let's go ahead and get some of the formalities out of the way, shall we? I do want to go ahead and thank Arthur for being here today. You can see him over on my right. He is going to be coming here from WIN. We definitely want to say we appreciate them. WIN stands for the Western what are we working? Western Interpreting Network. That's what we have today. Shout out to them. Shout out to AWS, of course. That's where I work. For helping out today and sponsoring. Shout out to HashiCorp for sponsoring. Real quick, before we dive into some of these amazing sessions, and they are really great, I do want to go ahead and mention we have a code of conduct. Okay, CDK.com, CDKday.com/COC, your typical path there to get to our code of conduct. You want to go ahead and check that out. If you haven't already, if you're not already a member, go ahead and get involved in the CDK Slack community. That's where I started. That's where I met amazing folks like Matt Bonig, Matt Coulter. They're all in there, all the big brains, right? You can go ahead and check them out over at cdk.dev. That's where you can find our Slack server, and you can also check out some of the channels that we have there. CDK track 1, 2, 3, etc. Go ahead and just take a moment before we kick off our first amazing speaker for the day, and just take a moment to see what's going on in there. Who knows? You might learn something. But without further ado, I'm not going to delay us too much. I want to go ahead and get an amazing speaker up. This is going to be Takuya Hashimoto, and he's going to be speaking to us today, kicking off track 1, talk 1, CDK 2023. Once again, my name is Michael Liendo. We have ASL interpreters throughout the day. Let's go ahead and get this going. Takuya, it is all on you.
Hi, can you hear me? Hey, okay. Uh, Hi everyone. Today I will talk about the session titled Configure Cross-Account Deployment Using CDK. My name is Takuya Hashimoto. I work at Serverless, a system integrator in Japan and an AWS partner company. I will talk about 3 topics. 1. Overview of the CDK security and safety deep guide. 2. What CDK bootstrap command actually doing? 3. Configure cross-account deployment for CDK project. In today's session, I will describe about how to build an architecture like this diagram. To configure cross-account deployment, the IAM role settings also need to be cross-account. So, today's discussion will primarily focus on the topic. Let's move on to the first topic. What should CDK beginner to learn after going through the tutorial? I personally believe that it's important to deepen one's understanding of the concepts, philosophy, and design behind the CDK. On this view, I recommend reading 2 documents for CDK beginners. First, CDK concepts is the most important. It introduces not only fundamental concepts like apps, stacks, and environments, but also frequently used features when developing with CDK such as aspects, context, and bootstrapping. Second, CDK Security and Safety Deep Guide provides useful information mainly for deploying CDK within your organization. It explains the options available for organizational security and governance without affecting developer productivity. You can see this document on the CDK GitHub repository's wiki page. Some of the content I will be discussing is quoted from this document. If you'd like to know more details, please refer to the original text. What permissions does CDK use during deployment? This diagram explains that. Right side is the default for CDK. For comparison, a simpler one, CLI credentials stack synthesizer, is also shown. The key difference is that the default synthesizer uses assume role. Because of this, the actor executing the deployment doesn't need to have powerful permissions directly in their own credentials. Let's take a closer look at the permissions used by the default synthesizer. Left side is the actor that initiates the deployment. This might be a developer running the CDK CLI directory from a local machine, or it could be a CI/CD service like code pipeline. The actor must have the necessary permissions to initiate the deployment of the CDK project. On the right side of the diagram, it shows the permissions that are actually used during deployment. In CDK, before running the CloudFormation deployment, there might be actions like uploading resources referred to as assets, or looking up existing resources like VPC subnets. The roles named CDK Image Publishing role and CDK File Publishing role are roles used to upload assets before deployment. Once the assets have been uploaded, the actual CloudFormation deployment is carried out. The role named CDK Deploy role is used to execute the deployment API. During deployment, path role is used, and the permissions used for construction. The actor can deploy the CDK project if assume role action is allowed. In other words, if the IAM role is set to trust principals from another account, you can configure cross-account deployments. Summarize the content we've covered so far. First, CDK's default approach makes it easier to migrate to cross-account architecture before deployment are based on assume role and path role. Second, these resources shown in orange box are constructed CDK bootstrap command. Third, it needs to configure IAM roles to trust the principals in another account if configure cross-account deployment. Move on to the next section about CDK bootstrap command. As many of you may know, bootstrap is the process we first execute when starting CDK project. Let's take a closer look at the specific resources the Bootstrap stack creates. By running with the show template option, you can see the Bootstrap stack that the current CDK is using. This code snippet is definition of file publishing role in default Bootstrap stack. This role is one of the permissions used during CDK deployment. When the trusted account parameter is defined, you can see that it's configured to trust that account and allow the assume role action. Let's move on to the actually configuring cross-account deployments. At first, sample code is available on my GitHub repository. I won't go into detail on everything detailed this section. If you want to know more details, please check out my repository. There are 4 points. I will explain 2 of them. 1. Bootstrapping in the target account. 2. The permission that need to be configured for the pipeline. In the target account, you need to allow assume role from pipeline account. To do this, you must run the bootstrap command with the trust option. Here, you instruct it to trust the pipeline account. Next, grant permission for the assume role action to the actual service that carries out the deployment. In this sample, I'm using code build. So we have granted assume role permission to the build project. This no need to specify a particular role ARN. You can use resource tag conditions as shown in orange box. By examining Bootstrap stack, you will see IAM roles that have these tags attached. These 2 points are permission settings you should remember for configuring cross-account deployment. Move on to the conclusion. In this session, I focused on how to configure permissions and looked at how to configure cross-account deployments with CDK. We also understood how CDK bootstrap command relates in cross-account configuration. By understanding what's actually happening behind the scenes, I hope it helps all of you to use CDK even more. Thanks for listening.
Awesome. Thank you so much. And thanks again to our interpreters for just being around with us today. It takes an amazing amount of talent for these individuals. So I really want to give another shout out to Arthur and the other interpreters that are going to be with us later on. Now, next up, though, I do want to go ahead and kind of keep this moving along, but keeping everything on track here. So I have an ask for everybody in the audience. Okay, if you haven't already, there's a couple things that these presenters do. It takes a lot of time to put these presentations together, right? So a couple things that I want to ask you to do. If you follow them on Twitter, if you follow them on whatever Mastodon, Threads, who knows, whatever you're on today, really, who knows? If you do any of that stuff, take a screenshot of the individuals. We always love it as presenters when we know our audience is tuning in to what we're presenting. Throughout something that you liked regarding the talk, a screenshot of an architecture diagram, those go a long way and they're a big vote of confidence for upcoming presentations. It's great to kind of have that in your back pocket saying, I made a difference. So if you want to go ahead and do that, I know that they would appreciate it. That's all I'm saying. That's all I'm saying. I'm going to go ahead and keep this moving along. Next up, we have Philipp Garbe. Philipp Garbe is going to be kicking things off as our second presenter here on track 1. Thank you so much for being a part of it, Philipp. I'll let you take it from here.
Yeah, thank you for having me. So welcome to CDK Day. And I know it's still early on, so I hope you're all motivated to dive deep into StackSets with me and how to manage them with CDK. Why a deep dive on StackSets? So StackSets are very useful to roll out stuff in multiple accounts of an organization, but it's not so well supported by CDK, and there's some good reasons. And I will show that. So my name is Philipp Garbe. I'm lead platform engineer at Personio, a company based in Munich, Germany. So greetings from Oktoberfest. And I'm also one of the AWS heroes. So before we jump into the topic, a short disclaimer. So the slots are only 20 minutes. So we'll go fast through the topic. The good thing, it's recorded. And I try to make my slides self-explanatory. So you have maybe give me then some feedback if I was successful or not. And I expect at least some basic knowledge about CDK and also CloudFormation. So what I'm telling you now is mainly based on 2 repositories. One is the CDK StackSets from CDK Labs, where the CDK team tries out new things. And one is my own repository. So, but before we start with CDK, let's look at CloudFormation. And we start with a very simple thing, a CloudFormation stack. For that, we use a template, which could be either YAML or JSON, to create that CloudFormation stack, and that provisions then all our resources that we want. But the question now is, what if we want to deploy the same template into multiple accounts? And the best example here is CDK Bootstrap. So that's something that you want to deploy in all of your workload accounts. And what we have here, and what helps us here is StackSets. So we can create a StackSet, which is part of CloudFormation. We provide a StackSet template, and then it will be rolled out in our target account. A StackSet template here is just a typical CloudFormation template, nothing special. It contains all the resources that should be created. And keep in mind, it should be account agnostic because it is used to be deployed in multiple accounts. And that StackSet template is basically the template that is used for the CloudFormation stacks in account A, account B, and so on. So StackSet is basically some kind of orchestration which takes a template and rolls it out into many accounts. And we have 2 ways how to deal with that in StackSets. So there's self-managed StackSets and service-managed StackSets. The main difference is for self-managed StackSets, you are responsible, which gives you more power, but also more responsibility. So you can decide on your own which account should be added or removed from your StackSet. But on the other side, you also have to care about the IAM roles, because what happens here is a cross-account operation that happens between a management account and all other target accounts. So you have to set up that trust relationship with IAM roles. And then there's service-managed StackSets, where AWS takes care about adding or removing accounts. And that is based on organizational units. So you define an organizational unit for your StackSet, And whenever an account gets added or removed to that organizational unit, it will also add it to as a stack, so-called stack instance to your stack set, and your stack gets automatically deployed or removed on the target account. And the good thing here is AWS also takes care about IAM roles, so you don't have to deal with that. Of course, we do not create resources manually in our account, right? That's why we're here. So we create our resources usually with a stack. It's not different here. So we create our stack set with the help of a stack. In that case, a stack set is just a normal resource like a Lambda. So we have to deal here now with two different kind of templates. Both are valid CloudFormation templates, but they are used differently. The stack template on one side is used to create the stack set. And the stack set template then is used to be deployed into the target account. How does it look like? That's a very simple example here. So on top, we have the stack set template that should be deployed into my target accounts. And we have just a simple Lambda function here. The example below is our stack template. It has mainly one resource, which is the stack set. And you see here in the template URL, it is referencing then our stack set template because that's the one that should be deployed. And we just have to upload that somewhere to S3. So now you're saying, yeah, nice, Philipp, but where is CDK? You promised us. So let's bring CDK into the game. So typically, we use CDK to synthesize our stacks and deploy them. And the same happens here. So CDK has to do two things now. The first one is it synthesizes a stack template and deploys it as a stack in CloudFormation. That's business as usual. In addition, it has to synthesize also our stack set template and upload it to S3 so that we can then use it. Remember the template URL? This is not working out of the box with CDK, but the CDK Labs project has you covered here. And they introduced a new StackSet template stack class that comes also with its own synthesizer. So that means you have to inherit from the StackSet template class instead of a CDK stack to synthesize and then also upload here the StackSet template. Maybe if you're used to that, it is very similar to what the service catalog product stack already provides that is part of CDK. But if you don't know that, it doesn't matter. The thing is here, the StackSet template stack, it needs a parent stack. So it can't be deployed standalone, always needs that parent. And that is also the reason why it does not show up in the CDK list command as a separate stack. The synthesizer here is then generating that template, creates an asset, and adds that asset to the parent stack. Also, let's have a look on the code, how they look like in CDK. Again, we have here on top the CDK stack, template stack. And you see here, it extends from StackSet template stack. That's all what you have to do. And again, we have our simple Lambda function here. On the other side, it gets more interesting. We have our CDK application. We create our stack. And the next line is here interesting because we create a new instance of the my stack set. And we provide the stack as a parent. Like I said, it needs to have a stack as a parent. And then we can use the new L2 construct that is provided by the library, where we create a stack set, we define some target where that should be deployed, and we provide the template. So basically what the template URL was in CloudFormation, that's the equivalent. And we reference here our initialize StackSet template stack. That works already fine, but you might now ask, what about assets? And when we have a Lambda, it's very likely that some assets are used there as well. And that's actually something that didn't work in the beginning. So normally, assets are uploaded to the CDK Bootstrap bucket, the assets bucket. But deployment into another account fails because that bucket is private, and the objects there, like the assets, they can't be reached from another account, like account A in that example. That's why the StackSet template stack did not support assets in the beginning and just throw an error. It's also not a good idea to make the Bootstrap bucket public, because like everyone could access that, or even if you restrict that to an organization, you would still give access to all assets to the accounts in your organization, and that's probably something you don't want. Maybe also violate some company policies. So here comes the synthesizer into the game and does its magic. So the red arrows here is actually showing what the synthesizer is doing. But let's start from the right. We are in account A. And that CloudFormation stack needs to access assets. So we have to put them into a public bucket, a separate one, where we don't make it completely bucket, but use some conditions, ideally to restrict access to all accounts within the organization, or even further. But the problem here is, how do we get the assets here? So what the synthesizer is doing of the StackSet template stack is, whenever an asset is added, it will be actually added to the parent stack. And in addition, an S3 deployment is also created in the parent stack, that then copies the assets from the assets bucket, where they are uploaded automatically by CDK, and copies them over to the public bucket. And it ensures that the synthesized StackSet template stack gets a reference to the public bucket, not to the assets here in the private one. So everything clear? So the synthesizer ensures that the assets are copied to the public bucket, and also that the synthesized template contains a reference to the public bucket. You might ask yourself, do I need to know that? And I would say no. Except you have to troubleshoot things, or you build it by yourself. That was happening to me. I was trying to solve the same problem in my company, and without noticing that there is a similar project on CDK Labs. So it was happening basically on the same time, and at some point I realized, okay, there's something official coming up. But that means we are done, right? We have StackSet template synthesized. We also have support for assets that works cross accounts. But if you think about cross account, you probably also think about cross region. And that's a very typical use case for StackSets, to roll out things like not only into many accounts, but also into many regions of that account. Again, CDK Bootstrap is the best example here. You want to have that in all regions where your workloads are running. But it is not working here. So what's the problem with cross region? Like if you add an account with a different region, the deployment will fail here. Let's have a look on account B, which is targeted to another region, in that case, EU West 1. The problem here is that assets must live in the bucket of the same region as it was used. So in our example with the Lambda function, the code to that Lambda function must come from a bucket that is also here in the EU West 1 region. But we created our public bucket already in EU Central 1. So this is not working. And there is also no support yet by the solution from CDK Labs. And you see the open issue link there. But what you can do is, as a workaround, you have the StackSet, basically this box here, deployed into each region in your management account. And then you roll it out, the StackSets only to the same region, to your target accounts. It's a little bit of overhead, but it's actually working. What we did as Personia was a bit of a different approach. So we do not provide like a bucket to the StackSet template stack, but we provide a list of regions. And we introduced a convention for a specific bucket name that also contains the region name. And think about like what happened with the CDK Bootstrap. It was based on some convention, and we did basically the same. So we created a Bootstrap for StackSets. And that is rolled out in the management account in every region. So we have these buckets already there. Our synthesizer then is doing multiple S3 deployments and ensures that the assets are then copied to every bucket for every region. And what it also checks is that the region variable that is used for the bucket name is always account agnostic, so it will resolve to the current region where the stack is deployed. And that also works quite nice. So with the or have already noticed that naming is hard. Your stack, StackSets, StackSet template stack instances, and so on. I mean, StackSets are complex already, even with cloud, just CloudFormation. But it's not complicated. It's just complex, and it's also complex with CDK. And what you can do is already now is you ignore all the complexity, use the CDK StackSets to create the StackSets that works with assets already cross-account. And if you need cross-region, I think I showed you the workaround that you can do. 2 ways how to do that. You can also look up in my repository. And with that, I want to thank you. If you enjoyed it, follow me. I will be also available here now, CDK Slack for questions, or on every other channel.
I realized I was on mute just now because the amazing ASL interpreter Danielle, who was coming on here to join us, wasn't signing, and that was my clear indicator that I must not be saying anything. So once again, shout out to our amazing presenters today. We're having a good time. What I was saying though is that I'm learning stuff now. I think there's this misconception that if you work at AWS, then you just automatically know stuff about the cloud. But it's as some of us that have been working in this field for a while, as some of us know, it's a pretty big space. So no, I don't know everything here. And to be able to work in the CDK and just hear these amazing presenters talk about stack sets and talk about all of these distribution cycles and whatnot, it blows my mind because when you know a lot, you realize how little you know, right? So being able to come up here and just kind of absorb knowledge for free. I mean, these people are doing it for free, right? Which is pretty cool. It's pretty amazing. So I just hope that you are taking advantage of this. I hope that you're jotting down notes. I hope that you're finding these people on Twitter. But yeah, this is going to be an amazing session. This is the first 2 talks that we have today. One thing, I was looking up ChatGPT jokes, and they're horrible. You would think that it would give me a good joke. It's saying things like, "Why was the CDK user always calm?" And it said the answer was, or the punchline rather, was because they had a construct for every situation. I mean, wah wah wah, right? Pretty bad, pretty bad jokes here. If you have any jokes, though, that I could use, throw them my way. Otherwise, we're just going to skip the nerdy AWS CDK jokes, and we're just going to go straight to dad jokes because that's my bread and butter. That's my territory.
Okay, I have to jump in here. I'm sorry. We cannot continue to have ChatGPT jokes. These will absolutely
so bad.
kill the stream. The people will sign off in droves. Nobody will want to listen to anything else we have to say here. So we'll keep those to a minimum.
So I thought you were going to come in here and say you had a cool dad joke, though.
I do not. I have no dad jokes. Hey, everybody. My name is Matthew Bonig. I'm one of the co-hosts for today. I just wanted to hop in and say hi. We had a couple of minutes before the next talk started, and I just couldn't let that CDK joke slide. I mean, I'm all for jokes. Don't get me wrong. I love jokes, but that hurt. That when you said that, I kind of got a little tightness in my stomach. Oh, yes, and definitely the Star Trek nerd has appeared. That's
you're not the only one. I mean, I'm right here.
That's Star Wars.
It's all the same, right? Touchdown and pop fly in the end zone type stuff. Yeah.
I don't know about that. I have to argue that Star Trek and Star Wars are very, very different. However, I do love the Bowser that you have sitting there above your left shoulder. That's pretty.
Which
fantastic.
one is this? Which one is this?
That's the Vulcan salute. That's the live long and prosper. Typically goes along with it. That is Star Trek, and that is Spock.
Okay. See, I know nothing about that stuff.
Well, we can teach you all day long.
Better idea is that we move on to our next presenter. We have Nora Schöner. And she's going to go ahead and have her slides up. Let me go ahead and get this started for you. It's been fun. Let me get off the screen, though, and get Nora going.
To my session, Building Efficient Infrastructure, AWS CDK versus Terraform. Together, we will take a closer look why CDK might be your choice when it comes to building infrastructure in AWS. I'm Nora, and I will guide you through some pains I experienced with Terraform. But why pains, you might ask? Well, I'm quite well known in my community for loving Terraform, and you see I even prepared a slide for it. I like it, but after years of coding my infrastructure with it, I have to admit, Terraform, we need to talk. Why? Well, I got enchanted by AWS CDK. And that's happened because I changed companies. So I joined Superluminar, and they love CDK. Superluminar is a successful AWS partner consultancy, and of course we are focused on AWS. It's a no-brainer to prefer CDK. We also use tools like Terraform or Pulumi, however our customer is requesting, but of course CDK is often our tool of choice. And CDK was also on my need to take a look into list for quite a long time, and I have to admit I'm a huge learning by project type of person, so it was finally my chance to take a look into CDK. And notice, of course, also what it might do a bit better compared to other tools. Before we hop right into the topic, I just want to say a few words about myself. So hi, I'm Nora. I'm a senior cloud consultant at Superluminar, based in Nuremberg in south of Germany. I'm in this industry for over 10 years now, and I worked for several companies doing different stuff like software development, DevOps, and also doing architect stuff. I joined the AWS Community Builders Program in 2023 and co-organized the AWS user group in Nuremberg. To connect women in the area here, I founded also the Sheen IT meetup, and in my free time, I like to draw and travel around and speak a little bit of Japanese. You see, my favorite spot, Japan. With this being said, let's get started and take a look what's in it for you. Well, we take a look about some pains I experienced, not all, but I will also have a blog post where you can take a look later. And we will also take a look, of course, into the treatments which CDK provides to heal us here a bit. At the end, I don't want you to leave you alone with this decision. I want to give you a decisions guidance to decide on your own which tool fits your needs. So let's get started. To be on the same page, I want to give you at least some basics, because it's not only my story why we compare these, but also the nature of the tools. So infrastructure as code tools are in general distinguished between declarative tools and imperative tools. So with a declarative approach, you describe what you want to have, like how will the server, the database look like at the end. You can kind of compare this with having a pizza around, a frozen pizza, or you order someone and getting it right away. With the imperative approach, you defined how to get to your pizza. No, not your pizza. Oh my gosh, how to get to your server. You can kind of compare it like having a recipe to bake your own pizza. So transferring this to our tools, Terraform is a declarative tool using like a JSON/YAML-ish language, the HashiCorp configuration language, to define your AWS resources. And CDK is an imperative tool, which means you can use your favorite programming language to define your infrastructure resources and having a more recipe-like approach. Terraform also supports various providers, not just only AWS, like CDK does. But today we want to focus only on AWS infrastructure. And now it's time to dig right into common pain points. First, I want to start with a kind of obvious thing, but this is not just related to Terraform itself. It comes as a kind of downside when you're using declarative infrastructure as code tools. And these are conditions. Well, in Terraform, conditions are written by the help of the count or the for each attribute and the question mark operator. So let's take a look at a kind of complex example I wrote some years ago. So you see here, we want to create a ACM resource, like an Amazon certificate, so manager certificate. Yeah, we want to create an SSL certificate you can use when you want to spin up a CloudFront resource or something else, whatever you want, wherever you need the certificate. So what we do here now is we using count and the question mark operator to create a certificate under specific conditions. And these conditions are having, for instance, the customer ID 1 and the environment prod, or the customer ID 2 and the environment dev. And when these conditions are met, we don't create this certificate. We do something else. I will show you in a bit. In any other case, we create a certificate and have a happy certificate resource. If the resource is created, we can also reference it using the resource name, the certificate, ACM certificate, and the unique name with an index, and then the attribute we want to use. This is kind of tricky because it's, I often forgot the index and then got an error. It's not that tricky, it's handleable, but well, it's disturbing, so to say. You may also ask what happens in case where these conditions are met. So when I have customer 1 under prod environment. Yeah, in this case, I want to use a data resource because, for instance, the certificate is already defined and I want to just read it and not create it. And also in this case, I need to use the count with the other way around, as you see here. So I want to create an asterisk, this data resource, if customers 1 and environment and prod, or customers 2 and environment is dev. So, and I can also reference this the same way and have the same kind of issues, challenges when inserting it. Especially a challenge when using the value is, how to use the value. So if I need to reference it, I need to be sure that this one is already existing. So I will get an error, for instance, if I deploy this using just the data resource, but the data resource is not created under my conditions. So I can use try here. It should be really used rarely, not too often, because it will not help with readability, and also it's not that recommended by Terraform. But somehow you need to then reference, maybe in this case, if it gets too much of the conditions, you also need to switch your whole infrastructure organization setup in this case. But as basic conditions, you can use this and have kind of a bit of challenge. So how to do this in CDK? Well, we can use here our good old if else statements, because we are using programming language paradigms to implement our infrastructure here. You see, we have if and an else block, and if the condition is met, we just create the certificate from an ARN using an already created certificate. In any other case, we create a new certificate. And then we can also reference from a constant cert here, which is really, it's much more convenient because I don't need to figure out which reference to use here now. Coming to the next thing, which made me a bit crazy sometimes, was defining and deploying lambdas. And this was with CDK a new brain wow. When I saw how easy it was to define and deploy lambdas, coding them with CDK, well, I was all in. Before, I might enjoy the pain a little bit too much. So let's take a closer look. How can you do it in Terraform? Of course, one can argue there are better tools to deploy lambdas, but for our use case, I want to stick with Terraform for the showcase. So for simple setups, it's okay to use, for instance, the data resource archive file to zip your Lambda code and reference it in the Lambda itself. This is especially handy if you have simple lambdas which have no dependencies and just need to be there. Think of a small lambda you maybe get called by event bridge or so, where you just need to trigger some servers, or else and just use boto3 as dependency. In any other case, it might a bit tricky because you need to add the dependencies. There are some ways to do it, and for instance, you can use here a null resource with the local execution provisioner, where you can set a command and executing a script which you define on your own. This will somehow then, whatever you need to do in the script, set up your bundle by installing the external dependencies and then zipping it and then using it for the Lambda function. You can also exclude this to your CI/CD pipeline, but also then it's kind of tricky because do you always need to creating the Lambda deployment package, and on the other hand you also need to maintain this all on your own, which can get challenging sometime if it's not only one Lambda, and or also if you're using multiple languages, which can be with Lambda, so it gets a little bit tricky. Also, the usage of the null provider is not that recommended by Terraform because it made a configuration harder to understand. So be careful if using it, especially in prod environment. Let's take a look how CDK does it, and this really hit me because we can use here the L2 construct Node.js functions, for instance. It's also available for Python and Go in alpha, so check out the latest docs for your language. The coolest feature here, I think, is that I can also do a bundling here. So I add a node modules, which I need to add to my Lambda function to functioning. And yeah, so this is really cool and saves a lot of maintenance work. The next pain point was also one thing which was mentioned by the community a lot, and these are policy handlings. When it comes to Terraform, the integration of policies is kind of basic. That means in case you need to add a specific policy to resources to allow service invocation and so on, you have to define the policy resource yourself and also add the JSON to it. So in Terraform, you can here add the JSON statement, for instance, as a policy statement or as a template or also as inline policy, where just having the plain JSON. One thing which really comes down, or is the downside here, is that if you want to go the least privileged path, it's really hard to maintain it all the way, because sometimes you need to know the resources before to reference in the resource tag in the policy JSON. And well, if it needs to go fast, and so I was always, not always, but often tend to use the wildcard, and I'm not proud of it. Of course, you can also use AWS managed policies here, which makes the maintenance a bit more easier. But on the other hand, if you want to be precise, you need to code this all on your own. And take a look how to implement. So imagine we have a Lambda function which needs to access DynamoDB. In this case, we of course have our Lambda function resource here. We add the role, and this role needs also, of course, needs also be created and needs to reference to a policy. And this policy reference will be done in, for instance, an attachment resource where I combine these both. Yeah, a lot of things to do. Let's take a look at how CDK can simplify this. So in our case, we want to access the DynamoDB table, so we create a table. We also create the Lambda function here using just a function construct. And the cool thing now is that we can directly grant the read-write to the function by adding the grant here. And this is really, really cool because it simplifies all the maintenance work regarding our policies, and yeah, take a lot away from it for coding it, so to say. It doesn't work for all resources like this. Sometimes you also need to specify your policies, but in most of the cases, this really helps here and is a good way to implement. Yeah. So now you think, well, Nora, you are just bashing Terraform, and you think the answer is clear. You don't like it anymore. You like CDK more. Well, of course, I like Terraform nonetheless. I'm a bit nostalgic because I started with it, and it helped me a lot getting my way through all the things I need to know about infrastructure and Terraform. But yeah, there are also other things I think which are really valuable about. So first of all, one thing I cherished was that there were no programming skills needed. Therefore, I can use familiar things like a JSON-ish, YAML-ish notation, easy to learn language, and yeah, use it right away. So no need for specific programming skills or programming paradigms. I can just start it. Another thing was also that, in my opinion, it's a bit more easier to do cross-region deployment. Some people argue this is not a good pattern, but especially from my point of view, when you want to deploy a single page application and you need to use CloudFront with the certificate, which you saw in the beginning, it's a bit hard because I need to have the certificate in the US East 1 region, and it would be nice to deploy it all at once. So this is not that easily possible in CDK. Yeah, but it's just also one point. So now, what do you think for which tool should you decide? I want to give you some questions you can ask yourself or your team when deciding for a tool. So let your decisions depending on team stuffing and preference of the developers, for instance. So are the people more on the operations side or more on the developer side? Do they prefer more config-like languages, or do they want to go all in with programming? This is really one thing to consider and ask yourself, because yeah, this defines how you use your tool also at the end. Another thing is also, do your company have compliance rules and need to use policies, for instance, for a specific language? Should be also considered. Although I don't like it so much, but it can be a case. Other things to be considered should also be the availability of the services you want to provision. So Nowadays, CDK, of course, because it's close to AWS, is really fast implementing new resources, and also Terraform does. But yeah, take a look which tool fits best for the services you want to deploy. And also the next thing, our workflows automatable, can be done nowadays very easily. But this is also one thing you need to consider if it fits already. And at the end, I can't stress enough, also take a look at the quality of documentation. Does the tool have a good documentation? Are errors easily be found in the internet, so to say? Can you Google it? If not so, well, maybe take a look for another one, or find ways how to contribute also to it to make it even better. So now, what is my conclusion? Yeah, I think it depends, as always, but I recommend, when having especially experience as a developer and solely working with AWS, let's take AWS CDK. It's a good choice for your infrastructure as code setup. It takes away a lot of work, especially with policies, Lambda deployment, and also if you think a bit further, because it's back to CloudFormation, it also have backup functionality, which Terraform doesn't provide when using the S3 backend, for instance. And on the other hand, I would say, if you have rare cases where you need to go down the multi-cloud path, or also have a team which is more on the operational side, Terraform is maybe the tool of your choice. At the end, it always depends, and I think you have now a good, stable knowledge here to be able to decide for a tool. At the end, if you said like, okay, I still have Terraform, but I want to go for CDK-ish style and do and code my infrastructure, you can also opt in for CDK for Terraform. With this being said, thanks a lot for staying here with me. I would love to connect with you on Instagram or Twitter, or also on LinkedIn. And maybe also take a look on my blog and read a bit for further information about this topic. Thanks a lot, and see you soon. Bye.
All right. Michael, I think you're on mute again. Hello, Alex. How are you doing today?
I'm doing well. It's bright and early. How are you doing, Matt?
I'm pretty good. Thank you, Michael. Welcome. Good to see you back. Hey, just a quick heads up. We're really sorry about what happened with the video. I have no idea why it glitched out for a few seconds and why we weren't getting any actual video. That was really weird. I don't think it was anything that we did on our side as far as hitting a weird button or something, but it came back, so that's good. So
you know what I think happened? StreamYard probably isn't deploying their site via Lambda. You know, they could be using something besides CDK or Terraform.
Ooh, those are fighting words.
I got your back, Nora. I got your back. Alex, how are you?
What's that? Oh, I'm doing well. Yeah.
Go ahead and introduce yourself to everybody.
Yeah. So I'm Alex Debrie, AWS hero. Do a lot in the serverless space. Do a lot with DynamoDB, and yeah, just excited to be here and watch some of these talks today. Pretty good lineup we got here. So excited to learn more.
Agreed. We've got a few minutes before our next talk from Ryan. We just kind of wanted to chat with everybody, let you know who we are and what we're doing, why you were seeing our faces today. I just realized I need to get a smaller set of headphones, though. These things are a little bit too large. My head's actually really skinny normally. These things actually probably help fill it out a little bit. That's kind of nice. So, Alex, what have you been up to lately?
Not much. I just traveled to Japan and spoke at Serverless Days Tokyo. So I'm still getting back on American time zones. Yeah, I've been waking up at like 2 a.m. every day for the last 3 or 4 days. So, and then I just like take this huge power nap in the middle of the afternoon, which is not helping me get back on schedule. But
I like how you preface that though with not much. He's like, hey, what have you been up to? Not much. Just,
Not much.
got back from Japan.
Yeah.
Just got it like that.
Yeah, first time there. It was an awesome experience. Yeah, really fun place.
What part?
So we did. My wife went with me. We did couple days in Osaka, a couple in Kyoto, and then we were in Tokyo for 5 days. So,
Oh,
it's
wow.
kind of
So
all
I'm
over.
thinking about doing something similar, especially the part with bringing the misses.
Yeah.
Which part, like, how does it work out? Like, now that you've been there,
Yeah.
which one is like, we should have spent more time here?
That's a good question. So Tokyo feels very much like a big city to me. Like feels like New York, with some Japanese influences and everything like that. Whereas Osaka felt more sort of unique and interesting, and also just like really good food, good street food, lots of things like that. So if you like to eat, I love the Osaka part. I thought that was a lot of fun. Tokyo has like a lot of good restaurants and food too, but it feels more like a sort of U.S. city in some of those ways, rather than like Osaka, which felt I think more unique and different.
Gotcha. Good to know. Good to know.
Yeah.
What have you been building lately, Michael?
But now, so this year I've been focused in on. Well, I was like, check out my Spanish talk later on today to find out.
That was a subtle ask for the plug. Yeah.
This year my big focus has been on building out micro SaaS applications. So, for those of you that may or may not know, so everybody basically, AWS has a team dedicated to building out SaaS apps, software as a service, software as a solution, and the idea with that is that you can build out these really large applications. We're talking like, how does, I don't know like the exact customers, but like as an example, how does Netflix do it? How does any of these big companies do it, right? But what about the quote unquote everyday indie hacker dev? A lot of folks know how to stitch together third-party providers to do it, but what does it look like when you build it on AWS? And why would you even want to do that to begin with? Check out my session later on to find out. But yeah, that's been my vibe all year. And speaking about that, building on that, showing folks how it can be done.
Gotcha. Very cool. Well, I'm looking forward to it. Hopefully, I'll be able to hop over there and take a look. Otherwise, all of these videos are going to be available on YouTube long after today is over. So if you happen to miss anything, you can always go back to them and watch them there. Also, as a quick plug, if you haven't already joined in on it, you can always engage with us on the YouTube comments, but we've also got the CDK.dev Slack server, and we've got channels specifically for each of the tracks. So as the talks are going, if you want to engage with the speakers or ask questions or anything like that, we'll definitely be over there along the way.
What about yourself, Matt? What have you been up to lately?
Ooh, what have I been doing? So let's see. The first half of the year was around putting together an advanced CDK course. You can find that over at matthewbonig.sidekick.app. That's SIDKIK. Or you can go to my Twitter. There's my Twitter, or X, I guess it's now called. That's my Twitter handle, and it's the pinned tweet there.
It's Twitter around these parts.
Yeah, I think
Can't get used to X.
Yeah. I've grown up here in Colorado. Mile High will always be Mile High Stadium, no matter what they call it afterwards. It's just always going to be the way. So, been working on that. That's been up, about the first half of the year, and now I'm just getting really excited putting together the reInvent talk. So I'll be speaking at reInvent on the CDK and trying to distill the last 4 years of my CDK experience into an hour, more like 45 minutes. At this point, I'm talking about 1 minute per slide, so I'm going to be speaking really quickly during that stuff, probably. Got to figure out how to make that work, so we'll see. But mostly that, also small little side projects here and there. So there's always a side project here or there that you got to be working on. Can't miss those.
Nice. Yeah. Michael, will you be speaking at reInvent this year?
Yeah, I got 2 talks. I have one on Gen AI and how do you do that with AppSync? What does that look like? And then the other one is our typical rehash of what's new with AppSync. And we're going to take an enterprise focus this year. Okay. So we did a bunch of cool stuff, and I'm super excited to talk about it. Super excited to see folks like yourself and Matt and everybody else. I feel like that's like the one time a year where we can just kind of hang out. But I want to see the sphere, though. That's my big thing. I haven't seen it.
Right?
Yeah, that thing looks really cool. I remember when they were building it last year, and I thought this thing is just going to be insane. I hope that my hotel room doesn't face the sphere, though. I don't want that.
Give you nightmares. Yeah, wake up and see the eyeball looking at you.
Oh my God. Crazy. I saw that on Twitter.
Yeah.
See, what's weird is that I say Twitter, but in my browser I type X because
You
it's
type
just
X?
faster.
Oh wow.
Yeah.
I can't do that. Yeah. Still
How
got
about
the
you?
muscle memory for Twitter.
Yeah, every time. Alex, what are you building?
Oh, just things here and there. I do a lot of consulting, a lot of which is advisory stuff, but I am helping build out a side project for someone. So, yeah, just doing, I don't know, the same old stuff. A lot of serverless, a lot of NoSQL, and just fun things like that. Yeah, and also working on my reInvent talk, which I needed to really get in gear here on that.
Right.
Yeah.
The deadlines for slides being submitted is creeping up really fast.
Is it October 8th?
Is it that fast? So we have to have our first. Do we have to have something?
It's like the initial slide. Like, I mean, people are like, here's my slide deck, and then we're tweaking it up until the day before.
Okay.
So
well,
going to the speaker ready room and all that
maybe
stuff.
AWS employees get a little bit more leniency than us non ones, but I think we're supposed to be done by the end of October. I think. Hopefully none of this is NDA, or else I'm going to get in a lot of trouble.
I was like, are we leaking implementation details right now? I was like,
I hope not. Jeez. That'll end that experience for me real quick.
Michael, tell me about this new Amplify V6 that came out yesterday.
oh man, pretty cool. So I don't know which is NDA, which is public, and which is upcoming. But I'm gonna talk anyways.
Okay.
We
So,
better know which is NDA and which is public.
right?
and
You
which
would
is-
think. You would think. So smaller bundle size is cool. Because previously you just got this big bundle, right? So now we do tree shaking, proper tree shaking, which is kind of hard in the Node.js space. Like, it's just getting wild with all that stuff. But then we also have cooler things like full Next.js support. So we're talking app router, server functions, API functions, all that crazy stuff that they just announced not too long ago. Now we have a bunch of utilities that wrap the context of a front end page, making it so much easier to call your backend services with whether you're on a single page application or your traditional front end plus server application. We really don't care anymore. And I think that's going to open the doors up for a lot of other server side frameworks like Astro and Nuxt and Vue and things like that.
Nice.
So I'm super pumped. A couple other things, but I'm like, I should probably look at the blog post before I say too many things that are down the pipeline.
Yeah, how are you going to support the next web framework that comes out in a month, and the one that comes out in 2 months, and the one that comes out at the beginning of the year? How
Honestly,
are you guys planning to support all those?
I think we're standardizing on, like, let's just make it generic and then have folks do that. But the big things are TypeScript support. That's a big one. But then I would say, like, to your point, it's probably like the bundler size, if anything, because now we have Bun, and now we have I mean, there's still like Vite and regular just plain Jane Node. Supporting those is what's getting tricky, and I'm curious to see where Bun ends up landing. It's kind of weird because like Deno never really took off. But yeah, that's probably like our hurdle is we're largely based off of community feedback and where we see trends going based off of what customers need. It's your typical AWS way, right? So
it's tough because the front end ecosystem is just so broad. So building for not just TypeScript and JavaScript, but then also you have like this newish runtime Bun, and then you have all the different meta frameworks and things like that. It's an interesting world, but doing great work there.
Yeah, and I think the tough part for me as someone who spends a lot of time in Node, Deno, I still don't know. I think it's Deno. I don't know. They're intriguing to me. I like the idea of having a more secure runtime and a better package management system and these other things. But I'm so used to Node system after 8 years. I feel like maybe I'm just sort of, what is it, Stockholm syndrome?
Yeah.
Helsinki syndrome, whatever it is.
Stockholm syndrome.
Stockholm. I feel like, okay, I'm here. I'm already familiar with that. Why go learn something new, right? So
get off my lawn. That's what I feel. Like,
I mean, right. I backed C# and the .NET framework ecosystem despite its horrible tendencies back in the late 2000s and early 2010s, and I felt kind of a little gross for doing that. And I feel the same way about Node now. It's like, I know it's not perfect, and I feel bad for anybody who's jumping into TypeScript and Node for the first time from some other language, because there are so many weird things that happen. But
But it is way better than it used to be, you know, like async await and a lot of and TypeScript generally. Like, you know, I feel way better about the JavaScript ecosystem now than
it's much better than 10 years ago.
Yeah,
Gosh,
yeah,
10
yeah.
years
With
ago was awful.
Rollup, Webpack v1.
Yeah.
What was before Rollup?
Was that like Grunt and Gold?
Yeah,
Yeah,
it
that's
was
what it was.
Grunt and
Yeah,
Gulp and all
that
Yeah.
bore.
Yeah.
All right, Alex, you
Cool.
are leading us for the next hour, so why don't we go ahead and keep moving? We don't need to.
Sounds good. I'm gonna bring Ryan on the stage. I'm gonna kick you two out of here. So Michael,
Perfect.
Matthew, we'll see you around.
Peace.
Ryan, welcome to CDK Day. How are you?
Hello, thank you. Thank you.
Oop, your mic's a little scratchy there. Can you try that again?
Let me try.
Are you using your AirPods or are you using some other type of mic?
I am, and I just switched to a different mic.
Okay. I can hear you there. I don't know if people in the comments want to say what that works for me, I think, better than the scratching. So anyway, you are an architect at Liberty Mutual, which is you know, a great place for serverless and CDK. I know a lot of really great things coming out of there. Can you tell us, you know, sort of what you work on day to day at Liberty?
Yeah, so I work on a cloud enablement team, so I get to see it's like kind of the whole gamut of everything that we're working on. So, you know, one day I could be jumping in on some awesome serverless stuff, like you said. Next day, you never know when you're diagnosing an RDS issue or you know, working on some EC2 networking. So, kind of get to see it all, but a lot of the stuff I've been working on lately is around, you know, helping teams with their deployments and CDK migrations, things like that. Of course, everybody has been working hard in the last few months, making sure you're all ready for CDK v2 that went, because v1 went end of life a couple months ago. So that was a big push.
Yeah. How was that transition for you and on the cloud enablement team?
Pretty exciting. I mean, yeah. I was doing a lot of that work on some of the teams I was working on before, just kind of with my regular work on application stuff, and kind of always wanted to just get a little bit more involved in the cloud stuff. So yeah, it's been great.
Yeah, absolutely. Cool. Well, I'm super excited for your talk, you know, talking about contributing to the AWS CDK and, you know, the CDK being open source, you can add to it. And I know like that can feel like a hurdle or a burden if you haven't done sort of open source contributions before. So I think going through this, you know, if you're new to the CDK, new to open source, I think this is gonna be a great talk. So without further ado, I'm gonna pull up your slides and take it away, Ryan.
Awesome, thank you. So as Alex said there, we're gonna talk today about making your first contribution to the AWS CDK. My goal here is if you have never contributed to open source and maybe the CDK is where you want to get started, or even if you've contributed a bunch to other open source projects and you've never contributed to the CDK in specific, I hope you can get something out of this. So a quick bit about me. We kind of led into this already, but I am a technology architect at Liberty Mutual Insurance. I've been working with the CDK for about 6 years now. And if those of you doing the math right now, that is when the developer preview got announced. So I jumped right in there as soon as it was available, because I don't know about the rest of you on the call, but I'm not personally a big CloudFormation fan. And when I'm away from the keyboard, I love to travel, watch ice hockey, and I am an unapologetic aviation geek. If you ever meet me in person and I'm staring up at the sky, there's probably an airplane flying overhead. Pretty typical for me. So jumping right in, you might be thinking right now, okay, AWS builds all these services. They build all of the stuff that I use every day. And you know, we maybe pay them some money for providing those services, but wouldn't they be building the CDK as well? And you're right, they do build the CDK among all of their other services, but AWS does have a track record of both using and providing their own projects as open source. CDK is one of these where they welcome input and contributions from community members like you and I, and this has benefits particularly for folks who might be looking to get their first experience with open source, like I said. Since the CDK is maintained by both a big enterprise in AWS, but also a large community of all the you know, wonderful folks who are here today, there's generally a lot more opportunities for support when you're going to contribute than maybe if you're looking to jump into a smaller open source project. So let's talk about what we need to get started. So even if you use the CDK with a different language, you may use it in Python or Java, you're going to need to know TypeScript to make contributions. The CDK ultimately is built in TypeScript. You can use any editor or IDE that you're comfortable writing that TypeScript with, but if you're not sure where to start, VS Code is a very popular choice, and you'll find tons of help online for getting started with that. Most people come to contribute because there's something they want to see in the project. And maybe that's you. You came to this talk because there's a particular feature that is missing from the CDK and you wish it was in there. And that's great. That's a perfectly fine way to come and say, I want to add this. That's how I got started. But you may just want to get involved in open source in general and you don't have an idea yet. And that's okay too. You can find some inspiration from existing issues that are out there. We'll talk about this a little bit later, but there's a ton of issues already open on the issue tracker. So there's plenty of stuff that you can jump in on. And then one other thing you're going to need is just a little bit of patience. And this is important for a few reasons. First off, the CDK is a very big project. That means it can take a little bit of time to pull down dependencies, run a build, run the tests. That's just sort of the nature of a project this size. There are a couple of things like Git pods and dev containers that can help speed some of this along, but it still might take a little bit of time. The other piece to this is when you open a PR, just remember that the reviewers on the other side of that are regular people. They've got their own work to tend to, and there's a ton of other PRs that are open. They are going to get to your PR and review your code, but it might take a little bit of time. So just be a little bit patient, and that'll go a long way to getting your code merged. So if you've contributed to open source before, this is going to look familiar, but with basically any open source project, the first place you should start when you're really starting to get into it is the contributing.md file. And this file basically includes everything you need to know for the entire contribution process. It does get updated often as tools and processes change. Again, CDK is a big project, so things are going to change over time. So if maybe you make a contribution, today, and then a couple months later, you want to come back and add something else, you might want to take another look through this document to look at anything that's changed just to make sure you haven't missed anything. I say this because this has bit me before, where I came back to the project after a little bit and didn't realize that some of the testing scripts had changed, for example. So now that we've reviewed the contributing doc, you're probably starting to think about what you might want to work on if you didn't come in with an idea already. And this is where I was saying it's a good idea to start out with the issue tracker and take a look at the things that are already in there. The CDK maintainers have done some of the heavy lifting for you and have tagged a bunch of issues with this good first issue tag that you can see in the screenshot here. And that can be a great indicator of issues that would be a good fit for somebody who's new to the project. These are usually issues that are a little bit smaller in scope and will help you work through the process and learn that without getting too hung up on the implementation itself. And you can use the search in GitHub to help find those. Now, if you have an idea and there's not already an existing issue out there for it, that's okay. You can create your own issue and get some input on it before you start working on it. So for that process, do take a look around and make sure you don't find another issue that corresponds to something you are already thinking in your head. There are, at least when I wrote this, nearly 1,800 open issues, so there might already be one. If you do find one, great, upvote it, bring some more attention to it, and read through the comments. They might be looking for a contributor, and you can jump right in. If not, go ahead and hit that new issue button. There are templates already out there in the repository that's going to help walk you through the process of creating a new issue. And you can see when you hit the new issue button, the screenshot that I'm showing here is kind of what you'll see. There's a bunch of different templates that will help you walk you through which type of issue you want to open. And then once you click that one, it's just as easy as filling in the appropriate fields. It'll walk you through all the required information. Once you do create an issue, it's usually a good idea to wait a little bit for one of the members of the CDK team to triage your issue before you get too involved in writing your code. As part of this, they might give you some pointers on your implementation that you might want to take into account before you get too far along. And they may also help tag in a related issue that maybe didn't come up when you were searching originally, or maybe one that was opened around the same time you opened yours. They'll help bring those together so that we don't have duplicate issues out there, and you can find other folks to collaborate with or get some more context if there's an issue that's been open for a little while. So now that we have an issue open, one of the fields you'll be prompted for when creating a new issue is a proposed solution. So this is a spot in the issue template where you can put in a little bit what you think that this feature would look like to somebody using the CDK. You will get prompted for this, and it's a really good idea to get input on this before you really start implementing, because you want to make sure you're not going too far down the wrong path. But if you're not sure where to start with this, then there's a couple of ideas of where you could get inspiration. So first and foremost, look for inspiration on similar implementations around the CDK. Let's say you're looking to add a new attribute to a resource, for example. Look at how other attributes or parameters were implemented for that particular resource, and try to see if you can mimic a similar implementation pattern. That'll make it not only a little bit easier for you to contribute that, but it'll also make it easier for users at the end of the day, so everything feels natural as they're working through using that construct. Another place to consider when you're designing your solution is CloudFormation. A lot of folks are coming to CDK from CloudFormation, so it makes sense that the implementations for a lot of level 2 constructs especially will look reasonably similar, while still getting all the benefits that we know and love of having a full programming language and some of the more helpful constructs in CDK. Both of these suggestions ultimately are to get you thinking a little bit about your change from the context of the user on the other side. You want to keep your implementations predictable to make it easier for somebody to use as they're going through building their CDK apps. But at the end of the day, if you're not really sure based on either of these other things, don't be afraid to ask. Open source contributions, both CDK and otherwise, are meant to be a community effort. So the whole point is you can ask in your issue or ask in the cdk.dev Slack that, hey, I want to implement this change. I'm not really sure what it should look like. How would you expect to see it as a CDK user? And somebody will be more than happy, whether from the CDK team or the community, be more than happy to jump in and give you some pointers. Okay, that's a lot of getting ready. Is it time to write some code yet? Almost. So if you haven't yet, you're going to want to start by forking the CDK repository. This brings a copy into your personal GitHub account so that you can make contributions, and then eventually we'll be looking to request that those changes get merged to the main CDK repository. Using the contributing guide as a guide, make sure you have the proper versions of all the required tools installed. There's a few different sort of prerequisite tools that you'll want to have installed for actually developing in the CDK, and there are some specific versions you'll need to make that work. So just be careful that you have those versions ready to go. There's also a tool called Gitpod that you can use that'll give you a pre-built cloud workspace that already has the dependencies installed. The CDK is built. It'll save you some time. You can find a link in the contributing guide that you can just click to jump straight over to Gitpod and start up your cloud instance all ready to go. But if you're like me, you might have some of your local development tools already personalized that you're ready to, you know how to work with and you feel more comfortable with. And that's fine. Just, you can walk through, pull down code and pull down all the dependencies locally. It does, like I said, it does take a little bit the first time, but once you get going, it's smooth sailing from there. And then finally, on environment setup, as I mentioned before, the CDK is a TypeScript project, and it's built as a monorepo managed with a tool called Lerna. You don't need to know Lerna, and you don't really need to be an expert in monorepo, design or anything like that. I mention that only because if you don't have experience with monorepos, things might look a little different than you're used to. That's okay. You'll be able to follow the guides even if you don't know how to build a monorepo yourself or anything like that. You have probably seen, and I mentioned earlier, that the CDK is available in a number of different languages, not just TypeScript. So these other implementations for like Java and Python are generated with a tool called JSII. We're not going to dive into that at all today. We just don't have the time. But the important thing to know is just a reminder that you don't need to know those languages. So if you felt like, oh yeah, I really want to contribute to the CDK, but I know TypeScript, but I just don't know Java, and I don't know how I would implement my change since the CDK also works in Java. You don't need to worry about that. All you need to write is TypeScript. You write it once, and all of those other implementations will follow. And then, while sometimes I know it's exciting to just jump right into the code, and this one might seem obvious, but I put it here because I've fallen into this trap myself as well. I highly recommend making sure you have a successful build with all of the tests passing locally before making any changes. There's a lot of moving pieces of the CDK, and it can be really frustrating to try to debug a testing issue when you're not sure if it's your code that you wrote or if it's just your local environment setup. It's much easier to do that debugging when you know that you're starting with code that has all passed the test before and none of your changes are in there. Okay, now it's time to go and work your magic. Now that you're set up for success, you can write some code. I know I've alluded to the scale of the project a number of times now, but once you're at this point where you're ready to start finding your way to actually implement your changes, this might be where you really start to feel the overall scale of the CDK. You'll probably be working somewhere in the packages directory that I have in this screenshot here. And the main folders in here where most contributions are going to all have similar names. So we'll go over the main ones real quick here. So the @AWS CDK package is where you're going to find the packages that are still in alpha. If you're the kind of person who works on the bleeding edge of the cloud, you're in all of the latest services and some of the stuff that may not even be in the production, full stable version of the CDK yet, this is the place for you. This is where you're going to find all of those alpha version packages. The @AWS CDK testing folder contains integration tests. Most changes are probably going to involve work in this directory at some point. We'll get to those in a minute. AWS CDK without any prefix is where the CLI lives. And then the AWS CDK lib folder is the main folder where all the production services are at. So most of the time, you're probably working on something that lives in this directory. And you can see from my screenshot here that each service is predictably split out into this folder, so you can easily find the service that you're working on. If you've been using the CDK for a while, you've probably already seen some of this structure in imports or in the CDK docs. So finding where you're trying to get to might be easier if you already know what you're looking for from those. I do also want to call out here that each of these service folders will have a README file in it. This README becomes the documentation that goes onto the CDK docs website. So be sure to update this anytime you make changes to reflect those changes you made. A feature that exists but isn't documented may as well not exist at all if nobody can find it. And while we're talking about documentation and things like that, another important piece is to remember the comments. Now, comments are generally an important tool for readability, but it's really important in the CDK because the docstring comments are going to appear in the end user's editor when they're actually writing their code. And you've probably seen these yourself. As you go on and you're typing through that you want to grant read to a bucket, you've probably seen that little pop-up that shows up, explains what that method does and what parameters it takes. This is where they come from. So you want to make sure that ultimately you're thinking about the information that you would want to see yourself while you're building a CDK app and write those doc strings accordingly. You want to make sure you include information that's helpful and descriptive, but also brief enough that it fits in that little pop-up and you can read it at a glance when you're typing. This is another place where looking at other code in the same package can be helpful too. If you can keep the other comments, the comments sounding similar to some of the other comments in that package, it'll make for a better experience for the user as they're working within the same package. So I'm showing grant read here on the screen. I would expect that this looks fairly similar to a grant write for a bucket object, for example. And then there are tokens such as the @param that you can use to highlight parameters or other special elements that are in your methods. So you'll see these around, but @param is the one you'll probably see the most. And as you can see there, it gets a little bit of special treatment on how it's displayed in an editor. Okay, so you've written your code, you've written your documentation, you've got your comments all good to go. Now it's time to open your PR, right? Not quite. We've got to write some tests first. So no code change in the CDK can be merged without tests. So that means whether you're testing new functionality or adding tests to make sure your bugs stay fixed. Unit tests are, of course, going to be required, but that's only part of the equation. You also need to write integration tests, most likely, for anything that touches how CloudFormation is generated. Integration tests will actually generate CloudFormation and deploy them out to a real account, take or compare a snapshot, and then destroy the stack. This does require having an AWS account that you can deploy to, and the CDK team is aware that not everybody is going to have the ability to do this. So if you can't run or set up integration tests yourself, leave a comment in your PR so that one of the maintainers can run those integration tests for you and get them into your change. The specifics for these are in the integration tests.markdown file. This will also explain when integration tests are required and some of the specifics on how to implement them based on your change. Okay, code is done for real this time. We've tested it. Now it's time to open that PR. So every PR needs a title and a description. CDK uses the conventional commit spec that you can find at conventionalcommits.org. Your titles are going to be prefixed either with feat for feature, fix, docs, refactor, or chore to quickly indicate what types of changes you made. Any features or fix PRs are going to end up directly in the change log, so make sure your message is descriptive so that people coming later can see exactly what changed in that new version. If your PR introduces any breaking changes, make sure you call them out. This is important both for the maintainers to understand and determine if there's any way to mitigate those breaking changes, but otherwise it's crucial for users to know too if they take a new version that their code might break. Make sure you tag the original issue that your PR addresses. So we talked about issues earlier. I've created an issue. I go create my PR. I want to make sure I reference that issue in my PR so that if other folks are watching my issue because they're interested in the same fix, once my PR gets closed and that issue gets closed, they'll get notified. This also helps reviewers a ton because they can get up to speed on context as well as making sure they have that full history of the issue when they're going into review. And in the body of your PR, make sure you explain the why and the motivation behind your changes. Explain why you implemented something in one way instead of another, or what design decisions were considered when making your changes. It goes a long way to helping reviewers. Now, once you've actually opened your pull request, a short time later, a build is going to get run against your changes to ensure that the tests are all passing. Make sure you either check back or you have GitHub notifications enabled so that you know if this fails. And also, this will help so that if maintainers come and leave any feedback, you can address them quickly. The CDK repo is large. I've said it a bunch of times here today. There's a lot of contributors, which means you'll almost certainly need to merge other changes into your branch. That can result in conflicts. So you're going to want to make sure that as you're merging in changes and you have conflicts, you can address them quickly. Maintainers are also going to trigger merges to try to catch conflicts just before merging or approving your PR. If you have any unconventional dependencies too, make sure you call them out and open a dialogue with maintainers so that they can work with you on how they might want to accommodate that dependency. Most of the time, you probably won't run into this, but just know that if you're doing anything that's maybe a little unconventional or breaking, just talk about it. This is meant to be a community-driven effort, and it's a social effort. So certainly want to keep channels of communication open all the time. And once that's approved, your PR will automatically be merged. And then after that, congratulations, you're now a CDK contributor. So thank you very much, everybody, for tuning in today. Hope you enjoy the rest of CDK Day. There's a ton of exciting talks on the schedule. If you have any questions or want to reach out to me, you can get me on GitHub, LinkedIn, or Twitter. I'm also in the cdk.dev Slack channel, so you can find me there, and I'll be catching up on the Track 1 channel as well. Thanks, everybody.
Ryan, thank you. That was a great talk. I love both the practical aspects of like how to do this stuff, but also, just like the empathetic aspect of understanding who's on the other side or writing documentation and tests and all those sorts of things. I know, I don't know if you saw Momo Corner from the AWS CDK team was here and saying, hey, I'm on the other side of that PR. So I'm guessing he appreciates some of those call outs for some of that stuff. So thank you for the talk today. That was really great.
Yeah, of course. Thanks for having me.
Yep, absolutely. So I'm going to go right into the next one. This, I'll kick you off, Ryan. This next talk is from Josh DeMuth, who is a partner solutions architect at AWS. And this is a great one. This is about just what's happening with when you run CDK synth, right? What's happening with stack synthesis. I think it's super useful to understand how your tools work and what's happening under the hood and things like that. So understanding what's happening on that synth is really useful. And Josh is going to walk through that here. So I'm going to go ahead and kick that one off.
Hello, everybody. My name is Josh DeMuth. I'm a partner SA at AWS. Been at AWS for a little over 3 years now. And in my role, I work with AWS consulting partners to help build up their AWS practices. And I also get the opportunity to work a little bit with our builder experience domain or services, which includes infrastructure as code, which includes the AWS CDK as well. So the AWS CDK is one of my favorite topics. I love talking with customers and partners, and I love building using the CDK as well. And today I want to talk with you a little bit more about our stack synthesis process. So what do I mean by stack synthesis? And the way that I like to describe this is, like, as you work more and more with the CDK, or you hear people talk about it, you'll learn about the word abstraction. So what do we mean by abstraction? Usually when we're building with the CDK, the abstraction comes when we talk about constructs. So we talk about, maybe like you have an Amazon S3 bucket and you use the Amazon S3 CDK package, which we would call our level 2 construct. And then there's basically, with one line of code, you can produce multiple lines of CloudFormation, but you can also like override defaults, and build your best practice bucket. But that's in the context of CDK abstraction, that's normally what we talk about, just to make it easier to develop in a higher level language, and then get that to be distilled down to CloudFormation. And that's really important piece of abstraction. But today we're going to talk about a slightly different type of abstraction, and that's what happens when I have that CloudFormation template that gets created. Now, how do I actually deploy that? And what if I have other assets? Like maybe I have an AWS Lambda function. Like, how do I actually get the code that I need to deploy for that function? Like, and how does it get deployed when I run my CDK deploy and it talks to the CloudFormation service? How am I guaranteed that the code that I'm going to deploy, or the template that I'm going to deploy, is the one that I actually want to deploy? Like, what if it accidentally grabs an old one? Like, what if there's one that I ran 3 days ago and it accidentally deploys that? Like, how does the CDK help limit the possibilities of that happening? And the answer to all those is through the stack synthesis process and the bootstrapping process. So if you've ever tried to run a CDK deploy and it says you haven't bootstrapped your account or your region yet, you'll learn a little bit more of why that we just can't deploy without bootstrapping, unless you override the synthesis process that we should touch on a little bit today as well. So this is my only slide today. I'm not going to have a presentation. We're just going to dive a little bit deeper into code directly. So I'm going to share my IDE just so we can get started and look at a few things. All right, so I have a really basic example here. All I did was run CDK init, and you can ignore some of the other stuff. So I have a basic example, then maybe a little bit more advanced example that I want to show you. So for the basic one, just ran CDK init, got rid of some of the comments. And you can see here's my entry point as I'm just pulling in this stack from my lib directory. And then I'm not passing any properties at all. So it's really basic example. And then my stack is just one Amazon SQS queue. So I have an SQS queue. So again, resource, like what I would expect the CloudFormation template to look like, is I have one queue. There shouldn't really be anything else there. So I just want to run a CDK synth, see what happens, and then we're going to kind of work backwards from there and learn a little bit more about the process. So while I run this, I want you to look over on this side. So there's going to be a cdk.out directory that gets created, and that's what we'll look at. So if I just run, and I'm not authenticated to any account, I'm not actually going to do a deployment. Like, I'm really just doing things locally here today. So if I run a CDK synth, notice that the cdk.out directory was created. At first, it creates a log file just so I can only have one running at any given time. And then, like, when I run a synth, it'll also display the YAML in my terminal window, as you saw there. But it also creates a lot of files just to, again, help the deployment process. So let's look at the first one. which is my template. So this is my CloudFormation template. Again, really basic. We got an SQS queue and my visibility timeout, which you saw on the property. It's got some other default fields that it created, and then there's just a lot of other metadata fields just to make the CDK service better. So this is our CloudFormation template. This is what I want to deploy. I could easily take this template and bring it to the CloudFormation service myself and run it, and maybe everything would work exactly as I expect, because I don't have like I said, there's no Lambda here. There's no external assets that I need to get anywhere. So I could technically take this and run it directly on the CloudFormation service, but that would still require manual effort for me. I would still have to build some type of custom process. Like if I'm building a CI/CD pipeline, I would still have to do that. So again, the abstraction of the CDK is that when you run a CDK deploy, it's going to do that part for you. And like, how does that work? How does CDK deploy know that I want to deploy this stack, and how does it actually get it to the CloudFormation service? And the initial answer to that is through this concept of assets. So if you look here, we have another file that got created when I ran CDK synth, and this is an assets.json that is kind of a sibling to my CloudFormation template. And what this is saying is that I have a file asset. So within CDK, we have two main types of assets. We have file assets that go to Amazon S3, and then we have Docker assets or Docker image assets, and those would go to Amazon ECR as a container image. So we have two main types of assets, and a template, of course, I'm looking at it. It can easily tell it's a file. So this is my file asset. And then as part of this assets.json, it's just giving me a little bit more information about what the CDK needs to do to this file. So I have a file, but what am I supposed to do with it next? So I know that it's a file asset, so it's going to Amazon S3. So now I need to know basically source and destination. So the source, we already looked at it, is my template.json, and my destination is a bucket. So you can see that we have a bucket that starts with CDK-HNB659FDS. We'll talk a little bit more about what is that value. We'll talk more about that here shortly. And then there's an asset. So this is my bucket name. And you can tell that it's pretty specific to the CDK here. I have an object key. So this is unique, to my synthesis process here. And then also we need to tell the CDK, what role are you going to use? Like, what permissions will you use to actually, take this local file and put it into this bucket? And then once it's in the bucket, what are you going to do with it after that? So that's where this manifest.json comes into play. So the manifest is what gets handed to the CDK deploy process that it just knows how to orchestrate the entire deployment, basically. So you can see that we have this asset, like where to get the information about assets. And we only have one asset here, which is our CloudFormation template. You can see that here's the file. We'll talk a little bit more about Bootstrap version in a second, but this requires that I have a Bootstrap version of 6. Anything less than 6, then things just won't be in place for me to actually do the deployment. And then I also have more information about my stack. So I tell that it's a CloudFormation stack. In my call here, I did not pass anything. Like I could come in here and put env. Then I have things like I could have my region, for example. If I wanted to deploy to a specific region, and then if I ran it again, then I would have a region there. I could also put an account there. If you don't put anything, then the CDK deploy is going to just best effort try to know where it thinks do you want to go, maybe based on your current credentials. But then there's also some other information. We have like an assume role ARN. So this is my deployment ARN. So the CDK is going to try to do the deployment using that ARN, using that role ARN. And then we have a CloudFormation execution role ARN. And that's, what is the CloudFormation service going to use to actually deploy my CloudFormation template? And then a whole bunch of other things. But you can see that this is all just backend related information, abstraction information that it needs to tell CDK that I want you to take this file this CloudFormation, and this is what I want you to do with it. And again, this is a really basic example, but it's still, will do everything for you, where you can just run CDK deploy and it automatically will talk to the CloudFormation service for you, so you don't have to do that. All right, so at this stage, let's talk about Bootstrap a little bit. So using the Bootstrap command, you can actually create a local template. So when you Bootstrap, all it's doing behind the scenes is running CloudFormation template in that account in that region that you're bootstrapping. And just to show a few things here, so we have some trusted accounts for lookup. So that's like IAM role related. We got file asset bucket name. We have this qualifier, which you can see it's defaulting to that HNB value. Then some other, it's really just a lot of the same information that we were just looking at. So when I bootstrap, that's bootstrapping for synthesis, basically. And you're also, with these being CloudFormation parameters, that you're also able to override these. So let's say that I wanted to have multiple bootstraps in a single account or in a single region, that you could do that. Like I could have my main one that uses the HNB default, but then maybe for some reason I have some compliance concerns in production, that I want to have a different bucket, that my production bucket needs to be completely different from other ones, and maybe that's just all running in the same account for some reason. So there's ways that you could override that at the bootstrap level, and there's also ways that you can override that when you actually run your CDK synth or CDK deploy. So you can see, when I call my application, that I've added a region here. I'm gonna just delete that. I was just showing as an example. But there's also this concept of a synthesizer that's part of the application of the stack properties. Sorry. So if I do this, I can basically override the default stack synthesizer. Or it can be difficult to say sometimes. Oops. Okay. And so what this is doing, so I know I haven't talked about the default stack synthesizer yet, but what's going on behind the scenes to actually produce these assets and this manifest at a high level. It's all done through this stack synthesizer process. So if we were to look just real quickly before we run this, I think it's important to see what the properties look like here. So we have this default stack synthesizer, and I can go to it, and I just want to look at the props. So if we look at some of the props of this, so name of the S3 bucket to hold file assets. All right, I think I've seen that before. I've seen that, in my manifest, or in my manifest in my assets.json. I saw it on the Bootstrap template. I got a bucket name here. And then you can see that there's some defaults that we'll look at. So we have this default stack synthesizer with its own defaults. So if we keep looking, we got more roles. These lookup arms, like image, that's for the ECR, deployment role. And then if I go down a little bit more, I'll see where it's actually creating all these defaults. So you can see this HNB 659. So in my manifest.json, this is where that value came from. It was implemented in the default stack synthesizer. And if I don't include anything, it's in the name. If I don't include a synthesizer, it's going to just use the default stack synthesizer with all of these defaults. So you're basically getting all of these default, again, buckets, roles, and qualifiers, and all the other stuff. And then within this synthesizer, it's also going to say, how do you actually package up an asset? What does it mean to package up a Docker image asset versus a file image asset? And all the other implementation details. Unfortunately, with the only having 20 minutes today, we're not going to dive deep into that part. But I just wanted to show you where all these values kind of come together, and that, again, you are able to override them. So if I have this and I do a CDK synth, and as this runs, you can see that it locked it. And then in a second, you can probably see it updated in real time once it's done. Okay, it just finished. Now, instead of that HNB value, now I have prod everywhere. So if I try to run this and I haven't bootstrapped with that same qualifier, then it's going to fail. But now I have the ability that I can, again, I can have multiple bootstraps in one account in one region by doing that. And that's just one example. Like you can override a bunch of different ones, and you can also create your own stack synthesizer. And that's what I want to show you next. So I also have within the service catalog L2 construct, this was recently created, and behind the scenes, there's actually a custom synthesizer for this, mainly due to how the S3, like if you do have a Lambda function that's in your service catalog product, which is really a CloudFormation template, like you can't use the CDK bucket for that deployment, because when you deploy service catalog, that's outside the scope of the CDK. Like you don't want to create that dependency when you're not running a CDK deploy anymore. So the way that this custom synthesizer works is for the file asset, instead of using just those normal bootstrap buckets, that you basically pass in an asset bucket, and it's going to do an S3 deploy, but behind the scenes, and it's going to take it from the CDK bucket and then put it into the bucket that you passed in. So just, and you can see that here, like where I'm passing in this user defined bucket, I'm creating it, and then when I'm creating my Lambda product, I'm able to pass this asset bucket in, and that's really going to be used by the stack synthesis process behind the scenes. So let me just show you what that looks like in the cdk.out directory. So let's do service catalog stack, and then we're just going to do the default properties. Okay, now I'm just going to do a CDK synth. So all I'm doing is just calling it, again, default properties. I'm not overriding anything. And then you're going to see a whole lot more files get produced here. Yep, because this is a lot more complicated. So if I just look at a few things, if I look at my template, you can see it, my asset bucket, and a few, and you can see my custom CDK deployment. Like in my personal CDK for the service catalog, I didn't say to do any of this information. Like this is all being done in the custom synthesizer that's adding it to my stack, because it needs it as a abstracted implementation detail. So if I keep looking, there's this S3 deployment process that's taking it from the regular CDK bucket and moving it to that one that I passed in, and that's being done through a level 3 construct, from a S3 bucket deployment. So that needs a Lambda, because it's a CloudFormation custom resource that uses a Lambda. So that's why I have these assets, because I need to deploy that. But again, I didn't, like, this is all abstracted away from me. I do have my index.js that's just empty, that's going to deploy with my service catalog. And then, but it's the same idea. I still have these assets. So you can see I have a lot more assets here. And you can see some, they're going to these buckets. And then again, behind the scenes, it's creating that custom resource that's going to take the ones that it needs from this bucket and then move it to the other one. Now, again, I have my CloudFormation template, and then this also creates a separate one for my Lambda product. So I know I went from like 0 to 100 really quickly there, but again, just wanted to show you, just how complex some of this can get. And then behind the scenes, the CDK is just handling all of it for you. And then when you create a level 2 construct, or a level 3 construct, that you're able to maybe override this stack synthesis process to build custom logic that the callers of that construct don't have to implement directly, that it can be behind the scenes, that you just pass a bucket, and then we're going to handle all of that behind the scenes. But once this gets sent to the CDK deploy process, it's still going to pass that manifest. It's still going to go through and run all the processes like it would normally do. But I know that we are pretty much at time, so we're not going to dive into the open source code today. But just know that behind the scenes, there's like a stack synthesizer abstract class that you can override and implement your own. Like, we saw the default stack one. There's the product stack synthesizer within the service catalog level 2 construct. And then, of course, you're able, with all things CDK, you're able to make your own and override it if possible. But yeah, thank you for your time today. And hopefully, you learned a little bit more about what's going on behind the scenes when you type CDK synth, and you can understand the importance of bootstrapping an account.
All right, Josh, that was an awesome talk. I love those deep dives, and I see many people in the chats as well. Matt, I got to ask you, because you're the CDK expert. You've done the video course on CDK and everything. So he talked a lot about implementing your own default stack synthesizer, tongue twister. When would you do that? What are some use cases for that, or when would I think to modify that myself?
Ooh, good question. I probably would never find much of a use case for trying to override the specifics of how the synthesizer works. I think the synthesizer as it currently is working is pretty solid. I haven't found many of the reasons to find it. What I do find is that it could take my CDK code and produce an entirely different output that could be useful to me. So, for example, one of the things that I've been toying around with is the idea that I could run a custom synthesizer that would output information that could be used in some sort of display fashion to show an architecture diagram of the entire code base. You can probably generally get that from the CDK tree that's part of the cloud assembly that gets synthesized out. But those are the sort of the fun things that I've been thinking about. I am going to be building a custom synthesizer as part of my talk at reInvent and actually was inspired a lot by Josh's talk here, to build something a little bit fun. It's not going to be useful in any way, but if you want to see what that looks like, I suggest you go to the catalog, favorite my talk COM302, and then come to it on Monday at reInvent, and you'll see what I've done with the custom synthesizer there.
There you go,
but
folks.
I know that
302, that's the one to go to. Okay, so
gotta plug
on that. Yeah, if I'm outputting something beside, you mentioned like display purposes, but if I'm outputting something besides CloudFormation, is that like where I would hook in? Like I know we have a talk later from Matthew Rawlings on like outputting Ansible. Is that where that's sort of implemented in that synthesizer?
Yeah, so it's the synthesizer that's responsible for going through, taking all that CDK code and outputting currently the CloudFormation, as well as how to generate assets and all those sorts of things. There is a lot of complexity there that Josh covered in there, and you could probably spend 5 hours talking about it in general. It's a very complex process. For example, one of the things that I believe Terraform did early on was, and we talked about it, I think at last year's CDK day, is they built a custom synthesizer that took all that CDK code and output Terraform code instead of CDK, which is a really cool option if you want to keep all of your CDK code as your resource definitions, but you want to use Terraform as the provisioner rather than CloudFormation as the provisioner. I haven't ever tried it myself other than a couple little demoware things and seeing the talk last year, but that's kind of the gist of it. I think what would be really cool with it.
Very cool. Well, so I think Matthew, when he talks later today about Ansible, I'm very curious to see if that's the approach he uses and if that's what's going on. So if you want like sort of follow-up applied application of this default synthesizer stuff, that's probably the talk to check out.
Yeah, and that's going to be here in just a little over 3 hours here on this track, Matthew Rawlings. So tune in there if you want to see a little bit more about how the synthesizers work. It's very cool stuff.
Yeah, very cool. So who's up next, Matt?
Next up, we have Kuba. I hope I'm saying it right. Cuba? How do I say it?
Yeah, you're doing great.
Kuba? Okay,
Yeah,
I love the name.
Cuba. Yeah, hi guys.
Hey,
Hey, how you doing?
I'm not too bad. How are you? How's CDK day? I can see from the comments that it's doing great. Yeah, you guys
So
are.
far, so good.
Yeah.
Do you have a presentation that you can share with us?
Yeah, I had a little bit of presentation. The main part will be just a demo.
Okay.
As we all love it. So let me just share the screen. Okay. hopefully, right, this one. Okay. Can you see the
go.
presentation? Yeah, awesome.
Perfect.
We'll be shifting gears a little bit.
No problem.
So
It's all
from
you.
this, yeah, thank you. Hi everyone. So we will shift gears, from talking deeply about the technical details, which is always fun, to a little bit more, I would say, lightweight subject, but I believe that it will be, it will be significant in the future. So we'll talk about creating our favorite CDK applications using generative AI. So quick question for you guys. Have you ever used anything like GPT? I'm sure you've played around with it, but have you used any kind of a DALL-E or something like that to generate images, generate text, or generate the code? Anyone have done that? It seems that I cannot see the chat for some reason. Okay, yeah. Any Gen AI users? Yes. If not, yeah, awesome. Okay, so here we'll focus on generating the code, right? And we'll see a little bit how this actually works with CDK. Okay, so you'll be able to compare how this works with the Code Whisperer, the differences between that and GPT. I live in Gen AI. That's awesome. Yeah. So we'll talk about hallucinations. One of the features, or a bug, of the CDK application. So this talk is really lightweight. It is designed to introduce you to the subject, to the tooling, a little bit. And we'll do the demo in the middle. It will be pretty simple CDK app just to show you, how this works. So what generative AI? Well, for the end users, it looks like that. We write some instructions that we call prompt, magic happens, and we've got some nice images, text, or code. And in our case, it will basically be creating prompt as a comment in our code, and it will generate something like that. Of course, speaking of hallucinations, one of the features or the back of the solution is that it actually can generate wrong code, right? It can generate different versions of the code, and we don't really know, when we'll get the right one. I mean, it's pretty consistent. When you start using it, you kind of get used to the actual errors that it or the mistakes that it will give you, right? But it's still very, very useful. And in a moment, we'll see in practice how this works. So what's this magic, right? And by the way, feel free to put the questions in the comments if you have any, or just interrupt me. We can, I want this to be very interactive. It's doesn't really meant to be a really heavy presentation, right? So what's this magic? The magic is basically foundational models, which are pre-trained models on a huge amounts of data. Specifically for generating the codes, we have a special flavor of those models called large language models. Now, the problem with those models, or the challenge with those models, is basically that if you want to train one, you need huge amounts of data, like terabytes of data, good quality data. Same goes for compute. It goes in tens of millions of dollars to actually build those functional large language models. And of course, after we do that, you still have to verify that the model, deploy it, host it, integrate it with the workflow. Copy and pasting it from some GPT tool is not really something that's practical in the end. In short, it's expensive, it's time consuming, right? Of course, this all is moving very fast. Yesterday, Amazons have announced Amazon Bedrock, and that might actually make it much easier to customize those models. So instead of training those models from scratch, we'll basically just pick one of those models and then tune it using our custom data. So it's already there, right? It's still a bit cumbersome with Bedrock. It's much easier to do that. It's still a bit expensive, but we'll see how it goes. And I think this is the future, right? But what we can actually do right now. Right. So yeah. So Vidit is commenting about just using the IDE for the solution. So let's have a look. Right. So Code Whisperer, the idea is that we don't have to worry about all of these challenges. Right. We basically have a code generator. It's a general purpose code generator, so it's not designed to be very good at very specific tasks. But it does support Python, Java, C#, JavaScript, and TypeScript. Other languages are also supported, but the quality of the data is not as good as the ones that you can see on the screen, right? Now, the big advantage is that you can get started using it very quickly. You basically have to just install AWS Toolkit plugin for Visual Studio Code or JetBrains. And basically just do a very simple configuration, creating a builder ID account, which is separated from AWS account, log in, and you're ready to go. It takes like 2 minutes, right? What's also awesome is that it's free for individual users. One thing to keep in mind is that you have an option there by default to send data to AWS or to Amazon. So we can basically opt out from that requirement, but you have to do that explicitly, right? It's on by default. Okay. So the big difference between this kind of a code generation and any other solution, even those GPT based, is that basically it will look at the context of your code, right? So when you try to add some new code or modify an existing code, it will look actually at the nearby code, also at the code where you have when there are open tabs, right? So it will try to understand what's going on, and based on that, gives you recommendations, right? So it's pretty cool. And to really kind of see how this works, let's have a look at the very simple serverless app in CDK, right? So this won't be anything complex. Basically, we have our stack, and let's say that we want to just we start a new project, and maybe we need to build some CRUD-based API. So we'll start with just creating a REST API, right? So once we configure the code whisperer, it basically will we have to just provide the comments for it, and it will auto suggest for us the code. That's pretty much it. We also have security scans, which is not really that useful for the CDK, as you know, when you're using especially those high-level constructs. We have a pretty good defaults about that. So now I want to talk about this one. Okay, so let's have a look. How much time do we have? Okay, it should be good to go. All right, so let's build a REST API, right? What would we say to Code Whisperer? Just create an API gateway REST API, and it even kind of suggests to me, the type of the API that I can build, right? And of course, those suggestions, again, here, if it's not really entirely sure about basically the suggestions, it will give those suggestions as comments, right? So I have to uncomment that. And that's great, right? So we still have to import the API gateway, right? And again, the idea here is that we can automate this boring stuff that we do a lot, right? So here we also should get suggestion about importing the right construct library, right? So it's pretty cool, right? So it will actually it looked at the code and it figured that, okay, this construct library is not important and it's not imported. So let me kind of import that. Okay. So next steps, as you can see, this is my prompt, right? Later on, I will talk about this prompt and what do you have to kind of think about when you're writing those. Okay, so the next step, it gives me some suggestions, but let me I want to connect that particular endpoint to a Lambda, right? So let's just create a Python Lambda function, right? And here we have, a couple of suggestions that might not be perfect, right? So it will try to figure out, okay, some kind of a demo Lambda, and I can, with the arrows, I can actually go through different suggestions until I can find the right one. So this is the hallucination, right? Doesn't necessarily, I want to create one from scratch, right? But I can help it out. Yeah.
Don't mean to interrupt, but are you intending to share your screen right now? Because we're still seeing just the demo slide.
Oh, really? Okay.
Yes.
I apologize because it should show the, okay, so it should be the full screen. Oh, I'm sorry about that.
Yeah, no worries.
Yeah. Oh, yeah, so it's entire screen. I apologize. I'm, keep just coding away and sorry about that.
No
so you
problem.
had a piece a lot, right? Can you see it now? Right.
Yep.
Oh, yeah. Apologize, guys. Yeah, sorry. New tool. Thank you, Matt. Right. So what we've done so far is that we basically, build this REST API. And now we are trying to create a Python Lambda function, right? No, it's not. Sorry about that. Yeah, it's not pre-recorded. It's live. Okay. Right, so Lambda function, so we need to help it out, right? We need to somehow kind of suggest code whisper what we're trying to do, and sometimes you just keep coding and we'll get some useful suggestions, right? So here I had to kind of move forward a little bit. Right, but then after I did that, as you can see, I basically just accepting those different suggestions, right? So it's not perfect. It does, hallucinations basically that it tries to figure out what's going on, but it's not perfect. And of course, here I also need to import my Lambda construct library as well. So at this point, it's also, it has to do that. Oh. Right, so it's not perfect, but once it gets into the groove, so to speak, it works pretty well. So basically, all of those suggestions looks good, right? How much time do I have left? Yeah, still have a little bit of time. Okay, so now of course we have to create a Lambda function, right? So we have to go to our project, and we have to create this, in this case, Lambda directory. Of course, there are different conventions here. Let's call this Lambda, and we have to create our handler as well. Right, so this will be our hello.py. And inside that, it will also help me create a handler, right? So my handler will be just handler, right? Very descriptive. And yeah, and it's actually pretty good at suggesting me the basic schema of the handler. That looks good. Okay. Now let's move on and let's connect our Lambda function to the REST API. Right. So another prompt will be this, trigger Lambda. Maybe just use the name of the function, Lambda function from API gateway. Right, and again, we've got the API integration, but of course we still need to have resource, right? It's doing it pretty well, right, at this point. And again, I've done it, many times, and this time it does it slightly differently, right? It's not exactly the same. Okay. Last stop. Let's just output the API gateway endpoint URL. And as you can see, it's also hallucinating at this point, because the CF and output is actually not in API gateway. That's fine. And again, if you know what you're doing, this will be easy to correct, right? So it seems that we are done. Oh, I've got my terminal. Let's do synth. Let's see if we miss anything. Some parsing error on 37. All right, okay. Here we go. Right, so again, not perfect, but pretty good for things like getting started and see if an output, right, again, API gateway, right? Okay. Still wrong. What's that? Oh, I still have to just provide the value, right? Yeah. Oh, output API gate. Oh, yeah, I have two outputs. That's fine. Just leave this one. Yeah, I just generated too much code. Okay. All right, so looks pretty good, and we can deploy these changes. Right. Now, to sum things up, as you can see, this is not, I'm not working on anything in advanced, right? Let me just open the presentation. This is not something that is complex. The important things to keep in mind. So first, always think about that, you potentially can have wrong code, insecure code. I mean, it's pretty consistent when you start working with it. It's like it's a bit like a coding partner, right? It's not the perfect coding partner, but it will kind of suggest you things to, so you can actually move faster. But you have to be aware of, potential problems that it will kind of bring into your code. There's still not a lot of best practices, but when again, things are moving pretty fast. And from what I can see from generative AI solutions for the GPT or from DALL-E, basically the more context you provide, the better the result. The more specific context you provide, the better the results, right? So when you already have code that is built, that's written, and you actually try to modify it, it seems that it's doing a pretty good job rather than starting from scratch. Same goes for the prompt. For those comments, the more descriptive prompt is, and sometimes descriptive means you're actually using the right keywords, unfortunately, right? So you have to experiment a little bit into how this works. My advice would be to, it's great if you know what you're doing and you just need to start a new project, do some prototypes. If you want to use it to learn something new, just embrace, trial and error, right? So if it turns out that, because, sometimes it can actually give you, get you on a wild goose chase, right? So to speak, right? So you have to then basically take the step back and, okay, what's going on here, right? So thank you. We still have a couple of minutes, I think. Hopefully that was useful. Again, we have only 20 minutes just to scratch the surface, but hopefully this is something that was useful. Yeah. Any questions, guys?
While we're recorded. Yeah. So while we're waiting to see if there's any questions that come up over in the YouTube chat, thank you very much. Really appreciate it. It's always interesting to see the Gen AI side of things, and I've been using Copilot now for the last few months, and it's fantastic in terms of just, it's sort of like the extremely smart autocomplete. As you said, it's not always correct. Yeah. But it can save me so much time in just typing out the stuff that I don't want to have to type all the time.
Exactly.
Figure out. So one of the questions we do have: what would you say is the biggest difference between this and GitHub Copilot?
Yeah, I mean, it's really hard to say because I haven't used it a lot. From what I can actually hear from others, is that with CodePilot, first, it does support CloudFormation and CDK, and CodeWhisperer doesn't, right? So if you're working with CloudFormation directly, CodePilot obviously would be better choice. The other, I cannot really say. It's too early to say. I think they probably have their own weird kind of behaviors. I would just suggest try both, right? And specifically for the CDK, I haven't yet used it, but I'd recommend just experiment with those tools. There are a couple of more tools also that you can use. So it's not only Copilot and CodeWhisperer, a couple of more. So just experiment. So that's my advice at this point. Yeah.
Gotcha. Well, thank you very much. I really appreciate your time today, and hopefully we will see you again next time.
Sure. Thank you, Matt. Thank you, everyone. And hopefully that was useful. Take care, guys.
Thanks, everybody. All right, so we're going to move right along. Our next talk is from Julian Michel. He's going to be chatting with us about the AppSync Merged API as an example to contribute to the AWS CDK. So another talk about how we can do some CDK contributions, because we all love contributing.
The story of this talk started a few weeks ago. I'm sitting in front of my notebook and I'm working on a new AWS project. It's a hackathon. We decided to use some new AWS features like AppSync Merged API. Therefore, I'm reading the documentation because I wanted to know, is AppSync Merged API already supported by CDK? Finally, I recognize that merged APIs aren't supported in CDK at the moment. So I decided to contribute it to AWS CDK. Welcome to my talk, AppSync Merged API as an example to contribute to AWS CDK. My name is Julian. I work as Senior IT Architect at a company called XL2. It's a joint venture founded by Audi and Capgemini, and we are doing IT project in the automotive industry. I'm part of the AWS Community Builders program. I think it's a great program organized by AWS that supports the community. I created over 50 pull requests to AWS CDK, so I'm open source contributor. One of the pull requests is the merged API feature, and therefore I'm giving this talk today. Let's talk about the agenda. I will start with an introduction, then I will talk about the feature request itself and the concept. I will continue with the implementation, and I will finish the talk with a summary and some lessons learned. Let's start with the introduction. AppSync is an AWS service to create GraphQL APIs in AWS. So it's an alternative to REST APIs. AppSync allows you to integrate quite a lot of different source services into an AppSync API. For example, you can use or integrate DynamoDB, Aurora Serverless, Lambda functions, and many, many more. AppSync has some benefits. It has typed APIs by default. They are defined in an API schema. Clients have the option to only request specific data fields. Then AppSync only replies an object that contains those fields, not the whole object. That's fine. And something really cool, AppSync supports real-time APIs. So you can define a subscriptions to some object, and AppSync replies the new object in real time if the object is changed. Yeah, Merged API, that's the new feature. It was introduced in May this year. It allows you to combine multiple source APIs into a new merged API. Like seen here in the diagram, we have 3 source APIs and they are combined into this new merged API. Why do we need merged APIs? Software is developed in components or microservices in most projects. And therefore it makes sense to have different source API for each microservice. So you can build the API structure according to your software component structure. The deployment can be done independently. So if you have a microservice with source API, you can just deploy the single microservice without changing the whole API or without deploying everything. And you can hide the internal structure of your project because you don't have to publish 3 APIs because you are developing 3 microservices. That's not necessary. You can just publish the merged API as an endpoint without talking about your internal structure. Yeah, that's the hackathon project I built. It was a community builders hackathon. I worked together with Danielle, Johannes, and Matt, and we built this awesome speaker directory. So speaker can maintain their talks. User group leads can search for speakers, search for interesting talks, and it will help you to organize their next community event, for example. It's online and you'll find it on speakers.awscommunitybuilders.org. It's just the first version. We are still working on it, but I think it's an awesome project because it helps the community. Now let's talk about the feature request and the concept. First, I checked the CDK reference documentation because I wanted to know, is it supported? And I recognized, okay, merged API is not supported at the moment. Then I checked the GitHub issues, GitHub pull requests, because I wanted to know, is somebody else working on this feature? But no information were available. So I decided to create a feature request. I opened a new issue and requested support for merged APIs. Here it is, the feature request. It just contains some basic information that this feature is available in AWS, but it's missing in CDK and I wanted to use it. I didn't include technical information because I also was new to merged APIs. I just requested the feature here. Of course, we continued our hackathon. We focused on the business functionalities. First, we implemented the AppSync APIs without merged API. Then we created merged API based on the level 1 construct in CDK. Here you can see a screenshot at the merged API, and it includes the mapping to the source APIs that are part of the merged API. What did I learn in the hackathon? So regarding merged APIs. A merged API doesn't use a field called schema. It doesn't have a schema definition. Instead, it has resource called source API association that includes the mapping to the source APIs. So I went to the CDK code for GraphQL API, and I thought about changing the schema property to optional. There is an attribute called schema. This one can be changed to optional, but there's also a getter where I can access the schema, and this one can't be changed. It would be breaking change because then the API changes, and this one isn't supported. It would be a breaking change, and breaking changes are not allowed. So my next idea was to create a new level 2 construct to support merged APIs. I updated the feature request, wrote about that I want to create a new level 2 construct. Let's talk about the RFC process. RFC means request for comments. It's a process that is mandatory when you want to create a new level 2 construct in CDK. You will get some feedback. The AWS CDK team and other developers can discuss the implementation, and yeah, it will improve the implementation itself because there is a concept before, and yeah, the review process will be faster because nobody is discussing about the design, because this was already discussed in the RFC process. At the moment, the RFC process will be updated by the CDK team. The new version isn't available yet, so I will skip it in this talk because everything I will tell you about the RFC process possibly will be changed. So yeah, we will skip it for today. But yeah, I've created the RFC issue. It's also a GitHub issue where everyone can discuss. Yeah, at the same time, I recognize the CDK contributors office hours. It's a new event format organized by the CDK team. I think it's every second week where open source developers can discuss their CDK contributions. So if there are questions, if there are some issues, you can join this meeting and talk about your pull request. I decided to talk about the RFC because I wanted to continue implementing it, and therefore I saw, okay, that's a great opportunity to talk about it. We discussed my ideas, and we ended up that a new level 2 construct isn't necessary. How can we resolve the implementation or resolve the issue with the schema property? We decided to deprecate the existing schema property, and instead we are going to introduce a new property called API source. And there are two methods. So first you can define API source from a file. That's the replacement for the schema, because this file also includes the schema, so it's the same functionality. To create a new merged API, there is a method called from source APIs, where you can pass the schema information. So both types of APIs are supported in this case, and you can create new APIs. But what about the schema property itself? I wanted to change it to optional. The solution is we can replace this property by a getter. So as a schema method, that's the getter, where you can access the schema. For GraphQL APIs, it will return the schema, so no breaking change. For merged APIs, it will throw an exception, but that's fine. Merged APIs don't have a schema, then it's fine to throw an exception. So we can implement this feature without breaking change. I think that's really cool because I don't have to go through the whole RFC process. So I could start with the implementation. I had to change some of the existing logic, add a new logic. First, I had to add the source API association, so the mapping to the source APIs. I had to implement a new merged API execution role. That's an IAM role that allows access to the source APIs to read the schema. I implemented the new API source property I just showed you before. I deprecated the existing schema property. There's also a new property called API type, which was necessary. It defines whether it's an GraphQL API or a merged API. After the implementation, I decided to continue with the integration test. Maybe you're asking, why did I do the integration test first, not a unit test? I wanted to see if it's possible to deploy this new merged API in AWS. So I created two source APIs in this integration test, and I created the merged API. I deployed everything in AWS. It was successful, so I was sure this whole concept works. I can deploy merged API based on this new, or based on this CDK construct. Of course, I also implemented some unit tests, for example, this one, to test the existing logic. I added test cases, for example, to make sure that only schema or API source are set. If both are specified, it will throw an error, for example. And I added a unit test for the merged API itself to have the same test case like in the integration test to make sure merged APIs can be defined. I submitted the pull request, and yeah, first feedback. Thanks, I love it. So I'm on a good way. There were some comments like having additional checks, and that was fine. I could implement them. And we discussed the schema property again. I introduced a new property called API source. We discussed this name again, and finally we changed it to definition. So it's the definition of the API, like having a schema file or having multiple source APIs. So I had to change this name again, refactor some coding, just rename the name. So nothing critical, and I could finish it. So I committed my changes, and after this one, my pull request was approved. Thanks. Yeah, sounds great. In CDK version 2.94, this new merged API feature is available now. So let's talk about my summary and lessons learned. So first, a summary, I implemented logic and test cases, so the new feature works. The pull request was approved by the CDK team, and now the new merged API feature is available. Yeah, it took some time. I had to do some discussions, but at the end I could implement it, and I think CDK contributions are no rocket science. So yeah, you have to work on logic, etc. You have to learn something, but at the end I think it's no rocket science. My lessons learned. I think it's quite helpful to interact with the CDK team and with other developers to discuss your issues, to discuss your concept and get feedback. The CDK contributors office hours is quite useful in this case. You have direct contact to the CDK team and you will get feedback. You can ask those questions. And I also want to mention the CDK.dev Slack, and there is a channel called Contributing where you can ask questions, discuss topics, and so on. So thanks for joining this call. I personally learned a lot when contributing to CDK, and I think also you can do it. Contribute new features to CDK. If you have some questions, connect with me on LinkedIn or send me a message on cdk.dev Slack.
All right. Thank you, Julian, for that. We really appreciate it. If you haven't ever considered contributing before the CDK, I highly recommend you check it out. It's always good. It is an open source project, and they are constantly working to improve that process. In fact, we now have with us the CDK team. They have joined us today to talk about the CDK and the current state of things. Let's start off with Adam. Adam, can you introduce yourself?
Yes. Hopefully I'm coming in okay here, not too hot on the mic.
Sound great. Yep.
So, hey everyone, my name is Adam Keller. I'm a senior developer advocate at AWS on the CDK team, and I've been with AWS for just over 5 years now, so it feels like a lifetime at this point. So good to be here.
Thank you. Meg.
Sure. Hey, everyone. My name's Meg. I'm a PM for CDK and CDKs. I rejoined AWS here on August 7th after interning with the serverless application team last summer. Just a little bit more about me. I graduated from Chicago Booth with my MBA in June, and I previously worked for 4.5 years as a product owner on large-scale e-commerce implementations for 4.5 years. So I'm very excited to hear from everyone today, and I look forward to hearing from you over CDK Slack if you're interested in sharing your experience.
Excellent. Thank you. And Evgeny.
Hi, everyone. My name is Evgeny Karasik. I'm a product manager on the CDK team as well. This is my first CDK day, so thank you for inviting all of us. Really exciting to be here. And we will be glad to kind of talk to you forward about what in our plans, what we hear from you, and how we envision taking that product in the higher level of implementation and the satisfaction of our community. So thank you for inviting us, Matthew.
Great, thank you. All right, Adam, take it away.
Awesome. So again, thank you so much for having us here. I know, Matt, for giving us a slot here just to introduce ourselves and just kind of meet the community. So first of all, just really great talks already. Like, I love, Gen AI is all the rage these days, and it's just so cool to have a talk on Gen AI to show folks how, you can leverage tools like, you mentioned GitHub Copilot or, Code Whisperer to kind of be that like pair programmer as you're developing, it's just getting better and better as time goes on. So a really interesting space to keep an eye on. The deep dives in the synthesis process with the CDK, like just so much great content here. So thank you again for having us. So again, we wanted to take the opportunity to just introduce ourselves as the product team here at AWS that supports the CDK. We have, and you've seen some of them in chat, like Momo, for example. I think Rico was in chat. We have a super strong engineering team that's building the CDK and building the product in working with the community as well. But also there's folks on the product side that want to make sure that we're building features that make sense for our customers and that are ultimately making the users' lives better when using the CDK. So we kind of jumped into introductions already. I had some slides introducing us, but Evgeny introduced himself already. He's based in Tel Aviv, but really, like, I will tell you, out of the three of us, our goal is really to just work with the community and make sure that the CDK is working for our customers. And I could just tell you a little anecdote here. So again, I've been with AWS for just over 5 years. Prior to AWS, everything I did was on AWS. So infrastructure as code was not new to me. I've been using infrastructure as code since, frankly, it started. And previously it was config management, and I'm sure folks here can remember the Chef Puppet days. And even before then, when it was just a bunch of Bash and Perl scripts to configure everything that you needed to run. So we've seen this great evolution, and the CDK really changed the paradigm of defining cloud infrastructure and defining cloud resources. And I so vividly remember, I started with, CloudFormation, used Terraform, and, DSLs and YAML JSON was great, but ultimately I always wanted something more. I wanted that imperative power. I wanted to use a general purpose programming language to define my resources because I'm big into DevOps. I love writing code. I love working on the infrastructure and operations side. And I wanted to really, blend those together. So, I used Troposphere. It was great. But when the CDK came out, it was like love at first sight. I felt like my life changed in that moment. And I started, it's weird that I remember this, but I started working with the CDK when it was version 0.37. And I just, it was very young then, but already the promise was there. And just to see, over the past, few years, how far the CDK has come. I mean, now we're at, over 1.4 million weekly downloads and growing. So it's clear that the CDK is here to stay. The community is driving its success. And, we have just a really great team of engineers that are building on the CDK, taking that customer feedback and ultimately just continuing to improve it and make it what it is. So we've also released, just in 2023, we've done some really cool things with the CDK. Of course, we've continued to improve L2 construct coverage. So, you'll continue to see that as we go on and as we iterate that, based on demand and based on usage patterns, you'll continue to see more L2 construct coverage across AWS services. And another feature we released this year that I feel like, and this is just all, my perception here, but I feel like it's kind of flown under the radar, is the policy validation at synth time. So, we're moving to a point where we're trying to shift security and compliance as far left as possible, because there's nothing more frustrating as a developer than when you're writing code and everything looks good, your tests work, you push your changes out, and you wait for the deployment pipeline to kick in and everything goes out. And then about 15 minutes later, an hour later, whatever that is, you get a notification that your code can't progress because you're not meeting security and compliance rules. So ultimately, this is why Policy as Code came out. And this is where tools like CFN Guard, OPA is another popular one, have really kind of become, big players in the space. So the CDK released this policy validation at synth time feature where essentially you can plug into, a tool like CFN Guard and run these rules at the time of synthesis. So you very quickly can know whether or not your CDK code and the resources you're provisioning are going to meet your compliance standards of your organization. So it's not just CFN Guard. There's also other third-party plugins that have been developed as well. So keep an eye on that. If that's not something you've seen or worked with, I highly recommend checking it out, especially if you're on the platform engineering side, security and compliance side, and you're trying to shift those rules further left. In addition to those features, we've also released an improved permission boundary experience via the bootstrap process. So, one thing customers were asking for was they wanted to have more control over those permission boundaries. So when you bootstrap, there's IAM policies that are created that the CDK is, CloudFormation, the CDK assumes when deploying those resources. So this year we've released functionality to basically give customers more granular controls over those policies from that bootstrap process when resources are being deployed. And the last feature I'll mention here is the AppStage synthesizer. So earlier, someone was talking about that really great talk going deep into the synthesizing process with the CDK. And, another component of that when you're synthesizing and, there's that bootstrap process where you create those roles, the bootstrap process creates those roles, the assets, stores them in an S3 bucket, creates those assets in ECR for any Docker image assets. And with this new feature now, you can actually manage those assets at the CDK app level. So this gives you more control. For example, if you're leveraging assets, ECR assets, and you want to add a lifecycle policy to your ECR repository. This gives you that ability to do that. So these are just some of the things that we've worked on this year and that we've released. Of course, there's more coming. So definitely keep an eye. And if there's something that you're looking for, a particular feature, or there's something that just really sticks out that you want, of course, GitHub is a place to do it, but you can always reach out to us as the product team. And we're in the CDK dev channel. You can reach us via email, GitHub, and all of those mechanisms. Now, there's one other thing I want to announce, which is that we're going to launch a new YouTube channel called CDK Live. So I'm really excited about this. Over the past few years at AWS, I've had the opportunity to launch some really cool, channels on YouTube. Containers from the Couch was one of them. We launched in 2020 during the pandemic, and that show has grown to over 20,000 subscribers. And it was just, the idea was we want to reach the audience and kind of meet them where they are. So, with CDK Live, we want it to be your go-to source in addition to all the other great community sources that are out there for anything related to the AWS CDK. So it's going to be a live show. We'll have pre-recorded content, and it's going to be a blend of tutorials, deep dives, and various interviews with industry experts. And some of the folks that you see here, in the chat that are building the CDK, these engineers that are really amazing that I've talked about, we're going to have them on CDK Live walking through various features of the CDK that they just know like the back of their hand. So it's really exciting. Right now, if you go to the channel, you can hit that QR code. Please subscribe. You can expect in the next month to 2 months, we're going to start churning out some really great content and live shows as well. And also, I look forward to having some community members on. It's not just going to be about the AWS side, but we want to hear from the community. And I've already talked to some folks who are really excited to join. So keep an eye out. Please subscribe. And now that was all. It was not really a huge presentation, but now I'd love to open it up for some Q&A. Or if Evgeny and Meg, if there's anything you want to add, please feel free.
Yeah, I would like to add a couple of things, and thank you, Adam, for recapping what we did so far. But I think more to come, and we have very exciting features that are currently working on, right? So first of all, I also answered some questions in the chat. I know that people really kind of disappointed, to be honest, with regards to the performance of the solution, right? And again, there are the majority of the roots of that performance slowness, let's call it, are in the CloudFormation. But this is something that they're working with the CloudFormation team to improve, and therefore we should expect that performance-wise, we will see a little bit different experience from what it was today. This is something that you should expect by the end of the year. And it's not that just on the CloudFormation side, we're also going to implement some adaptations on CDK side as well. So that's about the performance. Another that I believe is really important is migration to CDK, right? How fast we can basically move from either unmanaged cloud resources or cloud resources that were provisioned by the other tools, irrespectively how. But ability to jumpstart with the CDK, we see it's a great kind of jumpstart or starting page for you, right? And therefore, we are going to introduce pretty soon CDK migrate capability, which is basically ability to take CloudFormation template and auto-generate some CDK code using low-level abstractions, which are the advanced abstractions. And this is a starting point, and then from there you can start developing further by kind of modifying it and augment it into the more high-level abstractions and so on and so forth. So CDK migrate, take a look on our documentation pretty soon. We are going to speak about that as well, and there are further kind of partnership that we're going to implement with CloudFormation team to make it even more holistically over there, but this is more towards reinvent. Last but not least, most voted feature in RFC today is the refactoring capability. Right, the refactoring capability is the ability for you as a developer to modify the resources and be kind of smart enough, not just recreating them from scratch all the time, but to be smart to use the existing resources, relocate them either inside the tree of the application or in other stack or so on and so forth. So we plan to start working on the refactoring capability. RFC is already open. I can share it with you. So we would like to get your comments, feedbacks, and kind of directions, because this is very huge kind of a topic for us. But your feedback basically will help us to properly focus on the requirements. So this is something that Q1 we probably going to kind of running through the implementation process already. So call for action for you. Go to that RFC, review it again. Please add your more feedbacks and comments. And this is definitely something that we are going to look into. Thank you. Maggie.
Nope, nothing to me, nothing from me, except I still would love to hear feedback. So I was being genuine when I said, feel free to reach out over the CDK Slack. Would love to hear from everyone on their experience with the CDK and CDKs. So thank you.
Yeah, maybe worth also another comment about the community contribution, right? Because I would like to use the opportunity again. Thank you for inviting us. So to be honest, we got a feedback that the contribution process that we have today for the CDK is, let's call it, less optimal or far from being optimal. So this is something the team is currently looking into. Just to set the stage, we have people that are working on CDK at AWS. But if you are speaking about the maintenance or maintainer of the CDK repositories, we have something between 3 to 4 people that are actively working as a maintainers all the time, right? And therefore, we need to be very sharp with regards to how we envision that contribution process. And currently, we figure out that not all the processes that we have in place are suitable for very specific tasks. And again, there's various ways to contribute, right? You can contribute by submitting an issue, you can contribute by creating a pull request, and so on and so forth. Or you can also contribute by creating an RFC. So for the pull requests, we managed to reduce the turnaround time for the pull request from 5 days in June to only 2 days in August, and keeping that 2 days turnaround time for September as well. And we are kind of continue to monitor that and basically see if that's something that we can improve as well. We also introduced the office hour that was mentioned earlier, which also can contribute in that regards. And next on target is an opinionated abstractions, the L2s creation. We kind of figure out that the RFC process may be not the best way to manage those, because it leads to a lot of kind of interaction and fragmentation in the process and not contribute to speedily delivery. So we are going to focus on this one. We probably will get your feedback as well for those kind of changes, and something that we currently trying to introduce. But again, I wanted to thank you all for your contribution, regardless if that was implemented or not, right? This is the nature of the open source. We have very limited resources that we need to prioritize your feedbacks, contributions, and so on. We are going to cover them as fast as we can, but we need to resharpen our process and to reorganize our processes, and your help also going to be very important here. So thank you for your patience first, and secondly, we will come up pretty soon with some changes in the process that they probably will make your life as a contributor better, and your feedback is also required for those changes as well. Thank you.
Excellent. Thank you. So a couple questions that came up in chat that I wanted to just go ahead, and I'm going to put you guys on the spot here on it. Is there anything about V3 that you guys can talk about?
Ooh, Evgeny.
Yeah, so CDK V3, you mean, right?
Yes.
So we know that changing major version, let's call it, is very significant it's very significant event, let's call it, right? And not always that event is easy for the customers. And we still have our CDK users that are on the version 1, right? Even we deprecated it, I believe, 1st of June, right? So currently we don't have immediate plans for the V3 simply because there is nothing substantial that is required us for changing our version from one major to another. So we are going from 2.99 to 2.100 and so on and so forth. But again, I'm not saying that we are not going to introduce, CDK v3 somewhere in the future. Once and when it will come up to the place that we will see that there is a very significant reason for changing a major version, then we will immediately start it with some sort of RFC, let's call it, right? And our vision is that, first of all, we should provide you enough time for the migration once that event will be planned. And secondly, it should be very substantial in terms of kind of an intent. So it will be really make sense for you as a users to do that migration, right? And this is not the point in time today, right? We don't have such major kind of requirements that moving us or forcing us to introduce V3.
Gotcha. Excellent. Okay. Well, thank you, everybody. We really appreciate you coming in and joining with us today. As you mentioned, if anybody wants to contact the CDK team, the cdk.dev Slack server is the best way to do it. They are always watching. So thanks, everybody. Have a wonderful afternoon.
Thanks, Matthew.
Yep.
Thank you.
All right, Michael, how you doing?
Oh, I'm good. I'm good. I grabbed some coffee while I was away. Powered through it. I did 10 push-ups. Just
10?
randomly. Yeah.
10 push-ups?
Well, it's
All
not
10
really
of
like
them?
it's not a fitness thing. It's like a mental
Oh,
percolator thing.
okay. I'm gonna do some jumping jacks then while I'm off camera.
That'll work. Pull-ups is where 10 is significant.
Fantastic. Well, I will let you go ahead and get us started on the next talk.
Awesome. Thanks, Matthew. Next up, who do we have next up? Next up, we have Pawel. Pawel, and then I'm gonna try my best. Adaszewski. I think I did a good job. Let's go ahead and get you going and get the next talk in this next series. Here we go.
Hello everyone, I'm glad to have you here for my presentation on automated applications deployment in a multi-instance architecture. Just a couple of words of introduction from me. I'm Pawel and I'm a senior software consultant at Zeiss Digital Innovation based in Görlitz, Germany. My day job is centered around AWS. I'm developing serverless applications in CDK, and I'm also involved in architecture creation and evolution. All of this currently in the industrial IoT and manufacturing universe. You can find me on GitHub and LinkedIn, and I look forward to connecting with you there and answering any topic-related questions you might have. My goal for today is to explain what I actually understand by multi-instance architecture and when you should use it. I also want to give you a strategy on how to automatically deploy applications in such an architecture, and of course, give you some information on how to do this in CDK. All this to give you a simple guide to satisfying the application needs of your multiple enterprise customers from a single code base. All right, but first, a little backstory on how we actually came up with this architectural design. At the very beginning, we had an enterprise customer who needed a cloud application to run in his own AWS account. He told us all the requirements, and we, of course, implemented the CDK application accordingly. We did not have access to his account to deploy the application, so we had to give him the deployment file so his operations team could actually install it. Long story short, he was very pleased with what we had done so far and told his colleagues, basically other enterprise customers, about the application. They liked the idea and contacted us to ask if we could provide them the same application, but tailored to their needs. Means nothing other than customized for them. This is where the fun actually begins. We were a team of 3 developers and had to scale the application horizontally and also in different flavors. So all these customizations, right? We accepted the challenge, of course, and started thinking about how we could build these multiple applications from a single code base, because creating and maintain repositories for each of the customers would be too much for our small team, and also it would be too much overhead at the end of the day, right? So you might actually ask, why not software as a service? So we could not build a software as a service application simply because of the requirements. Each customer required the customized application to run in his own AWS account, installed, operated, and monitored by his own operations team. So after some research, we came up with the idea of a multi-instance architecture. As you can see, the use case is when multiple customers want to run the same application, but with different customizations in their own AWS accounts. So means they have full control over it. In our case, because we built sort of data lakes / warehouses, we had to provide different kinds of data ingestion and normalization methods for each customer. We realized that with smart implementation, we could do this from a single code base with our small dev team. We actually started with 3 developers, and only after, I believe, almost 2 years, when we had launched already multiple instances, we introduced a new colleague to the team. And this is because we also actively evolve each of the instances as new requirements arise. Life with enterprise, however, is not so simple, as you may probably know, right? After the initial excitement of making a cool product, we quickly ran into the barrier of legal approvals, licenses, open source approvals, vulnerabilities checks, and so on, so on. The operations team from the customer has to get the approval to install and or update the application we are providing to them. So the question is, how to do that with as little pain as possible. We analyzed the situation, and the result was actually quite simple. We built serverless applications, right? So we ship CloudFormation installation templates that require no approval because, they are just JSON files that are installed in an already approved AWS service by the customer. So what do we need to check against all the legal stuff? And the answer was, or is, the Lambda functions in the applications. So to make the customer happy, we have to provide all the legal documents per component, which may have some Lambda functions, and make them available to the operations team. They get the approval and can proceed with the installation or with the update accordingly. As you probably may know, these approval processes can take a long time. But I will show you later on how we managed to speed it up in our case. All right, let's jump straight into automated deployment process. The goal is, of course, to automate everything. When you think about automated deployment, you can immediately link into CI/CD, and that's correct. So we built our development, integration, and production pipelines to deploy the applications. But as I said, we cannot deploy the applications cross-account because we do not have access to the customer accounts. And for dev pipeline, it was not as relevant. We used our own accounts to test the deployment process to make sure everything installs and updates correctly. The question was, however, how to handle the integration and production stage. These stages must run on the customer's account because of the active data handling. We already knew about the AWS Service Catalog, which provides the ability to share template files with other organizations or accounts. However, the problem was that at the time, it was not possible to automate the sharing of assets, such as bundled Lambda functions from the CDK Bootstrap bucket, so that the implementation, or rather the installation in the target account, would simply not succeed. Long story short, we did some custom scripting as a workaround and spent almost a year working with the AWS Service CDK Service Catalog team on this, and it works now. So all you have to do is define an additional bucket for the assets, and you can use the level 2 constructs right away. It should work without problems. So back to the int and prod pipeline problem. The solution is to deploy stacks with a service catalog portfolio that contains the product we want to deliver, and this per customer. Each portfolio needs to be shared with provided account or organization. All of this can be, or now can be, automated with CDK. The stacks are independent of each other and can be deployed in parallel without problems. So let's dive deeper on this and move to the section on how to do that in CDK actually. Let me show you how we did this in our implementation. I'm going to focus on the production pipeline because the integration pipelines look just the same and the development pipeline is just for our internal checks and deployments, as I said before. We define our CI/CD in the lib directory, means on the top of the CDK project. The pipeline has its usual steps like build, assets, update pipeline, and I believe these three, yeah. The last step is essential, and it is the wave, which consists of several stages in which the portfolio stacks are deployed. Basically, the pipeline looks over the customer's array and creates the desired number of stages. When a new customer is added, the update pipeline step refreshes the pipeline and a new stage can be found. So the wave construct actually allows to deploy the stages in parallel. Now, here's what the stage looks like from the inside. As I said, the stage creates a stack. This is a custom stack created by us that requires a configuration property that is unique to each customer. Inside the stack, there are already AWS Service Catalog constructs. First, the portfolio, which is shared with customer's account and holds all the products. And inside of the portfolio, you have CloudFormation product or products, which is built out of a product stack. And this product stack, this is actually a CDK class, which creates the product template that is being deployed. Product template, like the JSON file, basically, at the end of the day. And inside of that, of the product stack, there is an asset bucket for sharing the assets with the resulting products. And of course, a generic customer construct, which is what we want to deploy in the customer's account. So the next unknown is actually what the customer construct looks like and how do you manage multiple of them. First, how we agreed to manage them. We explicitly wanted to have a monorepo, so we created a customers directory at the root level of the project, and each customer is a new node package inside that folder. Smart implementation allowed us that the versions of the product can be tracked separately for each customer. More on that later on. A word about the little shared lib directory you see on the slide. This is a place where common level 3 constructs are located that are used to build the customer constructs. In simple words, modularization and reusability. This is also a separately versioned node package that affects the customer packages when updated. Now for the interesting part. Generic customer construct. Each of these must be based on an abstract class in order to be instantiated correctly in the portfolio stack with the given configuration. In addition, each uses our custom-built level 3 constructs from the shared lib, which I introduced on the last slide. And actually, we call these our Lego pieces for building our customer constructs. These are highly configurable. Furthermore, if we get custom requirements, we can add some level 2 or level 1 constructs to the customer construct to satisfy the requirements. But yeah, however, the intention is to build as many reusable constructs as possible, but some of the customer needs are very unique, and there is no need for doing that. All right, back to the legal approvals. We use the Black Duck GitHub action to make a scan of each package for the legal documents. This is a tool for software composition analysis. When we do a release, we simply add the results to the new version, and the operations team has access to them. By the way, I also recommend the Release Please tool from Google for monorepo versioning. It is not perfect, but it is actually enough for versioning the different customer applications separately. It would be great to use Progen for this, but it does not support monorepo versioning yet. So Progen team, make a PR on that. So this combined with a proper Git workflow triggers all your pipelines and makes automation a breeze. In our case, AWS code pipelines, but you can use any tool you like. I saw a cool approach actually for doing CI/CD in GitHub Actions only, and I have to say I'm going to try that approach someday. All right, so a little bonus here. We started using the class called Product Stack History. With this class, we are able to incrementally deploy the versions and let the customer choose which version he wants to install, not just the latest one. The resulting product templates are stored in the repository, and therefore we can reference them in service catalog. It is actually a cool feature, but note that this class requires some workaround code and is a point for further improvement by the CDK team. And as far as I know, they are actually working on it. And as you can see from the properties, the current version name can be set during synthesizing. If current version locked is set to true, this version cannot be overridden. Then validate template. Validate template prevents actually an invalid template from being saved. And the directory prop points to a directory where all versions are stored. When we do the release, we run the release please GitHub action, which creates the new version in that directory. So, and the second bonus, as I mentioned earlier, we have gotten to a point where legal approval is done very quickly. And this is because of event bridge pipes were introduced a year ago on the reInvent. We quickly implemented this solution in our application in combination with a step functions approach in the transformation step of pipes. And this is because we wanted to have any lambdas in between or any glue lambdas. As a result, we only have lambda functions for domain transformations that have no dependencies, just raw TypeScript code. If we do not have any packages to check true legal, or I mean, we have just configuration of pipes, no transformation or transportation lambda code for that, then the operations team can do the deployment right away. I know, I mean, this is not always the case, and you have to use sometimes external libraries, but in our case, we had only some AWS SDKs and maybe some logging libraries, I believe. However, I just highly recommend using event-rich pipes. It's a great tooling. So, moving to the conclusion now. Now you know how to implement a multi-instance architecture, automatically deploy the product and share it with your customers. I showed you possible use cases for this architecture. Cross account directly from the pipeline. On the other hand, I have given you an overview on how to make the software approval friendly and also how to implement a uniform handover process of your application. This with use of service catalog, AWS service catalog. And do not forget, this is of course our way of doing it, which is in our case, or which in this goal. So I encourage you to experiment with this concept. And just a small comment on the implementation details. I didn't go into the code because I wanted to show you the concept, not the final implementation, which I leave up to you. If you're looking for help with this, feel free to contact me and I will be happy to assist you. All right. Thank you for attending this session. And let us connect on the socials, right? If you have any questions, do not hesitate to ask me there. So see you and bye-bye.
I'm gonna do that probably like 5 more times today. And my only cue is that my dear friend Arthur here isn't signing. But I wanted to say, sorry for the technical difficulties, but the fortunate thing is that we had all of that amazing technical content already out of the way. So a lot of good information there. Again, the talks are recorded, but I'm going to keep this train moving along. Next up, we have Serverless Hero, right? Ryan Isenberg is going to be giving his talk next up. Go ahead and take it away, Ryan.
Hi everybody, my name is Ryan Isenberg and today we're going to talk about AWS CDK best practices from the trenches. So I started to work with CDK back in 2020 and I had the privilege of speaking at the first AWS CDK day, and I spoke about how CDK helps us at CyberArk to really accelerate the development of serverless applications and how awesome it is to write code for defining my resources. And the more I worked with CDK, the more I realized that we're running code, so it's very powerful. We can do whatever we want. Now, the thing is, with powerful tools, it's really easy to make mistakes. And as Uncle Ben says, with great power comes great responsibility. So you need to really understand what you're doing so you don't make mistakes. And this is what my talk is all about, best practices. So we're going to talk about CDK application guidelines, construct guidelines, security guidelines, resilience guidelines, and some general development tips. Now, these are my opinionated versions of best practices, but I think they are good for most people, and some of them are universal. So, a little bit about myself. I'm a principal software architect at CyberArk. I'm an AWS serverless hero, and I own and maintain my own website at runthebuilder.cloud. Check out the link or my QR code here. And I write about CDK, serverless, and AWS in general, so check it out. Let's start. So, CDK application guidelines. The way I see it, when I start to write my serverless service, that's what I usually develop, I start with a new GitHub repository. And the main theme is that it has one business domain, should be maintained by one team to keep it simple. And then I have one CDK application, one stack, multiple constructs that might have relations between them, and one CI/CD pipeline. And that's it. Very simple, small blast radius. I've seen use cases where people have multiple applications in their CI/CD pipeline in one repository or multiple stacks. And I don't think that's right. I don't think that's the best way to do it. And why is that? Let's assume that we have multiple stacks in the pipeline in one repository. So the first stack is deployed successfully and the tests are okay. And then you deploy the second stack and there's a problem. Now what do? Do you have like this unstable state? Do you revert the first stack? What do you do, right? So don't go there. Let's keep it simple. One CI/CD pipeline, one repository, one application, one stack, simple. So there are use cases where you want to take one of the constructs and turn it into its own stack and put it in its own repository with its own CI/CD pipeline. When do you do that? So I think the rule of thumb is when a different team is going to take care of that construct and turn it into its own service or microservice, or this construct is becoming bigger and it has its own business domain, so that's a good use case. But it comes at a price, right? So you don't want to oversplit things because it increases the development complexity when you develop features across multiple repositories. So you need to synchronize the changes, perhaps use feature flags, things like that. It gets more complicated if instead of doing everything in one stack. And in some cases, you need to share in deployment time parameters. Let's say you have a stack for Aurora and it's a cluster. You need to share the port and the domain of that Aurora cluster with another stack in another repository that uses that cluster. So it becomes more complicated, but it can be done. You can use SSM, you can use Cloud Map during the deployment in CDK to solve these dependencies. Right, let's talk about project structure. Now, I've seen lots of variations across that. The way we do it is we have a folder for our CDK code, our service code, the business domain, and we have a folder for tests. So you have, for testing, you have unit tests, integration tests, and end-to-end. And if you want to check out how I do that and what's the reasoning behind that, you can check out the QR code from my blog post about it. And for security and CDK tests, we're going to check it out in a few moments later on in this slide. So now that we understand how the project looks like, let's say that we want to create another project, right? We want to create a new microservice. So one of the things that we saw at CyberArk that really accelerates development is to have a self-service template project. So it really helps us to create a new service from scratch with all the best practices in CDK, with the CI/CD pipeline, with all the business domain SDKs that we want to have, all the internal SDKs that you want to use, observability best practices, things like that, built in, simple to deploy in a click. It really accelerates the development and really helps you to create a new service instantly. So I've created my own version, an open source version. I call it the AWS Lambda Handler Cookbook. You can check out the link or the QR code and basically get started with these best practices and other best practices for serverless that I present here. So let's talk about construct guidelines. The same way that you don't write all your code in one handler, like all the Lambda functions, you don't write it in one file, then do it in CDK. Don't define resources in the stack other than constructs. Okay, constructs are usually, I want work with constructs. That's the basic unit that you have. The stack should have constructs, multiple constructs. However, there is an exception for that. If you have, for an example, a Lambda layer that you use across multiple constructs, you should definitely define it on the stack level. But other than that, you should have different constructs. And I'm going to show the reasoning of how I define and build these constructs in a minute. So constructs, why use constructs? Because you can share them. They're very easy to share across the organization. So which brings me to the next point. Share constructs across the organization. At CyberArk, the platform engineers usually own and maintain these constructs. These are constructs that have all the best practices for security, cost, resilience. These are tested constructs that developers can use and save time, right? You don't need to reinvent the wheel every time. And now the con is that you really require good documentation and you need to maintain them, and you keep versions, right? In Python, we have versions for libraries that we share, which means that at some point when people upgrade, they might break or delete resources by mistake. So it's something that they need to make sure that they don't do. And we're going to talk about how you make sure for backups and resilience, how to make sure that doesn't happen. So just a thing to keep in mind when you have an external dependency like that. Some examples for constructs that you want to share across the organization. Maybe you have web application firewall rules that you want to share across the organization so everybody uses the same rules. Maybe you have an SNS to SQS pattern with encryption at rest, which is not enabled by default. Maybe you want to have AWS app config, dynamic configuration constructs, or an Aurora cluster with all the security best practices. Things like that are easy to share across the organization. If you want more ideas, you can check out the links that I've added for serverless lands, CDK patterns, things like that. Okay, so we understand that we need to use constructs. We understand that we need to share them. How do we build them? How do we model the constructs? Let's take a look at this service, example service. So in this case, I have two parts here. I have the CRUD API. I have an Amazon API gateway, triggers two Lambda functions that write to an Aurora serverless cluster inside a VPC. And I have the asynchronous parts. I have an SNS with an SQS, and I have a Lambda function that is triggered from the SQS. And I have another Lambda function that is triggered from the Aurora streams. So you see there is a connection between the two parts. They have the CRUD and you have the asynchronous part, but there are two domains basically. And this is how I basically model the constructs. I have one construct for the CRUD and I have one construct for the messaging, the asynchronous part. Now, the Aurora part, I'm going to add as another construct because it is complicated, and I might even import it from the constructs that are shared across the organization. It is its own thing. I might even put it later on in its own repository, its own stack, because it takes like 20 minutes to deploy it. So I want to deploy it once and have all the developers use it. It's a possibility, but it's a construct that the CRUD creates, right? It's an inner construct inside the CRUD construct. So I have two constructs. I have the CRUD, I have the messaging, and they have connections between them. So this is how I would model it. Now, this is my style. You can do it however you want, as long as you can find whatever resource in the code, whatever makes it more reasonable for you to maintain it. So it's just my version of how to do that. I think it makes sense, domain-driven constructs. So let's talk about security guidelines. How do we handle secrets in CDK? We store them, we deploy them in CDK, and we consume them in runtime in our Lambda function in our service. So first of all, never, ever, ever write hard-coded secrets in your CDK or configuration files. Store them as secrets in GitHub Actions or in Jenkins files or whatever. And then when you need to deploy them, you send them to your CDK code as constructor to the stack via environment variables and things like that. And then the CDK code will basically deploy the secret secrets manager as a secret, or SSM as an encrypted string. And then in the Lambda function, you provide the Lambda function an environment variable of the secret name and the permission to access the secret, and then it can use the secret in a secure manner. That's how you do it. Now, when you define constructs, basically all the higher abstraction constructs like the L2, L1, sometimes they have defaults for security, right? Now, sometimes security defaults are good, sometimes they're not. It differs by the construct. And I did notice that AWS does get better at this over time. Like they added this year the S3 encryption by default for new object. DynamoDB does encryption at rest. But if I look at SNS topic encryption, I mean, the last time I looked, SNS topic encryption at rest is not enabled by default. So you need to go and configure it. And you need to think about it, right? You need to know that, hey, I'm gonna look for any security flaws and I'm gonna fix it. So there is a shared responsibility model, right? AWS secures the cloud, but we secure the resources inside the cloud. We define them, and we need to make sure that they're secured. So you need to keep that in mind always. And you can't expect AWS to do all the work for you. So make sure that you define all the resources that you define. You think about security, have security reviews, schedule penetration tests, and also you can have some automated tools like CDK-NAG, which can scan your CloudFormation output before you deploy it to AWS and notify you if you have some misconfigurations. This is a great tool, and I've added the link here in the QR code and in the link here, so you can check out how I implemented it in the cookbook and just basically do the same thing. Okay, another important issue is IAM policies. I've seen that, let's take a look at this function. It creates a Lambda role that accesses a DynamoDB. And in this case, I might require only, I need to get an item and put an item. That's all I need from my role. But I've seen people use the inner abstract functions like grant, read, write data, and it's great. I mean, it looks very nice. It's very clean. But it's not good, right? It's not good enough, because you're getting, instead of 2 extra permissions, you're getting like 11 permissions to the role. The role is not least privilege, right? So if somebody were to gain access to this role, malicious user, he would be able to create a lot more damage to your table because he has more permissions. So you don't want to do that. You want to be sure that you really understand what you're defining and it's really readable, and you define only what you need for that role. So the way to do it is to use inline policies. And here I can define a document, an IAM document, and an IAM statement. And I define exactly all the actions that I need are put item, get item, on my table ARN, and I allow it. That's it, bare minimum. And I also think that if developers use this mechanism, well, they're going to understand IAM better, and it's going to make them into a better developers. That's how I see it. Let's talk about resilience. Now, each resource has its own logical ID. It's unique, and if you change that logical ID, the resource is basically, the old resource is getting deleted and a new resource is getting built. Sometimes it's not that bad. However, sometimes people might have innocent refactors in the code. They just move some code around. They think, yeah, I'm going to move one item from one construct to another. Maybe I'm going to change another ID, and maybe I'm going to change another ID. And it might be very naive, but they might have dire consequences, okay? Because in stateful resources, this means that you're basically deleting the database with all the information, like the customer data, and creating a new empty database, which is horrible. Or even if you have roles that you use for cross-account access to assume, if you change them, then you basically break production, okay? So it's critical that people are aware that changing IDs is dangerous, okay? And in some cases, we also had issues with CDK raising an exception. Somehow that exception during deployment got caught and CDK continued the deployment. So some resources got actually deleted from the CloudFormation. It can be a table, it can be a bucket in KDP, whatever you do, right? And it really depends on how good your tests are if you catch that. So in order to prevent that, you can write unit tests for CDK. Let's see. So in this case, I write a unit test that runs prior to deployment. I synthesize the stack into a CloudFormation template, and I ask, basically, I make assertions about the CloudFormation template, and I want to make sure that some critical resources are there. I can check out that the API gateway is there. I want to check that my table, DynamoDB table is there, and then I can make assertions on the logical ID that it does not change, because if it changes, I'm going to lose all my data, right? Not good. So this is one way to do that. Another way to add visibility to changes is to add this utility CDK diff. It basically adds another comment in your GitHub PR and tells you exactly in a visual manner what resources you're adding and what resources you're deleting. So it's really easier for the developers to understand if the creator of the pull request is making a mistake. Let's talk about backups. So let's say that somehow a resource got deleted. We also want to make sure that we have retained policies. Even if the resource is going to change IDs, maybe we don't want to delete it. We want it to have retained policy in production, right? So it's not deleted. So in production, I'd say use retain policy. So database stateful resources are not deleted. But for developer stacks, yeah, definitely delete the stateful resources. You don't need to pay for them, and there's basically no need to do that. So a simple if statement in the code, if I'm in dev state, use delete, otherwise retain the resources in production. Now, obviously, you should back up your stateful resources, use DynamoDB point in time, or Aurora has a built-in backup mechanism that you can use, or even create your own scheduled backups with AWS Backup. But you also always keep that in mind that you should do that. And finally, some general development tips. If usually there is no high-level abstraction construct like a level 2 or even higher than that construct, and you don't really understand how to define the resources in CDK, you can go to the console, play around with the service, and really understand the entities and how they work together. And then it should be easier for you to write the lower-level CDK code to really connect all the entities together. Now, sometimes, on the other hand, there is a higher-level construct, but it doesn't expose all the security options or configurations that you want to use. So you kind of have to use the CFN low level. So keep that in mind. You need to do a bit more work, but it gives you more configuration and flexibility. Now, another tip that I can give is use tags. Tags are great to identify resources in your accounts that are orphaned, or just understand what service, what developer created it. So it's really great to identify resources. And I know that developers, like I said, CDK is basically writing code, and developers love to write abstractions and code. Please don't do cool factory methods and too many abstractions. It should be simple. It's infrastructure as a code. It should be readable, easy to follow. Don't make too much abstraction. I don't mind some code duplication as long as the code is readable. I even prefer it, right? So please keep it simple. That's what I'm saying here. So I hope that it has been helpful for you. Like I said, CDK is very powerful. It's really easy to make mistakes. You need to own these mistakes. For security measures, you have the shared responsibility model, so you need to keep that in mind. For security, we saw how to do the CDK application and stack guidelines, that you should share constructs. You should definitely have a CDK template, self-service, and we spoke about resilience best practices too. So thank you very much, and you can check out my website, runthebuilder.cloud. Follow me on X, right? X Twitter, and LinkedIn. So thank you very much.
All right, Ron, thank you very much. I really appreciate it. So up next, we have a little bit of a different type of talk. Thorsten, why don't you tell us what we're going to be doing here?
Yeah, sure. I hope you can hear me now, because I switched from the administrative area to the stage here. It's such a bliss now to having only one audio at the same time, because Now I had 4 hours of 2 streams in parallel, having, talking to me all the time because I was watching everything in the admin area. So now it's only one stream, and it's really nice to have it quiet.
Yeah, I imagine. It's been a busy day.
It's been a busy day, and it's a great day. So I'm really looking forward to the next, basically half of the day, or the remaining half of the day. But in between now, we have something very special. We have some kind of announcement from something that is not CDK, but might be CDK. Or should have been always CDK, if you ask me. So, without further ado, let me bring on Renee from the Amplify team.
Hi.
And Matthew, you will be back in a second.
I will. Thanks, guys.
Wow, that's a lot of foreshadowing. Thanks for that intro.
So Renee, happy to have you here, and maybe do one sentence about yourself, and then we just take it from there with our secret chat with the Amplify team.
Ooh, secret. Okay, cool. Hi, everyone. I'm Renee. I'm a product manager here at AWS Amplify. And I guess Pixel also just introduced himself. My team is specifically working on making sure people have real-time API and data for full-stack apps. If you're unfamiliar with Amplify today, we are targeting front-end developers and really help them build out their entire backend for their front-end easy. Yeah.
Perfect. And you brought something with you for today. So I will add your slides to the screen and...
Yeah, cool. Everybody can see it. Yeah, looks like it. Cool. So I want to do a super quick recap of just what we do and then jump right into it, right? So our team, as I mentioned, is focused on making sure that people have a great real-time API and data experience on AWS. Now, if you just zoom out of the picture, you've got a front end and back end. Life is super simple. You've got an API. But actually, if you really zoom into it, it's like, oh, there's a lot to build here, right? So in the past, you might know us from Amplify API, from the Amplify CLI capabilities. But effectively, we have some developer tooling that you can run on your local machine that deploys not only the API, but sets up the authorization rules, writes all the logic for making sure that data fetching works out, creates the database tables, as well as connecting it to other things like AWS Lambda. Now, these things typically will require you to write like hundreds, if not thousands of lines of code yourself, and these are kind of repetitive code. So we really introduced this tooling to kind of accelerate front-end developers to get there. Now, how do we do it? We do it using a very simple schema definition language, which you already know if you're building GraphQL APIs. It's just GraphQL SDL. And we add these little oh, sorry, that was a funky animation. We added little directives here that basically enhance capabilities. Like you have an add model, it will create the DynamoDB table to back this up, and authorization rules, for instance, say that everybody can access this particular table. Now, customers like Thorsten have actually told us that this is a great capability and really gets you from like 0 to 100 immediately. But what if you could do it in CDK? So that is what we're announcing today. So we're going to introduce a first-class L3 CDK construct that allows you to just take this schema definition language, fully compatible with all the Amplify features, and deploy it directly using CDK. You can start using CDK. If you can build it in CDK, you can deploy it in CDK. All CDK. As you can see, the CDK box is very excited. It's trying to show going into the demo. Okay, cool. So let's take a sneak peek at what this looks like, and then we're gonna jump right in. Okay, so this is the part where I'm actually gonna switch to live code. So bear with me. Okay.
I believe in the demo gods for you.
Yeah, today it's gonna work. I know it. Okay, if you're a CDK developer, which you should be if you're on this call, this should feel like a very familiar setup for you. You've got your bin folder, lib folders, and so on and so forth. Now, as I mentioned, everything for us starts with the schema. So having a schema definition, like here, there's a type that's called blog and a model that indicates it needs to be DynamoDB and backed by DynamoDB and so on and so forth is already present here. Now, this schema is exactly what I would have written with the Amplify CLI today. Now, in this new world, we're introducing a new Amplify GraphQL API construct. So in here, all you have to do is pass in the schema and you're practically good to go. I've also done a couple of other things like making sure that API keys are properly set up and so on and so forth. So I've went ahead and already deployed this, this particular API. And if I go to my my AWS console now, you can see this API up and running. So I can actually go and create a blog here using, oh, wow, 401, uh-oh. Demo gods, bear with me. We can do this. Okay. Oh, right. So let's actually try to run this again. Great. So I actually just created a blog by running this GraphQL mutation. And the reason why it exists is because I specified it as such in my schema.graphql. So I said, hey, you know what? Anybody who's logged in as part of like this admins group incognito gets to do it. And the reason why it failed earlier and it didn't work is actually expected, because my authorization rule said that, you know what, if you're authenticated through an API key, you're not allowed to create any blog posts. So this is working as expected. And then but if I have an API key, I specified that I'm allowed to read all the blogs. So I'm just going to go run a query here to read the blogs. And you can see it returns me all the data right here. Okay. And so this really goes to show how you can just easily take this developer experience that we've established in the CLI, but really use it with the tooling that you really like or already use in your company. Now, the other factor here is really to showcase how this works well with all the amazing things that the CDK team is already bringing to the table. So one of my favorite features, and I'm sure it's Thorsten's as well, is CDK hot swap. So like easily, quickly changing the logic code behind Lambda and so on and so forth. So let me just show that real quick. In this case, I've got a simple query that just calls a Lambda function to echo whatever I pass in. So I'm saying hello from CDK day, and I really think this warrants some more emojis. I think we need more hearts in here. And so the moment I hit save, my CDK watch is actually already running in the background. It's doing its business, checking if there's any changes to my logic code and deploying it for me. So it says it's hot swap. I go here and rerun my echo query again. You can see all the hearts are streaming through. So super simple demo that just indicates how this easily integrates first class with your entire setup.
Yeah, and at this point, let me quickly interrupt here, because as I'm reading all pull requests on the CDK tonight, so less than 24 hours ago, a new feature was merged that also supports now this watch mode, this hot swap for resolvers like VTL and JavaScript.
That is correct. And that's actually a contribution from our team. So shout out to Praveen who's done that. So yeah, we are doing actually a range of things. But today is not the day to share all of those things. So, but yes, we're also making hot swap work with JavaScript and VTL resolvers.
Yeah, it was merged yesterday, so it will be the next version of CDK.
Yeah. So, wow, you're really on top of things. It's almost as if you're an AWS hero, one might say. Okay, cool. So that's just a super quick demo of just how the setup works. I just want to quickly recap it. So we've got a single definition for your API and data source to really get you go from 0 to 100 super quick. It works with all the Amplify GraphQL directives. So add off, all the relationship ones, has one, has many, so on and so forth. And then also add searchable if you're using OpenSearch. And there is also some escape hatches built in, so you can actually access every single resource that is being generated as an L2 or L1 construct. So really, there's nothing that's hidden from you if you really want to like look under the hood and kind of make those tweaks that you want. And so that is launching next week, but we really wanted to show it to you today because it's CDK day. So for you, because you're all like kind of a little bit early, I just want to kind of showcase what early customers have said. So they say it's like creating something with this feels like cheating, or like the biggest benefits to add off because it's so hard to manually implement authorization correctly and securely, like both factors. And the last part is really for all the organizations that haven't looked at Amplify in the past because they are already using CDK and didn't want to use a different tool set. So some customers have said this is exactly solving their problem of adopting Amplify broadly in their organization. And we want to make sure you guys can walk away with a little present here as well. So if you want to try today before the official launch next week, you can go to bit.ly/Amplify meets CDK and follow me on Twitter for the official announcements next week.
Perfect. Thanks, Renee. Yeah, I'm really looking forward to this because, yeah, I finally can use the CDK project, but still use the cool Amplify abstractions and integrations with these cool directives. Because currently it was an either or, and now it's a both. And that's so cool.
Yeah.
So
and
really,
maybe one thing I just want to say is I also want to thank Thorsten and Kenneth, who've been really advocating this for a long time. So actually, a lot of this started from a conversation that Thorsten and I had at reInvent. So really just to showcase how much the community is actually working with us. And I really love how the community has been helping us get here.
Yeah, I think I used every single opportunity to talk to anybody in the Amplify team about that. So I'm really happy to see this. And yeah, so really thanks for jumping into CDK Day and talking about this cool feature. And it will be live on Monday. So looking forward to this. And yeah, now happy building or go build using Amplify. Okay. So bringing back Matthew. Thanks, Renee.
Bye.
Thank you, Renee. Appreciate it. All right. So we're going to bring Alex in too. So Alex, I know that you're not necessarily the CDK type guys that Thorsten and I are. But I know you've been watching. What so far today do you think has been, one of the more interesting pieces here?
Well, I mean, recency bias here. I just love what just happened with Renee. I love the Amplify stuff and AppSync. So I thought that was pretty cool. I didn't know we were getting new product announcements and everything today. So that was
crazy, huh? Just completely random.
Yeah. So I also just love the two talks I was here for earlier, especially Josh DeMuth on like what's happening with the stack synthesis stuff. I love that deep dive stuff, knowing what's happening under the hood so I can know how to use it better or if I need to tweak it, what that looks like. So I thought that was a really great session.
Yeah. So Thorsten, you're probably the most knowledgeable of all of us in terms of the underlying CDK code base. Is there something else that we should dig deep into besides the synthesizer if we really want to know how the CDK works?
I think the most underrated feature when people compare CDK to all the other infrastructure as code tools is the assets. And I think really assets are the most important thing when we're talking about CDK and when comparing CDK to other things, because building your stuff for you during synthesis is one of the coolest things ever, like building Lambda functions, building your whole front end like Next or Angular code as an asset, building your container images, all this managed by CDK is, I think, one of the coolest things ever. So the asset subsystem is really one of the most important things, I think, in CDK, which really sets it apart from all the other infrastructure as code tools that handle infrastructure, but the assets really handle all the resources that will live in your infrastructure later on. So that's really something that really needs some more love.
Yeah, it makes me actually think, Alex, I want to talk to you sometime about creating like a DynamoDB asset, something that could pre-populate tables when possible.
Like a seeder type thing.
Yeah, we pre-populate S3, we pre-populate Lambda handlers, like all that. Yeah, I think there's a good reason for some DynamoDB stuff too.
Yeah, that'd be really cool. I think that's a great point from Thorsten. I know like when serverless framework or SAM and things like that were taking off, I think the reason they did well compared to just like Terraform by itself was because they were doing that building aspect of it too, of like figuring stuff that out. And then CDK, like you're saying, expanding that to containers, to front end websites, to all sorts of things that you need to do. Just like, infrastructure as code and the simplicity of that is one thing, but then also just like all the other things you need to build as part of that process. If the more you can sort of take that off people's plates without them having to know all the details of creating a zip file or things like that is a huge win.
yeah, you don't need to care at all about how does ES build work to build a Node.js Lambda function or all the things. So your CDK code can be your entry point, and you'll just build all the assets that are needed, which also makes your pipelines way easier. It's just a CDK synth.
Yeah.
And it builds a whole application and all the parts of it. And that's really, really cool.
Yeah,
very
that.
cool. Well, I think we're about ready to move on to the next one.
Yeah, with that, thank you, Thorsten. And go back to my admin area, back to my cellar.
Yes, Thorsten, go back to your cellar, Thorsten.
Thanks for coming to track one and joining us here. Great to see you.
Yep. Cool. Well, Alex, this is all you, so have at it, and we will see you here in about an hour.
All right, sounds great. I'm going to kick you off, Matthew. I'm going to bring on Harsha and Shubham. Welcome.
Thank you, Alex. How's everyone doing?
Yeah, I'm doing well. It's been a great show so far. I'm really excited about this one because I think this is a problem, in CDK world or just anywhere in the AWS world is how do you, especially if you're in like this area where security is really important, maybe in regulated industries, how do you maintain, that compliance, those security requirements while still moving quickly, and you all like working in the financial industries and working with stuff like that. I'm just super excited for this.
Yeah, this is exciting times. I'm a geek about cloud security and just being able to find the right balance between cloud security and developer velocity is something that I've been chasing over the last 2-3 years with Harsha and everyone else on the AWS side of partnership. So yeah, super excited to talk about that.
Awesome. Sounds good. Do you all have slides that you want to pull up?
Yes. So I can share screen and then go from there if that.
Okay. Sounds good. I'll put that on once you pull that up.
Let me share my screen.
And just for background for those watching, like Harsha works for AWS, principal solutions architect, working in like this sort of financial services area, and then Shubham works at Goldman, I believe, right? Working on sort of like the fast track team, and so just thinking about developer velocity that way. And with that, I will turn it over to you two.
All right, thank you for that. Let's get started. So yeah, so we're going to talk a little bit about CDK over the next 20-ish minutes. Who am I? My name is Shubham Shukla. I work for the cloud enablement team at Goldman Sachs, mostly leading the cloud security initiative, building proactive controls using policy as code. And I'm joined here by Harsha Sharma, who's a good friend and colleague of mine from the AWS side. He's a principal solutions architect at AWS. So I know this is sort of like a little more of a casual kind of a conversation, but I mean, we are Goldman Sachs. We are in the financial services space, one of the most regulated industries, and solving for cloud security and developer velocity is at the core of what I do day in and day out. So again, this is sort of like the agenda. We can go in different directions. If I feel like, hey, someone's interested in something else, we can, cater to that. But we'll try to stick to the premise of this talk, which is around cloud security versus developer velocity. The conundrum that we had maybe 2 years back, and our answer to that, which is a platform we built, which provides proactive self-service guarantees for cloud security for any application deployed on AWS cloud. And then we'll talk a little bit about high-level design and everything, but where the rubber hits the road of sorts is where we'll walk through some sample examples and demos before we close. With that, I'll let Harsha drive the rest of this for the stating the problem and diving us a little deeper into the rest of it. Harsha, you want to take it?
Shubham. Yeah, I will. If you can share my screen from, is there someone who can just switch to my screen instead, please? Cool, thank you. So hello everyone, this is Harsha. Nice to be here, and it's a pleasure talking to you all. So very quickly, the problem that Goldman Sachs had was that a developer would have a design ready, and they would have a security posture all documented on a piece of paper, but they'll have to talk to a gated approval check of tech risk advisory and a group of infosec engineers or advisory groups that would look at their design on paper, look at the actual controls they have in place and say, no, you have to go fix this. This does not comply to the Goldman standard. And there'll be a lot of back and forth with this, right? And it would just, with all the right intent that the tech risk advisory team would have, it would just slow down the overall process, because the developer would be unaware of what does right look like, and at times they are not as cloud savvy to actually be able to document things accurately as well in the first go. And all of this is needed just to be able to actually approve accounts for you to be able to vend them out. So the problem compounded because developers would not actually have accounts to be able to test things out well enough to be able to document their application design and the security posture accurately, right? So it just meant that the enterprise that Goldman Sachs is, the pace at which they wanted to move and the reality of the situation were like very far apart. And in an ideal scenario, they wanted a magical box, let's say, where a developer would just express the intent of wanting an account gets created, they push their IAC deployments, and that just deploys the resources. And that magical box takes care of ensuring that all the necessary tech risk controls or suggested threat vectors that need to be accounted for are all inside that contained entity. And that was the genesis of the overall fast track project that we'll talk about in this talk. But it led to an organic creation of 4 tenets that would be the pillars of that magical box, right? The first one is self-service, which is to make sure that the developers are completely independent. There's no central entity to talk to, not just from a design review standpoint, but also ensuring that it's easy enough for them to deploy things in a compliant and secure manner on the public cloud. And over here, there was a lot of bias towards programmatic languages than things like JSON or YAML, and TypeScript was chosen here. And this is where CDK also comes in, where there was a lot of emphasis on making development of deploying resources on the cloud very straightforward and simple. Then there was the concept of that the platform should actually have a degree of shared responsibility, where there will be a platform team that offers that magical box and maintains it. But then there's the app team that ensures that they have the entire control of the app and manage the state of it as well. Then there was the angle of secure by design, the tenet of secure by design, where the actual magical box contained all the necessary policies that Goldman Sachs wanted app teams to follow on the cloud within that magical box itself. And finally, the true power of the cloud needs to be utilized by using a language that's extremely developer friendly, and it should actually be a first-class citizen of the actual cloud that is being spoken to. In this case, AWS CDK was chosen, and Shubham will talk in more detail about that. So that's where Cloud Fast Track came in, where a developer would, and I'll quickly go through this because we'll deal with this in a bit more detail later on, where a developer would express the intent to create a pipeline. They would call a fast track control plane. The accounts would get provisioned through the org's APIs. There'll be one account for SDLC, one for application. There'll be a pipeline that will be inside the SDLC account where the developer would push their changes, which would then in turn deploy resources within the application account. Now, the crux of the bulk of the actual policies or the entire tech risk, the tech risk advisory policies live within the pipeline. And we look at that particular component on this talk as opposed to the remaining, in the interest of time, because we have so many boxes here, right? So in the pipeline itself, there's a developer would push their actual changes, which is an IAC code, which is the CDK code we're talking about. That will get synced into a code commit, which will then kick off a code pipeline, which will actually do the CDK synth. It will download all the assets that are needed and code deploy in one of the code deploys in the code deploy stage, there would be policies or security rules in the form of OPA policies that will be applied on top of the synthesized CDK, and then it will be deployed in the actual application account. The bulk of this talk will cover security rules, because that's where the brain is. And we'll also look at how developers are able to use CDK in a much more easy and accelerated fashion to be able to reach to that end state of a fully formed, approved cloud formation on the extreme right. With that, I'll give it back to Shubham.
Thank you, Harsha. Can I? Okay, awesome. I guess everyone can see my screen again. Fantastic. So yes, security rules, this green little box you see at the bottom is the crux of what differentiates us from any other products, if you will, or platforms, if you will, that we had previously at Goldman Sachs. What are these security rules? These are essentially controls which ensure things like, which is basically me preaching to the choir, trusted principals should only be able to talk to trusted resources, non-trusted principals should not be able to talk to trusted resources, and likewise. So these translate into policies or guardrails, if you will, which look something like, thou shall always encrypt your buckets with KMSCMK. Thou shall always attach a permission boundary if thou creates an IAM role. Likewise. So that's great. So by the way, whatever we talked about so far, we believe in dog fooding. So everything, even the platform that was being built, has been built on CDK using TypeScript. So what does a typical guardrail looks like? A typical guardrail looks something like this. Hey, for a Lambda function as a resource, make sure if you're bundling your Lambda code, it's coming from a bucket that is a vended, pre-approved bucket inside the Goldman Sachs environment. Everything else is non-compliant. So in a way, we've sort of codified, if you will, security proactively right after CDK synth happens for our CDK TypeScript applications. Now, one might argue, how do you enforce these controls? It's great you got Rego policies like such, but how do you enforce them? This is where we basically write these Rego policies. In the pipeline that Harsha was showing us earlier, there is a CDK synth stage wherein your CDK TypeScript application gets synthesized into CloudFormation templates. And these CloudFormation templates then are run against an NPM package we built, which essentially runs OPA binary against these CloudFormation templates and spits out violations of any of these policies that we have built, which we also call guardrails. And since we run all our deployments through a managed pipeline, nobody has a chance to bypass these controls and sort of, let's just say short circuit their way to deployments. All right, so this is all, talk is cheap, right? So we'll go through a quick demo of what this guardrail looks like and how we embedded guardrail into this platform called Fast Track for our customers. So here is a customer journey. I'm a potential customer who has the next $1 billion idea, and I want to just deploy an application load balancer through Fast Track. Great. I write my code for application load balancer. For everyone here on CDK Day, they know this is very basic CDK construct for application load balancer, whether using CDK 1 or 2. One of the guardrails we have, if you notice on line 131, it says internet facing is set to true. But one of the guardrails we have, it says thou shall never enable ALBs, which are internet facing. So what we do is we now synthesize this CDK application by running npm run CDK synth. And also in parallel, I run this command, which we've built called cftp apply guardrails. What apply guardrails does is after the the CDK TypeScript code is synthesized, it will run OPA binary against each of these CloudFormation templates and run those guardrails and see if there are any violations. Now the synth phase is waiting for a little bit. It's thinking, and then it's spawning up some child processes to get the violations. And voila, we have a violation. What is the violation? It says, hey, oops, sorry, I clicked on the wrong place. But yeah, it says the violation is that your load balancer cannot be public. That's why the decision is denied, and hence you cannot deploy your application any further until you fix this. Now I go back to my application, flip the internet facing from true to false, which I already did, and run guardrails again. This time, if the demo guards are happy, we should now see that there are no violations, and I should be allowed to go through the deployment through the managed pipeline. Let's wait for a little bit. It is thinking, it is synthesizing my CDK code. I'm gonna zoom past this phase, and it's applying guardrails now. And finally, boom, the decision is allowed. You have no violations anymore. So this is sort of like how we manage to enable a customer use case and enable a scalable platform where customers don't have to come to us for expertise on cloud security. We embed those as part of the promise of the platform, and customers use the hints that the guardrails provide them in order to make their application guardrail compliant. So, but there was another problem we landed up into. While we solved for the security problem, we sort of introduced this problem of developer velocity of sorts, right? Like we increased the cloud security posture at the cost of customers having to write a lot of boilerplate security code just to conform to the guardrails. So we said, okay, what should we do about it? That's when we decided to build something which was inspired from, again, CDK L2 and L3 constructs. We built an NPM package and a library, which we call Accelerator. Accelerator are custom constructs which are built such that customers are able to create their infrastructure, which is pre-compliant with guardrails, without them having to need to write any boilerplate security code. So this was sort of inspired from CDK L2 and L3 constructs. We built our own out of that. Here is an example. Again, I feel like for a forum like this, it's better to show code than to talk about things. So let me give you some context. In this demo or the screen that you see, on the left-hand side, and well, both of these left-hand side and the right-hand side screen of my VS Code that you see are trying to just simply do one thing: deploy an S3 bucket, which is compliant with all the 20 or 30 guardrails we have in place. On the left-hand side that you see is us using vanilla CDK constructs to create this S3 bucket, which conforms to guardrails. Guardrails like don't encrypt, well, always encrypt your bucket with, KMSCMK. All traffic should be using SSL for encryption at transit and whatnot. So as you can clearly see, if we go this route, we have to have at least 160, 170 lines of code just to create an S3 bucket, which is conforming to our guardrails standards. Which is something that we did not want the customers to having to do just to create a bucket. On the right-hand side, whoops, again, I clicked the wrong button. But on the right-hand side, what you see is us expressing the same intent of creating a bucket, but we being able to do that within, let's say, 20 or 21 lines of code. One hint that might be useful to understand is if you look at line 16, much like cdk.s3.bucket, we are creating a CFT, Cloud Fast Track.s3.bucket. And this is exactly what I meant when I said we've built L2 and L3 constructs, which are compliant with guardrails, and those are inspired by CDK. So in shape and form, they sort of look like the CDK constructs, but they encapsulate everything that we were having to do in 200 lines of code on the left-hand side. So in a way, we managed to sort of solve for the dilemma between security and developer velocity by first building guardrails, which solve for the security piece of the puzzle, and then building accelerator constructs, which are inspired from CDK L2 and L3 constructs to solve for the developer velocity problem. So I'm going to quickly conclude here. So the impact that we managed to make so far, besides, hey, being able to onboard a lot of applications onto the cloud using this platform, account provisioning piece, which was previously manual, required manual tech risk reviews and whatnot, turned from being an enterprise which took weeks to a matter of minutes. Application deployments, which was a high-touch activity here in the firm, turned into self-service. And infrastructure security reviews, which were super manual here, there are no more anymore because we've basically codified infrastructure security as part of the guardrails program. Now, as far as learnings, if I were to focus just on the CDK piece is concerned, if I were to talk about that, CDK constructs provide us a beautiful way to use what's already there, discard what's not needed, and sort of build what you want to choose to take and sort of customize for yourself. In that way, I call these CDK constructs are usually very nimble. Like concepts of validators, for example, or even aspects of CDK are super helpful in order to assert some baseline security requirements through CDK out of the box. And one sort of feedback has been like, we've been working very closely with the CDK team on multiple things in order to help work as a community in order to refactor some constructs that do not conform to our guardrail standards. So for example, like one of the active piece of work that I have been involved in, some of the discussions with the CDK team has been around S3 deploy construct, for example. It makes some liberal assumptions about connectivity to the internet. So we are working with the team to see how we can sort of close some gaps there. But my point is we are constantly raising the floor and raising the bar on security and working very closely with the CDK team at AWS and the broader CDK community. So with that, this is us. If you have more questions for Harsha or for myself, happy to connect offline as well. That'll be me.
Awesome, Harsha, Shubham, that was a great talk. I love that. I love the challenges there and just the approaches to solving them, both with the validators and with those acceleration type constructs as well. So thanks for sharing that knowledge with us today.
Thank you. Thanks for the opportunity, everyone. Thank you. Bye.
All right, I'm going to bring in our next speaker here. This is Matthew. Matthew's going to talk to us about CDK and Ansible, which I'm just super fascinated by. But first, I want to say you work on the S3 team at AWS. Is that correct?
Yep.
Awesome. Well, thank you for your work there. I love S3. Makes a lot of things easier. So, and I'm sure a lot of people in the crowd here think the same. Really excited to see your talk today. We were kind of previewing it earlier when someone was talking about custom synthesizers and seeing if that's sort of how this is working. So yeah, excited to see this talk. And with that, I'll just put your slides up here and let you get cooking.
Cool. All right.
Hold it. Matthew, you're a little bit quiet. I don't know if you can turn up the sound on that.
How about that?
There you go. That's better.
Okay. Sorry.
Yep.
I'll keep this in front of my face.
Cool. Sounds great. Thanks, Matthew.
Yeah. All right. So as I was introduced, I'm Matthew Rawlings. I'm a software engineer at AWS working on S3. And today I have something that isn't related to that. It's a personal project I've been working on, and I call it CDK-ANS or CDK-ANS, which I'm going to refer to them interchangeably probably as we go throughout this. And CDK-ANS is a way to define Ansible with CDK. So I think to start off, a good thing to cover is what is Ansible? Just in case people in the audience aren't familiar, Ansible is a systems automation tool that allows you to define essentially a series of tasks that you want to have occur on a machine or a group of machines. And this is good to help automate the configuration of your machine. So if when you make a new VM or some new EC2 and you want to make sure there's users there and applications there and all sorts of things, rather than having to do that by hand, you can write an Ansible playbook and it will run and do all the stuff for you. And so Ansible playbooks, they're a collection of YAML files. And so you have these directories where you'll define the tasks you want, the different hosts you want, and collectively these will make up your playbook where when you run this, they all come together and do your automation. So on this image I have on the screen here, this is just an example Ansible playbook. This is just pulled from something I have that makes a Kubernetes cluster. So we can see it will prep the machines, build the control planes, and then build the worker nodes. So yeah, now that we know what Ansible is, what is CDK-ANS? So if Ansible is similar to CloudFormation, CDK-ANS is essentially the AWS CDK, where we move from writing YAML files into a CDK-like approach where we can define our Ansible playbooks with a real programming language. And so this CDK-ANS is essentially following like the CDK style way of doing things where you have your application, and stemming from that application is a bunch of different constructs that you can tie in to help define everything you want to make. And so if you see this image here, this looks pretty familiar to how some CDK application would work. We have our application and we start defining resources, and they all stem from each other. So yeah, now that we know that, I think another good question is why? Why do this? And I have a couple reasons. I don't know if they're good, but I'm going to go through what kind of mindset I had when I wanted to initially take on building something like this. And first is patterns are hard. And especially in Ansible, which is a pretty old tool. It's been around for a little over 10 years now. A lot of things have changed over time. And Ansible is pretty flexible, which is good and bad for this. Over the years, Ansible has kind of changed the syntax of how you define things and changed some of the best practices. And they've been good about keeping a lot of good backwards compatibility. So if you wrote some old playbook, it's more than likely going to keep working as new versions come out. But if you're like me and you come into it like 9 years after it's been around, it can be kind of hard to figure out how should I do this. So to kind of illustrate, on the screen here, I have two ways you can define your inventory, which are like the machines that you're going to run your playbook on. And these are both totally valid. One's a YAML blob where you have a bunch of nested keys where I'm defining the hosts and the different variables they'll have that describe them. And the other is like an INI file that you'll also still see pretty commonly, where you have your brackets with the groups and the IP addresses that of how you connect to those. And these are both valid. And when it comes to learning something like this, I always stress on like, what is the right way to do it? And how should I lay this out? And there's a lot of things like this in Ansible where there's different ways you can lay out your playbooks and there's different ways you can define things. And a lot of this gets in the way of what I'm really trying to do, which is I just want to write some automation to take care of this thing I don't want to do anymore. And CDK-ANS can help kind of remedy that situation, because now you don't need to worry about how to lay out your directories. You can just write your resources. So the second reason is IntelliSense and typing are awesome. So I love modern development. We have a lot of things that make things way easier now. Like your IDE can tell you so many things. And you don't really get that when you're writing YAML, because you're kind of writing these just, there's a schema, but it's not getting enforced in your editor. So when you're writing something new, typically what your development process is going to look like is I have my YAML up on one screen, and then on another, I have the documentation of like, what are these fields and how do I actually write this thing? And with CDK-ANS, we bring in a lot of the modern strengths that you get from a programming language, like IntelliSense. So in this top image here, when I'm defining this enum, there's only so many values. In this case, there's 6. And rather than having to look at the documentation of like, how do I spell this? What can I use? I can let my editor help guide the way. And then it even extends further if you're doing something like TypeScript, where you have all these type definitions made. If I'm making some new construct, rather than having to have the documentation open on one screen, I can just pull up the type file and see what makes up this thing. What do I need to set? What do these different fields do? And that's what this bottom image is. I have the host props. These are the different things I can set when I'm defining a host. And I don't need to leave my editor to actually see what these are. And I can see what's required and what's optional. Yeah, and so IntelliSense is great. Really wanted to bring that over, but that's not the main reason. Really, the main reason is I hate YAML. YAML is great in small doses for configuring small things, but in Ansible, everything's YAML. And it leaves a lot of room for things I want to do, where I can't approach defining these in a programmy way. I need to approach them in the I'm documenting every single thing I want to do kind of way. And in Ansible, it's actually a little worse because it's not just a bunch of YAML files. You have a bunch of main.yaml files. So this is just a screenshot from some random repo I have where I expanded a bunch of directories all next to each other, and every single file in there is a main.yaml. When you're defining this, you'll have your editor full of all these main.yamls, and you'll have to flip through all of them to figure out where you are, and it's just a pain. So that's really why I wanted to do this, because I wanted to close that gap for when I define all my resources, I can use CDK for everything and not have to fall back to this YAML pattern when writing my playbooks. So yeah, that's CDK-ANS, and I figured what better way than to show it off than doing a demo. So I'm gonna flip over to my little example project I made to showcase this. A lot of the things are filled out because I wanted to make sure I didn't go over my time. But this is an example CDK-ANS application, and I'm gonna go through all the different fields in here and show off the different things that we can do. So the way this is written is it's trying to be as close to a CDK as you can get. So at the top level, if you're familiar with CDK, we always have our app, and the app is going to be the different things that we is going to be the container for all the different resources that we want to make. And so this next line.
Hey, real quick, I don't mean to interrupt, but if you could you zoom in a little bit there on the code? This is a little bit hard to read on the sun.
Sorry. How about that?
A little bit bigger would be great.
Bigger. Hell yeah. Let me.
Yep, that should work. Thank you.
Cool. All right. Sorry about that. Where was I? Yeah. So like a normal CDK project, you have this app, and the app is going to be the container of which everything stems from. This next level, we have a project, which if you're looking from an AWS CDK lens, is kind of like a stack where it's going to be that partition or a group of resources that you want everything to stem from. And then in Ansible world, this is essentially equivalent to like a Ansible playbook repository where you're going to define all of your inventories and roles and your playbooks. And so then from here, once we have our project made, we can start defining like the 3 major Ansible resources, which are inventories, roles, and playbooks. So we're going to go through what makes up like each of these components. So we can see right here, we have this local host I'm making. It's making a new host. It's stemming from this project, naming it localhost. Its connection type is local. And I'm setting this variable for it where I'm setting the user as Allsring. And then I can take this host, plug it into the inventory, and we're good. The next kind of resource we can make is a role. And so a role is, in Ansible world, is a collection of tasks that should happen in a specific order. And you can bundle these in a role and reference that role when you want these predefined set of tasks to happen all over the place. So you can build these roles to help consolidate your code and have these like similar groups of tasks run all the time. And so for here, I'm just making a pretty simple task structure where I'm greeting the audience, hello CDK day. And then because I couldn't think of anything better, I just say hello again. And the way you tie these tasks together and define the order is I took some inspiration from the step functions library and the AWS CDK, where in step functions, everything is a chain of tasks. And you can define in CDK these chain of tasks as this, I think they call it a definition body now, where each task has the ability to indicate what should happen next. And so here, when we plug in the tasks, we can do first task, and then next, run task 2. And we throw it into the role, and we make the role, and then we're good. And then the last resource we define is the playbook. And the playbook is where all the good stuff happens. It's where we tie the inventory and the role together. And so playbooks are a little similar to roles, where a playbook is going to define a series of plays. And so we follow the same kind of pattern here, where you can have your plays chained together with the .next method as you would a role task definition. But for simplicity, for this demo, we're just doing a single playbook. We can see here, we define the play, we give it a name, we specify, hey, run on the local host I defined, and then for the roles, target that role that I made above. And then we plug that play into the play definition, and we're good. And that's all it took to write our Ansible playbook, 53 lines of TypeScript about. And then at the bottom here, we have the app.synth, which is another CDK concept where this is just telling the system, hey, when I run, synthesize me. And so what the synthesization here is going to do is it's going to produce all of the different YAML files that we needed for defining this playbook. So if we run our build command here, which I made as npm run synth, we can run that. And now we have this handy dist directory, which if we pop open here, we can see everything we wanted was made. So we have our inventories. We just have that example inventory. Or if we pop in here, we have our host file. And we have our local host. We can see we have the name, the connection type, and that user variable I set. So that's cool. And we can pop into roles. It built our role in the role directory structure that you need to follow in Ansible, where we have the role name, we specify the tasks, and we have our first main.yaml file, where if we look in here, we have our first 2 tasks where we greet and then greet again. And then if we look at our playbook, we have them all tied together. We have our hosts with our local host, and then our roles where we're targeting that echoer role. And this is a totally valid Ansible playbook that we can just run with our Ansible tool. So actually have that ready too. So we'll pull up this handy predefined command I have where we're going to run this playbook targeting that inventory. And let me expand this because that happens really quick. We can see it ran. So we started up, we targeted the local host, and then we printed out to the display, hello CDK day and hello again. So yeah, that's the example of like how you would define an Ansible playbook and how you can use that to actually just build a playbook and start running with it. But there's a couple other things that I've made that help ease this a bit. And we're actually going to hop back to our main.ts file. Because if you've noticed, or if you're familiar with Ansible, you might have noticed that like this doesn't seem super helpful. This action here is targeting what's called an Ansible module. And the Ansible module is the thing in your task definition where you're configuring what should actually happen here. And this isn't super convenient because this task action, we have to specify, hey, run debug, And then you need to know what debug is. And that leads us back to, I need to go to the documentation site to look at like, how does this actually work? So there's a companion CLI to CDK-ANS that allows you to do a bunch of code generation, which is heavily inspired by how CDK-8s solve this problem, where in Kubernetes, you have all these different resources you can extend your cluster with, and they aren't necessarily going to be modeled in CDK-8s. So to bridge that gap, you can extract that information and turn it into a bunch of code. So if we look here, I pre-ran this too, because this can take a bit. I have this imports directory, which is a result of running our CDK-ANS CLI, which in this config file, we specify what should have been targeted. So this config file, we say, hey, make TypeScript. Also, this is the app command. And then under imports, we have what we want to import. And so each item under the import is specifying what is the thing I'm importing, what is it called, and where do I get it? So here we have a module, which is like the Ansible action code. I'm targeting the Ansible built-in one, and then I can get it from this GitHub Ansible repo. And I'm not going to run the CLI because it can take a bit to pull this down because it extracts the whole repo and builds all these files. So for the sake of time, I pre-generated this, and in everything it makes, it will dump into this imports directory. In this imports directory, we have all sorts of fun things we wanted. So if we look at the debug that was generated, we can see everything that makes up a debug action we have specified here. We have all the props with all the different messages and all the different documentation on like what are the different variables I can set. So we have an optional message, variable, verbosity, cool. Above the actual action, we have all sorts of documentation on who wrote it, how do we use it, and all this helps us continue to leverage our IDE as our biggest tool. So if we go back to this main file, we can just use this. So we can replace this task action with a debug action, drop this name, and it's happy again. And now we have our strongly typed debug action where we have full IntelliSense, and we can see everything that makes up this module and the people that made it, when it was added, what collection. And yeah, this is great. So we'll just refactor this real quick to another debug action, and we'll drop that. And yeah, and so now with this strongly typed action, we can just regenerate the same project, which is gonna just produce the same thing. But we can see here, nothing changed, but the namespace that it's specifying, because now we're following the real best practice where we have our Ansible built-in debug, and it's going to actually, do the same things that we did. So if we want to run this again, we can do the Ansible playbook, run it. Sorry about that. And it ran all the same. Yeah, so that's CDK-ANS. I guess I should wrap up now. So let's hop over to where is it at today? I'm calling this project current state as alpha, which means it works for a lot of things, but there's probably bugs, and I probably still need to find them. So don't use this for anything too crazy quite yet. All the packages I put onto NPM last night, so you can pull these down. TypeScript is the only language that you can compile to at the time, with more support coming soon. And I have some getting started documentation ready, but the in-depth docs I'm still writing up, so those will be coming soon as well. And so yeah, you can find more information at the GitHub repository, which is on the screen. And there's also the CDK-ANS website, cdkans.io, that you can pull up and look at more if you want. So cool. Thanks, everyone. I hope this was interesting.
Matthew, that was great. Thanks for sharing that. Yeah, I really loved it. Ansible was actually the first infrastructure as code tool that I ever used. So it's cool to see that playing. And I think your distaste for YAML is not unique.
Yeah.
Sure. So thanks for sharing that, and thanks for doing a demo. Definitely got some props in the chat for doing a live demo. I'm gonna pull up our next speaker now, which is Danielle. Danielle, how are you?
Doing well. How are you, Alex?
I'm doing well. I'm excited to see this talk because I've seen you give talk before. You do a lot of great stuff. I think probably from your background as being a teacher and being able to explain stuff really well. So Danielle, serverless hero, been in the sort of serverless space for a while, does talks on CDK. Matthew was saying this is the second year in a row talking at CDK Day. And I'm excited about this because it's using step functions, which is just like one of those awesome services that I really love. So without further ado, I'll kick it over to you and teach us about step functions here.
Awesome. Thanks, Alex. Yeah, great to be back. This is serverless weather reporting with AWS CDK and step functions. Alex already did a brief demo of me, but if you want to keep in touch, I try to get the handle at dheber on social media, and danielleheberling.xyz is my personal website. So let's get into it. So another autobiographical fact about me is that I moved to Portland, Oregon around 10 years ago, about to celebrate my 10-year anniversary. So pretty excited about that. And as an adult, I've lived in lots of different places throughout the United States, mostly because it was before remote work was a little more accepted. But now that remote work is accepted, I've stayed in the area, and I guess you could say by default, living here has been my favorite place to live. But nowhere that you live will be perfect. There will always be, some problems. Some will be big or little. So today I was going to talk a little bit about one of my issues with living in the Portland metro area. And that issue is snow. And I know what you're thinking. A lot of places it snows and people have figured out how to deal with it. What's the big deal, Danielle? Well, let me tell you, Portland, Oregon is a little special in that regard because the local government doesn't plow a lot of the roads. They also don't salt or treat a lot of the same roads. And this kind of mindset is common throughout the whole area. So it goes beyond Portland, Oregon proper. Even close suburbs kind of have this type of mindset. And being someone who grew up in the Northeast where it snows a lot, I was really curious about this and wanted to learn why. So I asked quite a few long-term residents as to why this was the case. And almost always the answer that I got was, it doesn't happen here too often. So it's not really worth the expense or, hiring all those folks to clear the roads. And I do think that historically that might have been true. But from my experience of living here nearly 10 years, I've seen the city of Portland shut down for a day or two, sometimes 3 days, just because of the lack of maintenance of snow on the roads. And sometimes it happens a few times every winter, which is fun. And I'm not the only person that's moved here from somewhere more snowy. A lot of times this can kind of turn into folks with an inflated sense of confidence of driving in the snow here. But I do think it's unique because, where I originally was born, Pittsburgh, they had that baseline of plowing the roads. So yes, the snow there is way worse. But with that baseline, it makes a really big difference for public safety from what I've seen. And then I discovered this lovely website. I'm not affiliated with the folks that created this website, so I don't take credit for it. But is it snowing in pdx.com? And if you look at it today, this is what it looks like. And unfortunately, I was unable to get a snap of what it looks like if it is snowing. But if you can picture, the background is red in color. It says, yes, I believe in white lettering. And there is a Kermit the Frog GIF of him kind of flailing, freaking out. And it says, induce panic. So I love this website, both for the entertainment and just also for the information. It's a little less dry than going to your, typical weather website. And I really like that, stuff like this is really a testament of folks in this area. We do what I consider ridiculous things sometimes, but we are good at kind of poking fun at ourselves. So I really love that. But then I ran into a problem because I moved to Hillsboro, Oregon, which is a suburb of Portland. And if you remember what I said before, Hillsboro has similar thoughts about clearing all the roads. So is it snowing at pdx.com didn't work out so great for me. So I bought a domain and I built a website. And this is what it looks like when it is snowing a few times a year. So this is CDK Day. I know you're not here to listen to me complain about my local government or the weather. So I thought we could go into some more details about how I built this site. And if you're interested, how you can build a similar site. So first off, I built this website 100% with the AWS CDK for TypeScript. It was really fun to build. So let's take a look at the high-level architecture. Tried to keep it pretty simple. So on the far right, you'll see an S3 bucket. I literally just have a single HTML file and CSS file, kept it super simple. So that works for the website. But then what happens when the weather changes and we need to update it? I thought through a few things and I wanted it to be as automated as possible. And here's what I came up with. So on the far left, we have Amazon Event Bridge Scheduler. And that is one of AWS's ways of running a scheduled job. So periodically, this scheduler will invoke this step function. And we're going to zoom in on the step function on the next slide here. But long story short, essentially what it does is it reaches out to a third-party weather API, gets the current weather for Hillsboro, and then determines if the website needs to be updated. If it does that update for me. And because I wanted to save resources and money, I've got actually two schedulers. The one scheduler for winter months runs every 10 minutes. And then the scheduler for non-winter months runs every hour, because somewhat unlikely it'll snow, but I want to be prepared. So let's zoom in on the step function. So if you start at the top where it says start, our very first step here is get site status. And what I did was I put a parameter in the parameter store, literally plain text, just says snow or no snow, nothing too fancy. So that first step is to get that value and return it. And then the second step, check current weather. This is a Lambda invoke state. And in hindsight, it probably could be run in parallel with the first step, but for now it's one after the other. Anyway, check current weather calls out to the third-party weather API, open weather map to be specific, gets the weather for Hillsboro and returns it. And then my third state here is the site up to date? So this is what's called a choice state. And it compares the value from get site status and the value from check current weather to see if they're the same. If they are the same, we know the website's up to date. So we do an early exit. We go to the right here to the site is up to date state. It's just a past state, and then the step function ends. If they are different, we know we need to update the website. So we go to, I think the left, maybe it's your right. I'm not sure. Anyway, we go to update site, and that's a Lambda invoke state. And what that does is it dynamically generates a new HTML file for us, either snow or no snow, depending on what the current value is. And it puts that new HTML file into the S3 bucket overriding the current one. And then finally, if that's successful, we go to update site status, which is another AWS SDK direct state call. It's literally just updating the parameter, the same parameter from step one. So when we rerun the step function in 10 minutes or in an hour, that the value for step one is correct. So when I first built this, I was kind of newish to step functions. I had used them before, but not super extensively. So I found myself continually checking CloudWatch to make sure that it was running on the schedule. I didn't fully trust EventBridge Scheduler at the time just because it was new to me. So I decided to automate this a little bit. So what I did was I set up a second CDK stack. This is completely optional. You don't need to deploy this if you don't want to. But I've got a CloudWatch alarm set up to watch if the step function fails. I believe I have it set for if it failed twice within the last hour. An alarm goes off, and that sends a message to an SNS topic. And then I've got my personal email address subscribed to that topic. So could also be a text message. I just chose email because it felt a little less invasive. And here's a little quick code snippet of what that alarm looks like. Yeah, that's one thing that I really love about CDK is if you can read English pretty well and have a base understanding of AWS. To me, it's pretty intuitive what this is doing and pretty easy to update, which I love. So I did run into a few challenges. There was one that I wanted to briefly cover. So the first challenge that I ran into was getting Amazon EventBridge Scheduler set up. AWS CDK has the concept of L1, L2, L3 constructs. And the L1 construct is perfectly mapped one-to-one with CloudFormation. So if it's an L1 construct, you're essentially writing CloudFormation in the programming language of your choice. And me personally, I choose CDK because I like the abstractions that L2 and L3 give me. So I did kind of miss that. Currently, I believe it is still only an L1 construct. It was definitely doable, but at the same time, could have been a little bit better of an experience. I really did miss the IAM policy automatic generation that a lot of L2 constructs do for me. So I just wanted to say thanks to some folks here. Disclaimer that I'm not sponsored or affiliated with any of these things I'm going to mention. But if you are someone like me and you build on managed services a lot of my work is reliant on the work of others. So wanted to acknowledge that. So first off, thanks to the folks who created Is It Snowing in PDX.com. Thanks for the idea, for the inspiration. The Open Weather Map API, personally, my biased opinion is if you are building anything that requires weather, I would highly recommend checking this out. Their documentation is fantastic. And they also have a very developer-friendly free tier that I loved. And then finally, I wanted to thank the creators and contributors of the CDK. And that is both, the internal to AWS folks and the folks who are just in the community. Thanks for making CDK better for all of us. So yeah, former teacher and me, you got some homework if you would like to accept it. All the code that I was chatting about is available on, correction, Scheduler has an alpha package now. So yay, thanks for the correction there. Awesome. But anyway, yeah, you can go to the GitHub to check out my code if you want to look at it. It's open source, so if you want to contribute to it via an issue or a PR, feel free. I love working with folks. And you can also use it if you want. So if you look at the root README, I tried my best to write detailed instructions on how you can use it yourself. But for the most part, what I did was I made it very configurable with environment variables. So you can plug in the coordinates of where you'd like to track weather. And you can also plug in the type of weather you'd like to track. So it's not just limited to snow. This is what, with the way that I'm using Open Weather Map, this is what's currently available. So if you want to do like, is it raining in Philadelphia? You can definitely do that. But yeah, if you do end up building a site, definitely feel free to share it with me. Would love to see what you all do. And it's been a pleasure being back for a second year. So thank you for listening, and hope you have a good rest of your day.
Danielle, great talk. I love a good like single serving website, right? That does one thing and does it well. When do you start seeing snow in Hillsborough? Like, will you get one in 2023, or is it more like January, February before it starts snowing?
Typically, it's more January, I've noticed. Yeah. So later on.
Yeah. When you're like really stuck in like the really cold parts of the year and just ready for it to be over. So cool. Yeah, that was a great talk. I love it. I love step functions and EventBridge Scheduler as well. So thanks again for sharing your knowledge, and hopefully you'll be back next year for CDK Day again.
Yeah, totally. Thanks, y'all.
Yep. All right. I'm going to bring Matt and Michael back. How's it going? Michael, how'd the talk go?
Oh man, it's crazy. I feel like my mind has been just all over the place today. Starting in English, switching to Spanish, going back here to English. But the talk itself was great. My first Spanish talk, a lot of support from folks in the audience. Marcia's great over there, as you guys know. I'm looking forward to keeping it going. That can't be the first and only. Now we got to keep going.
Yeah, that's awesome. Yeah, and switching back not only between English and Spanish, but between like hosting and presenting duties. Yeah. Right? Those are just different modes as well. So definitely winning most flexible contributor today to CDK Day.
Yeah, he's doing it all today.
Yeah.
I'm happy to help. Thanks for inviting me.
Yeah. I want to shout out. Go ahead.
So I just wanted to know, over your right shoulder, are those Lego models of the helmets?
Yeah.
Over your right shoulder. Yeah. Are those Legos? Oh, gosh. That is so funny. I thought those things were another 10 feet back.
I don't know how to... There it is. That's this crazy lens that I have.
Yeah, I thought for sure that was at least like 5-6 feet behind you, and I thought those were like big old
huge
models, but I guess not. Yeah, weird. So funny.
Matthew, what's been your favorite talk today, or any couple talks or anything like that?
Oh, I'm going to steal a lot of content from the synthesizer talk for sure.
Yeah.
I think also, I wanted to ask you, you said, did I hear you say that you were an Ansible guy at one point?
I was, yeah. Yep.
Okay. So I remember reading about Ansible because it was part of the DevOps Pro certification.
Okay.
Do you see yourself, if you were an Ansible guy, picking up and using that CDK for Ansible?
Potentially, yeah. I mean, it's been a while since I've used any Ansible. I mean, this was honestly when I was just getting started with programming, and it was probably like 2013, 2014. I haven't done much with it since, probably at least 14 or 15. But I definitely loved it at that point. I was actually using it to provision like Raspberry Pis, and then also some AWS servers and just lots of different flexible things. It taught me a lot about just like server management and a lot of things I did not know about computers. So
yeah.
That was pretty sweet.
I love this continued evolution. We just see more and more of more construct based APIs. These, we saw it obviously the AWS CDK first, and then we had CDK, and the CDK for Terraform, then Progen, and now CDK Ansible, and it keeps going and going and going. And I want to know. I've heard people talk about perhaps a CDK for Docker files and all these other things, and I'm just really curious to see like what the potentially what the other uses are for it. Just a quick programming note. As some of you might have noticed, our interpreter was having a little bit of problems with the focus on her camera. and it was making it so everything was very, very blurry. So, oh, that seems much better now.
Yay!
Welcome back, Danielle. Yay! Okay. So, Michael, what about you? Have there been any talks that you've seen so far that you really liked?
I caught the not to show my front end hat. I caught the tailwind of Danielle's talk. Practical use cases of Event Bridge Schedule. I love that service, honestly.
It's so good.
And now that they added the ability to have it auto delete the schedules, it's great. So anytime I see step functions, scheduler, showing my bias here with AppSync, all of that stuff where you can just orchestrate things and not have to write as much code, like that's my wheelhouse. So I'm going to be taking lessons from her talk.
Yeah. Alex, you're a big step functions fan, aren't you?
Step functions, love it, and Event Bridge Scheduler too. I feel like when that was announced, that was like one of the very few remaining gaps where I was like, man, if I could just have dynamic schedules at any time, super flexible like that, so huge. Now we just need true serverless search, and all will be right in the world, right? We don't need anything else.
I'm curious to see what the landscape looks like post reInvent, and then also like 6 months from now with all this AI stuff.
Yeah.
With Bedrock, like what is the landscape even going to be?
Yeah.
It's kind of nuts.
Have you been playing with Bedrock much, Michael?
No, I actually, so funny thing, I just tweeted it the other day. It's like a lot of us internally, we thought that Bedrock wasn't going to be GA until reInvent.
Yeah.
So we were under strict like hush hush on what we could actually even talk about. And then all of a sudden it was like the team was just boom.
Yeah.
Here it is. So I haven't
see it today. Am I seeing it today that Bedrock went GA today or yesterday or something?
Yeah, either yesterday or the day before. Yeah,
yesterday.
Okay. Yeah, it's finally out there. So
can't keep up with all this stuff.
I know,
it's crazy.
Right?
As soon as you think you got a grasp, here comes pre-invent.
Yeah.
Oh gosh, yeah, we're definitely a pre-invent stage.
Yeah, we got the DynamoDB incremental export. That was a huge one.
That was cool
for me. I like that. So, some good stuff already starting to come out.
What about you, Matt? You have everything off of your candy list of things that you want from AWS or DC Gas? A lot of people talk about serverless search.
Sure. So the things that I really want to see, and of course, none of this is anything that I know coming down the pipeline. But if it was my wish
we do have to preface that is like we have no insider stuff.
Yeah. No, we don't have any insider information. I would love to see the continued efforts put into step functions. I think step functions is a fantastic service. I think that there are a lot of really great things that it can do. I think the development experience still needs a little bit more love. There's a little bit too much effort that has to go into actually creating a workflow. When it comes to the runtime side of it, I think step functions can't be beat really in terms of its cost, its effectiveness, its observability, its replayability. I love it. But the development experience is still a little bit rough. So I can't wait to see what they do with that over the course of the next 6 months, hopefully, and improving on that would be really great. I've been saying for years, I wish DMS was getting some love. I think DMS is a system that I would probably use in some form or fashion with every single client that I've got. But unfortunately, it's a product that has a very narrow use case from what I've seen, because it's always the same situation, right? You go out there and you spin it up and you move one database to another database and you're like, this is fantastic. And then you touch one thing and it blows up. And I've never been able to get it to work correctly. So those are the frustrations I have, because that is a incredibly useful process to move data real time from one system to another. So those things, continued work on Lambda, I think is always appreciated when it is the Swiss Army knife of the AWS world. I was really excited with the Event Bridge Pipes announcement. I thought that was really cool, and just continued work to make different services within AWS function together without me having to write a Lambda. Like as much as I like Lambda and I love working with them, the fewer of them I have to write, the better off I think we'll be. And then of course Amplify. I think Amplify is a service that everyone should be keeping an eye on and using in one form or another. So there's a lot of good stuff going on.
Yeah, I'd love to see API Gateway pick up some of the like JavaScript resolver type syntax in API gateway rather than just the VTL. Like
Dash to VTL.
Been way above. Or the AppSync team's been way ahead on that stuff.
I've been talking to for folks that don't know, serverless here, Alan Helton, and he's a big API gateway step function champion. And it's funny because we go rounds talking about API gateway versus AppSync. And again, I'm totally biased here, but he goes, well, I go, well, you can do this, this, and this. He goes, you can do that in API gateway. And I'm like, but I mean, JavaScript. I think VTL is like, regardless of the service, VTL's got to go.
Yeah. The JavaScript resolvers from AppSync, that's a pretty amazing experience. Yeah, it makes that a lot easier, and yeah, it's pretty good stuff.
And I've never heard anyone enjoy working with VTL.
No. It was weird.
Maybe Richard Boyd, but
he would. He
doesn't count. Yeah.
Oh man. People are like, what's VTL? I'm like, it's this thing that was written by Apache, and they're like, I'm done. Like, it's the SpongeBob meme. It's like, I'm gonna head out.
Yeah. Tell me more about DMS, Matt. Are those folks that are migrating from like on-prem to AWS? Are they migrating from like MySQL to Postgres for some reason? Like what are you seeing that use case for?
So I work for an MSP. Our job is to often take on existing AWS accounts, and far too often we come across cases where someone has created a database on the public side, publicly available, and we have got to get that locked off. You can't just make a public database private. And while there are certainly some things you can do to protect it, you're going to have security alarms going off all over the place if you don't truly make it private. So that's a number one use case. Oh, we created a database and we forgot to encrypt it. Oh, we created a database and we didn't encrypt it with our own managed key, so now we can't move backups to another account. All these little things where in an initial configuration problem, it really hampers you down the line. DMS could be a great way to fix that.
Yeah, interesting. Huh. That makes a lot of sense. That's pretty slick. Yeah, I wish that would be nicer.
Cool. Well, we are right at time. Thank you, gentlemen, for everything today. I believe this is the last time we're going to see Alex and Michael. I can't say thank you enough for coming on and helping host. This has been fantastic. Definitely been a huge help. We love seeing you guys as always. Can't wait to see you guys again, hopefully at reInvent.
Thank you for having us. It's been great.
Yeah, thank you. This has been a lot of fun. Great turnout. So thanks, everybody.
Thanks you to the. All right.
Oh. Well, that was a little premature. Hit the wrong button. Sorry, Michael. All right. So we're going to move right along. So our next talk is by a gentleman named Ari Palo, and I will just put him on and let him do all the work.
Hello. I'm going to talk about managing configurations with AWS CDK. First, brief introduction. My name is Ari Palo. I'm a lead technologist at Alma Media, where I've been working a bit over 12 years now. My favorite programming languages are TypeScript and Go, which is great because CDK supports both of them. I've been dabbling with AWS for almost 10 years now. Additionally, I'm an AWS recognized community builder focusing on developer tooling. You can also see my contact information in the slides, so feel free to connect with me in LinkedIn or in CDK Dev Slack, especially if you have any questions at all. To give you some context for this presentation, a couple words about the company I work with, Alma Media. We develop over 100 different websites and applications for our various brands, operating in 11 countries across Nordics, Baltics, and Eastern Central Europe. We are a market leader in many of the segments we operate in, such as job portals and marketplaces and news media. Alma's journey started in 1847 with the newspaper business, and in the mid-90s we started our online services. More interestingly, our journey with AWS Cloud started in 2012, so a bit over 10 years ago. In 2016, we started prioritizing serverless technologies such as AWS Lambda, API Gateway, DynamoDB, etc. We are actually early adopters of CDK, going to production in late 2018 with CDK version 0.21. Now we have a bit over 200 accounts in our AWS organization, and the number will grow as we migrate other parts of the business to AWS. to the actual topic, I'm going to start with how you handle known configuration values, then briefly summarize the props model in CDK, jumping into handling configuration values that are resolved from the cloud environment, and then a couple words how we handle CDK configuration in Alma, and finally I'm going to leave you with some considerations and takeaways. First, known values, or static configuration that is known ahead of time. I'm going to showcase few ways I've seen people do it and talk about the pros and cons. First, values from the environment that you could export in your shell and then access the environment using process.env, for example, in TypeScript, although all these examples apply to any of the programming languages supported by CDK. Or you could use the .env files to define your parameters there, which you then parse using something like .env library in your code and access them as you would normal environment variables too. Generally, I'd recommend avoiding these, but you could use these if you have developer-specific configuration, such as each developer has their own AWS account. Then you could use the .env files to handle that. In that case, of course, remember to ignore those developer-specific .env files from Git. Next up, any data formats like JSON, YAML, TOML, and such. I see people using these quite a lot. Again, I would generally recommend avoiding these, except in the cases if you need to load data from external data sources, then it makes sense to fetch the data and store it into JSON and finally read that JSON data in your CDK application. Next up, I'm going to talk about context. Context is available in the construct tree where it propagates down. So if you set context key foo in the root node, then it's available for every child node as well. Also, if you set the context key bar in some child node, then that is available to that node you set the value in. So how you actually access that context? There are two ways. First one is get context, a method that is available through the node property of any construct. If the context key is not available, this method will throw an error, so quite useful to ensure that you will actually receive some value. But note that reading context values doesn't provide any type information, so you need to handle the type system yourself. The second way is using try-get context, which is similar. I usually prefer using this try-get context method, which doesn't throw but can return an undefined value if no matching context key is found. But as I often anyway have to validate the context key value, this is okay. So in the example you can see I'm using try-get context to get the value, and then I'm doing some assertion on the value to ensure it is actually there and in a specific type that I want it to be. Next, how can you actually set the context? So you can use try-get context and get context to read the context, but now we are talking about setting the context. First one is through using the CDK app and its properties. You can set the context prop as an object and key value pairs into it. And this is often not that useful, but it's good to know for testing purposes. The second way of setting the context is using cdk.context.json file, but you shouldn't use this. This is generated by CDK and it's used as a local cache for lookup values. Then there's the context object in cdk.json file within your CDK project folder. I would say this is more intended for configuring feature flags for CDK itself and maybe for some third-party constructs that you may be using. You can use it, but if you do, I would consider namespacing your context keys there as well. Additionally, you can define developer-specific configuration in the global CDK JSON file, which you can use and have in your own home directory. So this global CDK JSON file will be applied to every CDK project in your machine, but only use that for a developer-specific configuration. Then there's a programmatic way of setting the context keys. For CDK apps, this isn't that common in my opinion. Technically, you could use it to avoid the prop drilling and passing parameters deep down in the construct tree, but I don't really recommend that unless you really know what you're doing. Finally, there's a way of setting the context through CLI. You can set simple string parameters or anything that can be stringified to context using CDK CLI by passing in a -- context CLI parameter. In my opinion, you should only use this instead of environment variables, so basically for simple modifiers that need to be passed down through the CLI every time you run the CDK application. Then, my favorite or preferred configuration model, just using code. I would say use this instead of JSON, YAML, etc. data files, env files, or the context object. Benefit of using just code is it is just code, so you will get a strongly typed configuration. You can get complex types, for example from AWS CDK lib, like in the screenshot we have defined this architecture config type. Additionally, you get also JS documentation, so your configuration will be well documented as well. And finally, using just code means you don't need to have any additional parsing or validation for the configuration, as it's again just code. And configuration in code can be easily assigned into props. So let's talk about props really fast. Besides object-oriented programming, CDK relies on the construct programming model. There are a few basic patterns in that, and one of those is how you expose properties and methods on constructs, and then how you pass in data as props. Almost every construct in CDK follows this pattern. And this applies to stacks too, as they are constructs too that take in the stack props, which you can of course extend with your own interface and your own prop needs. Then there's stages, and props work there as well. Stages are useful as they can group together multiple stacks. And also note that with stages, the stacks within the stage will inherit the env or the account and region information from its parent stage implicitly, but you can of course do stack level overrides there. Then finally, you can define custom props for the apps or the CDK app by subclassing the CDK app class with a custom props interface. I don't think this is not necessarily that useful for most CDK apps, but for example in Alma we have used this pattern with our own CDK app subclass to enforce certain conventions using our own props interface. Then next, let's talk about how to resolve configuration from the cloud. So first of all, cross-stack references. To pass dynamic values between stacks in your CDK application, you use the constructs pattern of exposing values and receiving props. But stacks are a bit special, I will say. The exposed values will actually be CloudFormation stack exports, and the received props will be CloudFormation import values. So actually CDK is using the CloudFormation features to achieve the cross-stack dependencies or cross-stack references here, allowing you to pass data from stack to another. But it has to be within the same account and within the same region for it to work, for the cross-stack exports and imports to work. To pass data between stacks in different regions, you previously had to build your own solution using SSM parameter store and some custom resources. Luckily, nowadays you just need to enable this cross-region references property on a stack, and then CDK handles everything in the background. So in the example screenshot, you can see that we are passing a value from a stack in EU West 1 to a stack living in US East 1. Super straightforward. Next up is using SSM parameters. Often you will need to access configuration from resources that are outside of the scope of your CDK application and its stacks. For that you can use SSM parameter store parameters as an example. So in this screenshot we are creating a reference to an SSM parameter, then the received string value then we receive a string value that is actually a token that will be resolved during the deployment time by the CloudFormation service. Next are lookups. You can do lookups to existing resources also during synthesis time. So the SSM parameter reference was happening in deployment time, but lookups happen on synthesis time. So in this example, we're defining a reference to an existing VPC by its hard-coded VPC ID. But you may think that you may not want to hard-code these values always. So there's a way around to solve that as well. You can combine lookups and SSM parameters too. So in this example, we have externally stored VPC ID that is stored as an SSM parameter, and we want to reference that in the VPC lookup. But lookups like the VPC lookup require concrete values during the synthesis time, not tokens. Luckily, CDK supports that by using the value from lookup for the SSM parameter. This way, CDK resolves the parameter value during synthesis time and is then able to provide the resolved VPC ID for the VPC lookup, because that as well happens during synthesis time. I wanted to show this specific example solution here, as this is quite a common problem people face. So then to a real-world example, how we handle CDK configuration in Alma. For some context, in Alma we often set up 2 AWS accounts for each product or product family, and those are dev and prod. Each of these accounts have multiple environments in them and then some shared account level resources. To help with that, we have created Alma CDK project. It is actually based on our internal tooling from 2019, but this newer version is open sourced and somewhat improved. Basically, it subclasses cdk.app, allowing us to use the custom app props which enforce certain configuration conventions and also perform automatic tagging for all resources. Then those props are internally set to context, and by providing few custom constructs, few helper functions, we can make the complex configuration and also retrieving it within the application relatively simple. And this way we can also support the multi-account, multi-environment conventions described in the previous slide. The Alma CDK project is built for our own needs, but it's open source. So feel free to check it out, even just for inspiration. It's not the perfect tool, but it gets the job done for us. It's available in github.com/alma-cdk/project. Then few important considerations. Imagine you have an AWS account with some service defined by a single stack. You could have another service with multiple stacks referencing each other, even across different regions. You even could have multiple instances or environments of any service like we do in Alma, as we utilize the multi-account and multi-environment setups that may contain multiple services in them. These service stacks then may reference some account level resources with completely different lifecycle and ownership, or even external AWS accounts. So always consider these references between your cloud resources, and be especially mindful of cyclic references. Common example is defining a security groups with CDK, where it's quite easy to create these cyclic references almost accidentally. To solve the security group cyclic reference problem, my personal recommendation is to separately create security group based on the access requirements and never modify those security groups elsewhere. For example, create the database access security group separately, then reference it only as allowed inbound traffic source on your database stack. Finally, assign the reference database access security group in your application stack to any resources requiring database access. This way, you don't modify the database access security group all over the place, creating cyclic references. Additionally, I think the benefit is that it makes it really easy to understand which resources have access to your database only by checking which resources have the database access security group attached into them. Lastly, few takeaways. For global configuration known ahead of time within the same application, just use code like TypeScript to avoid those data files like JSON, YAML, TOML. And this gives you the flexibility and the full support of the type system. So I really strongly recommend using a configuration in code for CDK projects. You can use the env files or the global CDK JSON in your home directory for developer-specific configuration. Again, this applies if you have, let's say, a separate account for every individual developer. And remember, props are the de facto way of configuring in CDK, so use them. And then in addition to those, you may want to use sometimes a little bit of context keys if needed as modifiers or feature flags, especially if you find yourself in a situation you would want to use an environment variable, then instead you should consider passing down context key using the CDK CLI. Then between stacks within the same application, use the stack exports and props for the import to reference values between stacks, but again, be really mindful about cyclic references. For cross-region references, you can use the CDK provided cross-region references if you need to connect two stacks together that exist in different regions. For external configuration, I think naming convention with the use of SSM parameter store parameters is usually the way to go. Lookups help, but remember sometimes those tokens don't work and you need to resolve concrete values during synthesis time. So there can be a bit of challenges there, but it's doable usually. Additionally, for runtime applications, AWS app config or DNS or service discovery can help. And lastly, remember sometimes hard coding of values can be okay too. So that was a lot of stuff in short time, but hopefully it was useful. Again, feel free to connect with me using the links on the slide or go to almamedia.dev to learn more about Alma. Thank you.
All right. Now, I know that Ari is not actually here and listening, but I want to say thank you to him for presenting. That was a great talk. Configuration is one of those things that it seems like always comes up in conversations. And I just want to kind of personally add in that the context is probably something you want to avoid, and doing everything you can in code that's the way to go. So we've got one last talk here, and then we're going to go into a keynote talk from one of the CDK team members, so stick around for that. But now up we have Deepak, and I'm going to try this last name, Deepak Kavuri. I'm probably got that wrong, and I apologize to you now.
Hello everyone, welcome to CDK Day 2023. I'm here to talk a little bit about how you can leverage SAM CLI to build and test your serverless applications built using CDK. So a serverless application is often more than just a Lambda function. A serverless application can contain multiple Lambda functions, API gateways, databases, even sources that come together to perform a task. Often when you're getting started or just trying to test out things, it's easier to just use the AWS console to provision the resources that you need. But as you graduate your application to a production application, you need additional capabilities such as leveraging infrastructure as code to consistently redeploy your application into other environments. Or you also need features such as version control so that you're able to track the changes to your code as well as your application over time. And then finally, you'd also want a CI/CD process in place so that you're able to automate the release of your application as well as your infrastructure over time. So before we get to the crux of the topic today about SAM CLI and CDK, I want to quickly introduce myself. I am Deepak Kavuri. I'm a senior solutions architect here at AWS. I've been with AWS for about 6 years now, and I'm based out of the North Virginia region. I specialize in the containers and the builder experience domains, and I work with customers primarily in architecting solutions in these areas. I'm really excited to talk to everyone today, and I'm sure you might have a lot of questions following this talk. If so, please feel free to reach out to me either on email or connect with me on LinkedIn or on X. So what are some goals that I have for today's talk? So I want to make sure that everyone is able to walk away with a better understanding of how you can leverage SAM CLI to build and test your serverless applications that are deployed using CDK. That's goal number one. The second thing that I want everyone to walk away with is have a better understanding on how you can model your CI/CD pipelines and leverage SAM CLI within it. So let's take a look at what we're trying to build today, and we'll walk backwards from there. So the architecture that we're trying to build today is based on, it's a serverless workload, and it is called the historical weather web service, and it takes in user parameters such as zip code and a timestamp and provides the user that weather information for that area at a given timestamp. So let's see what are the components that are being used over here. I have an Amazon API gateway to the very left, and this interacts with a Lambda function. The Lambda function interacts with Amazon Location Services and a third-party web service known as the Open Weather API to provide the user the information that they need. And then finally, any data that's returned to the user is also transacted into a DynamoDB table. So let's take a look at how this works. A user puts in a request with query parameters such as zip code and timestamp, and the API interacts with the Lambda function, and the Lambda function works with Amazon Location Services and Open Weather API to get the information that we need. The data that's returned is transformed and then sent back to the user through the API gateway. Also, any information that's returned to the user is also written to a DynamoDB table. You can also see that we have Amazon Secrets Manager and Amazon CloudWatch Logs being used over here. Amazon Secrets Manager is being used to store secrets to access the Open Weather API. And then finally, we also use CloudWatch Logs to stream any logs that the application generates during runtime. So this looks like a pretty simple and straightforward application to build, and let's see how we can build some of these applications. So the legacy approach of building such an application or a workload would be to leverage infrastructure as code tools like CloudFormation. So with CloudFormation templating, you use primitive resource types such as AWS Lambda function to define your Lambda function or API handler, and then you have API gateway resources such as the REST API, stage, method, integration, and deployment. All of these resources that come together to create your API gateway resource. And then finally, you also have the DynamoDB table to create the DynamoDB table. And you can see that it's quickly becoming complex, and you have a lot of resources that you need to define to just create this architecture. And this template can easily span up to hundreds of lines, and it's often not developer friendly. Let's quickly take a look at how this template would look like. So as you can see here, the template is about 130 lines of code, and it has several resources being defined. It has Lambda functions, API gateway resources, DynamoDB tables, all that need to be defined for it to work together. And there's also a complex requirement to interlink resources when defining these templates. And let's see how we can make this simple. There definitely has to be a better way. And AWS provided customers with two different ways of doing this. And the first one is the serverless application model, or also known as the SAM framework, which is a declarative and opinionated framework for defining serverless applications. The second approach is using CDK, or the Cloud Development Kit. With Cloud Development Kit, you add a level of abstraction on how you define your resources. So you can define your resources using a programming language of your choice. Let's also take a look at some of the difference between CDK and SAM. One key thing to remember is, regardless of CDK or SAM being used, both of them have the same provisioning mechanism, and they use CloudFormation to provision resources. And when you're trying to declare resources with either using SAM or CDK, CDK uses a programming language of your choice. Some of the supported programming languages by CDK are TypeScript, JavaScript. You can use Python, Java. I think you can also use Go. So there are these are some of the programming languages that you can leverage. And with SAM, you use JSON or YAML templating similar to how CloudFormation works. But talking about resources that are supported, with CDK and SAM, since they use CloudFormation as the provisioning mechanism, basically all resources that CloudFormation supports are supported using these frameworks. However, with SAM, you have a focus on serverless workloads. Let's talk about references next. So when you define infrastructure templates, there's often a requirement to cross-link resources. For example, as you've seen, we have an API gateway that links with a Lambda function. So you probably want to establish a cross-link between these resources. And the way you do this when using CDK is you use native programming language capabilities to link resources, and we'll take a look at how that works. And with SAM, you use CloudFormation specific features such as pseudo parameters and logical references to reference resources. And we'll take a look at how that works as well. So let's quickly talk about SAM. SAM provides easy to use composite resource types such as AWS Serverless Function and AWS Serverless REST API. A key thing to remember is these are composite resource types and not something that CloudFormation supports out of the box. And SAM uses the feature within CloudFormation known as transforms to translate these composite resource types into primitive types that CloudFormation understands. And all of this happens during runtime. And on top of this, you can also leverage SAM CLI with your SAM applications to test your Lambda application during development, either locally or within your CI/CD pipeline. Let's take a look at how a similar template would look when defined using the SAM framework. So as you can see, I was able to bring down the CloudFormation template to about 57 lines of code, and I have two resources being defined over here instead of the complete galore of resources that I created earlier. I just have two different resources. One is the historical web service handler, which is an composite resource type of the type serverless function. And this has all the properties that are required to expand this into the primitive resource types such as Lambda function, API gateways, API gateway integrations, methods, deployments, you name it. This takes care of everything that you need for the serverless workload. In addition to this, I also have the DynamoDB table that's being defined over here, which is a primitive resource type. If you look closely over here on line 14, I was able to cross-link resources using CloudFormation's logical reference feature, which is the ref functional reference. All right, so let's quickly talk about CDK next. So CDK provides an opinionated framework, programming constructs that you can use to define your API resources as well as integrations with API gateway. So some of the programming constructs that you can use to define resources in this case or for this workload are the AWS Lambda function and the AWS API gateway, Lambda REST API. So after you've defined your CDK application, the next step is to convert your CDK application into a CloudFormation template. And to do this, you leverage the AWS CDK CLI's feature known as CDK Synth. And CDK Synth takes care of converting your CDK application to a CloudFormation template. And this is often known as a Cloud Assembly. And the template is stored in the folder cdk.out. So let's take a look at how your CDK application would look like. So as you can see here, this is my program, this is my stack defined in Python. And you can see I have a couple of resources being defined over here. I have the DynamoDB table, and I have my Lambda function being instantiated over here. And I also have the Lambda REST API being defined over here at the very end. However, you can also see that I'm able to extend resources using methods such as add environment, where I'm adding environment variables such as DynamoDB table name. And you can also look here that I'm able to reference other resources, and I'm able to pass the name of the DynamoDB table as an environment variable to the Lambda function being created here using this helper method add environment. Awesome. So now that we have a good understanding of what was the legacy approach using CloudFormation, and we understand how SAM works, and finally how CDK fits in, let's take a look at how you can bring together SAM CLI and AWS CDK. So in early 2022, SAM CLI extended the ability to test your applications, serverless applications, locally when they're deployed using CDK as well. And some of the possibilities are, the first one being, you're able to test mock a Lambda function. For example, let's say I'm deploying a Lambda function as a part of my application stack, as part of my infrastructure stack. I have the option to use the SAM CLI's command, SAM local invoke, to mock a Lambda function invocation locally. And how this works is, SAM creates a Docker container, and the container uses an container image that emulates in Lambda runtime. And the invocation that you provide is passed onto the container, and the container emulates how the application will respond to your invocation payload. And we'll take a look at all of this in action in just a few minutes. And the second step is, you can also go one step above and completely emulate the experience of the API gateway and Lambda function integration as well. In this case, there are two different components being mocked. You have the API gateway web server, and then you also have a Lambda function. So as you send in a request, you send the request to the API gateway, and the API gateway forwards this request to a mock Lambda function, and you would take, and you finally get a response sent back to you through the API gateway. We'll take a look at how this works as well. You can go one step above this. Then next you have the ability to completely mock the AWS Lambda service as well. So this is useful in the case when you're working with multiple Lambda functions within your infrastructure stack. Let's say you have multiple functions and you want the ability to be able to test multiple functions at the same time. What you could do is you could use the command SAM local start Lambda to mock the Lambda service, and then use third-party or additional tools such as the AWS CLI to interact with this mock service and invoke different functions. And we'll take a look at this in action as well. Awesome. So let's quickly talk about how you can model your pipeline, considering that you have these tool sets in your toolbox now. So considering a very standard pipeline that's built for CDK applications, you have a source stage, then you have an application synthesis stage that synthesizes your app CDK application into CloudFormation templates. Considering that this application builds is deploying serverless workloads such as Lambda functions, you can optionally also have a build stage in between, where you can bundle all the packages that your application needs into a deployable artifact. For example, SAM build can look through your functions code and look for dependency files such as requirements.txt or pom.xml, and can fetch the required dependencies and bundle them into the artifact. Well, so once you have your artifact ready, it's now good for testing. So the next step is to have a testing stage in which you can have two simultaneous actions. One action that we're trying to perform over here is to statically test your infrastructure. That's using the CDK assertions feature. CDK does provide a feature known as CDK assertions that you can use to statically test how your infrastructure templates are being synthesized. For example, if you always want to ensure that the function runtimes being used are Python 3.9, you can have an assertion in place that ensures that the infrastructure template that's generated has this feature, has this property set. If not, the assertion test would fail and your infrastructure would not get deployed. Similarly, you also have the option to use, the next action would be to use the SAM CLI, and this would be to test your actual application that's being deployed. You can use SAM local invoke to mock your Lambda function and verify that its functionality is the way that you want it to be. Once all your testing works out, the next step is to go ahead and deploy this application using CDK deploy. Awesome. So now that we have a good understanding of everything, let's quickly go dive into a demo and see how everything works with SAM CLI and CDK. All right, just give me one quick second while I switch screens over. All right, so let's quickly take a look at how you can leverage the SAM CLI with your CDK application. Here I have my CDK application. This is the project directory, and I have my terminal open over here. Let's quickly take a look at how the CDK application is structured. So if you look at here, I have my CDK application here, and I have this historical weather service stack. And within this, I have instantiations of a few programming constructs. One of them is the DynamoDB table programming construct that's used to create the DynamoDB table. And then I have the Lambda function construct that's used to create the API handler that processes API requests from the user. And this integrates with an Lambda REST API that's created by Amazon API Gateway. So this is a very high-level overview of the CDK application. And so the first step is to go ahead and synthesize this application into a CloudFormation template. The way you do that is to use the CDK synth command. As soon as I hit enter, the CDK would start to synthesize this application into a CloudFormation template. And this would get stored into the cdk.out folder. So as I click open over here, you should see that there is a file that ends with template.json. This is my CloudFormation template. So the next step is to go ahead and work with SAM CLI. So SAM CLI can do a couple of things. The first thing is to build your application. So how I'm going to build the application is use the SAM build command and then provide the template that has my definition for the Lambda function. So here my CloudFormation template is in the cdk.out folder, and it's historical weather service template.json. And as I hit enter, what the SAM CLI will do is it will look where my application code for the Lambda function is stored, and it also looks if there is a requirements or text file or a dependency file within that project directory, and starts to install them for you. So let's hit enter. It found out that my application code is in this folder assets.ad90, and it found out there's a requirements.txt file, and it installs all the packages that I need. However, it does not write to the actual source directory, but it writes to a folder called AWS SAM build, and you can take a look over here. You can see how it's installed all the packages that were required by my dependencies file. All right, so that's a quick overview of how you can leverage SAM build. So let's quickly move into the more interesting part about how you can leverage SAM CLI to test your application locally. The first thing that we're going to do is mock the API Lambda invocation. So when you run the SAM local invoke command, what SAM does is it spins up a Docker container that emulates the Lambda runtime. It also passes in an event payload to the Lambda function and to your application, and your application processes this event payload and generates a response, and that's how it returns the response back to you. So the first command that I'm going to run is the SAM local invoke, which mocks a single invocation of your Lambda function. And let me walk you through the command that I'm running here. So I have SAM local invoke. The first flag is -t, that's a pointer to the application template, which is in cdk.out. And then I have -e, which is the invocation payload that's being sent to Lambda. This I have stored in a folder called tests, events, and event.json. Let's quickly take a look at this. So it's in tests, events, and events.json. You can have it in a different location. This is just convenient for me. And the event payload that I'm sending in is structured this way. It has the zip code and epoch time, and this is something that my API will understand and respond back to this. And then finally, I can also use the -n flag to pass in environment variables that my application needs during runtime. So I have this also in the same folder. It's envars in some of the parameters that my application needs. So now that I have this defined, I can also finally pass in the flag --region US West 2. You might think, why is the region required when this is running locally? So this is to ensure that the Lambda understands where it is, which region it's emulating when it's trying to run. So if you didn't provide a region, it would default to US East 1, but if you provide a region, it would emulate itself as if it was running in a Lambda function in that region. I hit enter, and you can see that it starts to spin up a container and starts to process the event payload that I just passed to it. So you can see that the query string was passed to it, and it generates a response with the weather information. It's pretty cool. So now let's take it one step above and try to test the end-to-end experience of mocking the API gateway as well as its integration with Lambda functions. So in this case, I use the command SAM local start API, and it has similar input parameters -t and -n. However, you can notice that I don't specify a -e. I don't provide an event payload because since this is mocking an API gateway experience, the event payload would come through the API. So I could use tools such as curl or Postman or even a web browser to interact with the API and generate the response that I need. And we'll take a look at how that works. I hit enter. As soon as I hit enter, you can see that SAM local has started a mock web server. This is running on localhost on port 3000. I'm going to bring up another terminal because this is running in the foreground, and I'm going to use curl to query this endpoint. So you can see here I'm using this command curl and querying the local endpoint, a local host endpoint on port 3000, and passing in the parameters zip code and Unix timestamp over here. So as soon as I hit enter, this starts to work with the API endpoint, and the API endpoint starts to spin up a Lambda container, and it generates a response. So this response is returned back to the user as an output of the curl command, and I'm parsing it using JQ. That's pretty cool as well. So now let's take it one step above this, and this is where you can completely mock a Lambda service. So I'm using a similar command, but in this case I'm just going to switch it over from SAM local start API to SAM local start Lambda. So as I hit enter, this would start another server that mocks the Lambda service. This is not mocking an API gateway, this is mocking the Lambda service. And this is running on port 3001. And how do I interact with this? I can use the AWS CLI to invoke this Lambda function. But the key difference over here is when you use the AWS AWS CLI, all the default APIs end up on the AWS public endpoints. But you can definitely override the endpoint that you want to interact with by using the endpoint URL flag and change this to the local development endpoint that we just created. And after you have this done, hit enter, and this would start to create an invocation using that Lambda mock server that we just created. And as soon as I get a response, you can see here that I get a response from the API. This is my API response, and I also over here have the response from the Lambda service. Awesome. I hope you found this was helpful, and this kind of clarifies a little bit about how you can leverage SAM CLI with CDK applications. Now that we've discussed that, I quickly also want to discuss about how you can leverage this in your CI/CD pipelines. So over here, I have the code committed to an Git repository in AWS, that's in code commit, and I leverage code pipeline to set up a similar pipeline that we discussed earlier. So I have my source pipeline, and then I have a build stage that's doing SAM build. Then I have a test stage that's testing my Lambda application and also testing CDK assertions. And then finally, I have a manual approval. And once the approval is done, the operator can release this change to production and deploy this application. So yes, so I hope this makes sense. Please let me know if you have any questions. I'm happy to take any questions after the session as well.
All right. Thank you, Deepak, for that. Really appreciate it. So, don't need these things on, I guess. Okay, so that is it for all of the pre-recorded and live talks today, but we're going to finish off today with a keynote. So I'm going to go ahead and actually put my headphones back on and invite Kendra into our call. Hello, Kendra. How you doing?
Hello.
Great to have you here. Can you introduce yourself to everybody?
Yeah, so my name is Kendra Neal, and I am an engineer on the CDK team.
Fantastic. Well, thank you for joining us today. We really appreciate it. We're really honored to have you here as our closing keynote. I'm going to hand it over to you, and we'll go ahead and share your screen, and it is all yours.
All right, looks good. So for those of you who are part of our contributing community, I am also the real Amazon Kendra. And you may remember me from such hits as, I think this PR needs more tests, and I'm concerned that this change didn't get picked up by any of our existing integration tests. So is there a coverage gap here? Given that, the people organizing CDK Day asked me to come and talk about what makes a good PR and what you can do to get your PRs looked at faster by our team. And I will be watching the questions here because I assume some questions will come up as I'm going. So if I look off to the side, that is what I'm doing there. And I'll try to answer at the end of each section, excuse me. All right, so what I'm going to cover today is what makes a good PR. And then I'll cover who reviews PRs under what circumstances and discuss our community reviewer program. And then finally, I'll cover an upcoming change that will hopefully make contributing significantly easier. So since we likely have a large variation here in contributing experience, I'm going to cover some of the very basic things just to make sure that we're all on the same page. So the TLDR basically is make sure all of our status checks pass, and we'll look at your PR. But that's a very broad overview, obviously. So what does that mean? Let's start with the PR itself. So there's a few checks that we perform on the PR prior to any reviews from us. The first check validates that the PR title follows conventional commits. You can check out that link at the bottom here for more information on what conventional commits is, but it should look something like this. So it's in all lowercase, and you start with the type of the change that you're making, which library you're making the change to, and then a summary of the changes that are being made. Now, the specifics of this are important for a couple reasons. The first is that the type of the change and the libraries changed are going to determine the other requirements that we're going to check against. And second, the changelog is populated from these titles. So we want to keep the formatting consistent so that that looks good. So what do I mean when I say that the type of the change and the libraries changed will determine the other requirements? Basically, every change type, we test against something different. So for a feature, we're going to require unit tests, integration tests, and a README update. And if any of these are not present, then our bot will request changes from your PR, letting you know what's missing. And that will look something like this. So in this PR, we're missing both a README change and an integration test change. For a fix, we require both unit tests and integration tests, but no README change. And again, the bot's going to let you know if any of these requirements aren't fulfilled. Something that I'd like to take a minute to point out about the title of the fix PR is that the summary of the change should describe the error and not the fix. Note how this title doesn't say how I fixed it. It only cites that the error or what the error was. In this case, the error was that inactive lambdas fail to invoke. And my fix here was to use a waiter, but none of that is included. This makes searching for what was fixed in the changelog a lot easier. So regardless of the change type, and those are the only two that we have extra checks against, so just highlighting those two. But regardless of the change type, if a change is made to our CLI package, a maintainer must run the change through our testing pipeline and then mark the PR as CLI intake tested. Our bot will request changes on the PR in this case, as well as the others, but with this message, but there's no action that needs to be taken on your end at this time. A maintainer will run the tests and let you know if any changes are required as a result of the tests that are run. The last check is our build. On a successful build, you'll get a message that looks like this. And if it fails, it'll look like this. You can click through the build logs link to find the reason for the failure. Our entire build logs get printed out, so scroll to the very bottom. It's a massive file, but you can find what the failure was so that you can fix it and then get a review from us. All right, so you may have taken note of the text here saying that you can request an exemption or a clarification. Given the nature of automation, sometimes our bot requests things that aren't actually relevant to your specific PR just because it's titled that way. In that case, you can request an exemption from us. Exemption requests must contain the justification for that request, letting us know why you think those requirements aren't valid. Frankly, when we receive ones that just say exemption requests, I deny them immediately. So make sure to provide your reasoning, because otherwise there's just back and forth and back and forth. You can also request clarification. And if the build, if the build failure doesn't make sense to you, or there's just something you need troubleshooting help with, or if our feedback to you was unclear, then use the clarification request to let us know. And also in this one, provide context. Don't just put the words clarification request, because we don't know what you're asking about. So in some cases, as a result of a clarification request or an exemption request, we might override the checks to allow your PR to go through, but we cannot override a failed build. I've received a few requests from people who wanted us to just merge a PR even though the build was failing, and all that does is block our pipeline. There's automation there. We just can't. So keep that in mind. All right, so the last part of the PR that really matters here, I mean, besides the code, that obviously matters the most, is the body of the PR. If you link to the issue, that will do a few things for us. One, we determine the level of it, P1, P2, P0, based off of what the issue is. Any PR that doesn't link to an issue is automatically labeled as a P2, which puts it down further in our kind of review priorities. So if there is an issue, make sure you link to it, or open an issue if you think that it's really important, and we'll triage that accordingly. The second thing is that when you link to an issue, if you say fixes the number or closes the number, then GitHub will automatically close the issue when the PR is merged. So that helps us avoid clutter or unnecessary open issues. We have quite a lot of open issues, so keeping those organized is, very helpful to us. And then a description of the change. So a lot of times people just link to an issue, and it's very, very helpful when you provide context on what your approach was to fixing this issue or the feature or whatever, and just kind of what your thinking was. It's good to keep in mind that we have over 200 services in our library, and we are not experts on all of them. So often when we get a change, it requires some research on our end, and as much context as you can provide us there will speed up the process of us being able to provide that review with enough information to know, if this is the right change or if we should suggest another approach. So this is a pretty good example of a PR body. It's pretty brief because this one just didn't require that much context, but it does give us context and a link to the issue itself, as well as some other related issues in here. All right, so you may have noticed these labels that show up next to all of our PRs. And the label that's relevant here is admired contributor. So based off of how many PRs you've contributed to us, you'll get some sort of badge here. So there's admired contributor, distinguished contributor, beginning contributor, several more in between. And once you reach 25 or more PRs that are accepted by us, you become eligible for what we call the Community Reviewer Program. So this program was developed to both give more of a voice to our regular contributors, on the code that we accept, and to help our team provide feedback in a timely manner. We found that the people currently participating in this more often than not align with the feedback that we would give in, so it is pretty effective, and it's really helped us scale a bit better. So when do we look at it a PR directly versus when do the community reviewers look at it? The first prerequisite in general is those status checks passing. So everything that I just talked about. So if you have a P2 pull request and all of your status checks pass and the build passes, then you will get an initial round of community reviews. Once they've given their approval, then it'll go to us, and one of the maintainers on our team will then go ahead and review it. If you don't have all of your status checks passing, but you have requested an exemption or clarification, then that will go straight to us. So it's not that you're just plain out of luck if your status checks aren't passing. You can get our attention and get responses from us in those other cases. A P1, regardless of kind of anything else, skips the community review and goes directly to us. And anything that we have already approved, but something might have gone wrong in the merge process, that also goes immediately to us. So if you are curious about joining that community reviewer program, getting 25 or more PRs with us is the threshold. There's not specifics about what kind of PRs you need to do. Just that consistent set of contributing is what we're looking for there. So finally, an update here on our integration test process. So we recognize that the integration test process as a whole is difficult. So because of the snapshots that get merged, there's often conflicts. Running those tests can cause costs to your account. And also, we don't currently require anything more than basically what's on this screen, right? We have the option to add assertions to double check that, the right thing's uploaded and all of that, but it's not required at this point. So what we are going to do going forward is we're working on a process to automate the integration tests running in our system. So you will be allowed to run them all you want on your own, but there will no longer be submitting snapshots to us. You will just submit a file that looks like this with the addition of assertions. Those will become mandatory. So basically, upon an approved review or a manual trigger from one of the maintainers, our integration test will run, and they'll provide you with, whether they succeeded or failed, so that you can now submit code that you're not going to have to incur costs in your own account. We don't yet have a timeline on when this will be released, so I don't want to, say it's coming soon or anything, but it is in progress, and you should start to see PRs that are related to it soon if you're a contributor. So I wanted to, I didn't, overload this because I really wanted to provide some time for Q&A. So hopefully you have some questions because there's quite a bit of time left. So in the chat, any questions about any of this? Besides, will you go look at my PR right now? I will not.
All right, so while we take a look and hopefully get some questions in, I do have one personally myself. So you've covered a ton of stuff in here today. I assume this is all covered in the contributing doc within the repository?
Yes, yeah, everything is in the contributing guide. So hopefully you have read it because it is one of the checklist things on our PR submission.
Yes.
But there's a lot in there, and it changes every once in a while. So just wanted to highlight some of the things that get missed.
Gotcha. And what would you say are some of the common issues contributors run into that may make it either difficult for you to accept their PRs or difficult to follow the process?
So I think one of them that I did kind of call out here was the requesting exemptions or clarification without kind of telling us why. And I think our integration tests really are kind of a barrier to contributing for a lot of people because it's not always clear. I think we could improve our documentation there. So, we have raised our requirements in the last year for, always having those tests there, and we provide exemptions a lot less frequently. So long-term contributors probably have noticed that, we kind of made that bar of entry higher and a little bit more difficult. But for the sake of, our own deployment safety, we've found that it really is necessary to have that. I think the other thing is that there's a lot of things that look very simple and, a one-line change to a contributor, but they don't necessarily realize that on our end, it could have a lot of unintended consequences. So there's a lot of times where people are like, this is just a one-line change. Why do I need to add a test? And probably the most catastrophic issue that I have caused in our repo was as a result of a one-line change that I was like, this is nothing. So I'm very hesitant to ever just say, you're right, it's simple, no big deal.
Gotcha. So I know that there's been talk of the contributing office hours. So that there's some consistency among that, is there a place where these office hours are posted? We see them in the cdk.dev Slack server, but not everybody is available there. Not everyone's paying a lot of attention. Is there some other place that people can go to see these office hours and sign up for a slot in them?
So right now, that is the only place that we've been posting those. We've been running that kind of as a trial to see, if it was effective for our contributors, if they actually liked it, if people actually showed up. And I haven't taken a huge part in those, so I'm not really sure what the outcome of that is. But if there's other places that, people would like to see those office hours posted once we kind of settle on what that's going to look like long term, then, we're happy to take suggestions there.
Okay. One thing that I can toss out there is I think we could probably also make it available on the cdk.dev website if we can find a place to put it over there. But any sort of good communication as far as when these are, I think will make it better, because I know a couple of times those messages have gotten lost in my unreads in Slack, and I miss going to them because I just didn't know that they were available. So some good consistency there would certainly help there on the communications standpoint. Anything else that you'd like to sort of communicate or touch on before we wrap this up for the day?
So I see
yeah, I just saw that too
in here. So so is there a special process for contributing L2 constructs for a library that doesn't have any existing? So the answer to that is yes. If you're in the cdk.dev Slack channel, you very likely will have seen my message saying that we are putting the RFC process on hold for the moment. So for new L2s, we do require or have been requiring an RFC. We have realized that process isn't really working quite how we want it to, so we're working on revamping it. I don't have an answer for what we will be doing going forward just yet, but we are actively working on that. And the reason that there's been, kind of a lag there is that we don't want to just throw out a new idea and cause a lot of churn. Like, we want to get it right because we respect the time of our contributors. And so we don't want to just switch that every few weeks and cause confusion. So
gotcha.
We'll have an answer to that soon.
And for those who aren't aware of it, can you kind of describe what the RFC process was trying to do and what an RFC process in general is?
Yeah, so for L2s, the RFC process was really to nail down the contract, right? We didn't really care about the inner workings at that stage, but to look at, what are the use cases, what is the user experience here, and get an agreement on that prior to people starting code. And the reason that we moved those in that direction was because the amount of code required for a new L2 is a lot. And the longer that your PR is, the less, it just in general, not for our team, but in general, the less quality review you get. So we wanted to break off some of that so that we could pay more attention to detail in the right places at the right times. And often when people would submit PRs, besides them being really large, we would have some pretty substantial changes that we would suggest to it. And it was just a lot of back and forth, a lot of churn, so much rewrite for the contributor that we were actually trying to minimize that. Unfortunately, I don't think that the RFC process itself has really translated well for getting that design and that contract. So like I said, we're trying to improve that because the RFC in general is more a working backwards document for our entire ecosystem, not just the CDK library, but for like proposing, any kind of new idea that you have, right? And so you'll look at, what are you proposing? How does this serve customers? It in the context of L2s really didn't need to include a lot of technical design, but as it stands was not the best fit for those L2s. So yeah.
Gotcha.
Yeah, and if you we have a repo for RFCs. It's I think it's just CDKs-RFCs. If anyone on my team is here and knows I'm wrong about that, please correct me, because that's off the top of my head.
I think we can find it real quick. Let's see what we can do.
Let's see. So there's a question here. Is there a chance we will see more contributions from AWS teams, having more service teams own L2 constructs for their service, or even releasing them the same time as going GA? So we do have some service teams do that. Given how contributions on GitHub works, you often can't tell who is AWS and who's not. So a lot of our contributors are already working with us from service teams. And there are times where service teams work with us for a simultaneous launch. That happens especially around like the reInvent time period. So that gets very busy for us. But yeah.
And we're at that time.
What was that?
And we're at that time right now.
Yeah.
I imagine everyone over on AWS land is probably running around crazy right now.
Yeah. Let's see. So there's a question here. Do you plan to have an SLA on how quickly we get a review from the core team? So there's a number of factors there. So we don't have one that we publish. Like I said earlier, that it may need to go through the community reviewers first, and it needs to pass status checks. So there's nothing that we specifically publish, but the very, I guess, unsatisfying answer is as fast as possible.
Gotcha. Great. And someone shared with here it's the AWS-CDK-RFCs repo. So if you're looking to see what's currently there and how the RFCs have been working, I guess that's a good place to go to it. All right, so we'll give everyone just another second if there's any other questions. But probably not. All right. Well, thank you very much today. We really appreciate you being here and helping us. There's been this very this theme through today that when we're talking to AWS and when we're hearing these talks, there's a lot of effort being put into this contributing pipeline and how to get this into a better stance as far as PRs and changes. How can people contribute to it? I think there's this overall feeling. We saw this in the community survey that we do every year, of that it's tough. And it is. I mean, the CDK is a massive code base. It is a mono repo, which always adds in complexity, and there's a lot of difficulties there. But between a couple of the talks today and what you're talking about here from a process standpoint, I'm really hoping that when we run this survey again next year, we'll see that hopefully that headache that goes with contributing goes way down.
Yeah, I very much hope to see that. And, some of the automations that we did put into place this year, I will say, if it closed your PR when it shouldn't have, that was not intentional. Please reopen it. We will look at it. Some of our bots got a little aggressive and we had to make adjustments. Please continue providing feedback about the contributing experience, about the automations that we're doing. If it causes us to miss things, we really don't want to, but nature of automation, sometimes things slip through. So looking forward to trying to continue to improve that.
Gotcha. Well, thank you very much. We really appreciate it today, and we will see you next time.
Yeah, thanks.
All right, so we are, that's it. That's all for CDK Day 2023. I hope everybody enjoyed it. I wanted to bring our wonderful interpreters back on. These guys have been champs all day. We got started 7.5 hours ago. 7? No, yeah, 7.5 hours ago, I think it is now. Am I doing math right? I don't know. I've been awake for 7 hours. But it's been a fantastic day. I want to say thanks to Western Interpreting Network and Danielle and Arthur here for providing this fantastic interpreting all day long. We really, really love having them here and being able to provide this. We want to say thanks to AWS, who's made this possible for us to bring these interpreters in, as well as HashiCorp, who is also our other sponsor. If there's any further questions, the CDK.dev Slack server, we have the track channels, the CDK day-track-1 channel, to track 2 and track 3. You're more than welcome to spend the rest of the day in there asking any questions or anything about the talks that we had. Otherwise, thank you all for coming. We really appreciate it, and we will all see you next year. Bye.